Welcome everyone to this Virtual Azure Community Day, the December edition.
Yeah, because we can't talk about winter edition because in some parts of the world it's definitely not winter season.
Exactly, but it's everywhere December. So
it's here though, I don't know about you, but definitely.
Exactly. Nice socks, sweatpants, we are totally ready for it, right?
Exactly. We're knitting, for when we have to go outside again. Should be warm.
Yeah,
and cozy.
Hopefully when it's warm. My name is Mark Duiker. I'm an Azure MVP. I work as a consultant for Spirit, and I'm a big serverless fan. You might have seen me as a co-organizer of Serverless Days Amsterdam, or maybe you recently joined in on Azure Functions University, which I'm doing with Gwyneth, also one of the community members. And today I'm very happy to be a host here for Virtual Azure Community Day.
Absolutely. My name is Floor Drees, and I'm a community advocacy program manager responsible for Western Europe at Microsoft. And we're hosting this thing together.
Yeah, but it's not just the two of us, right?
It's not just the two of us. There's a lot of people behind the stage, or behind the cameras that we're looking at, and a lot of volunteers who spend their time making sure that we have wonderful sessions today, and making sure that we can actually do this here today, and also have our teas and our coffees and everything that we would need.
Exactly. All right. So people are joining this on hopefully on the website, right? Azure.Community. And they can also interact with us there, right?
There's live chats on either side. I don't know.
Yeah, exactly. So, and if you want to interact with us further, there's also, they can reach us via Twitter, I think.
Definitely. We have a hashtag VACD. That should be easy to remember. And so if you are joining us from your living room or your work from home office or anywhere, really, share a picture with us. And we invite you in our living room, so,
Exactly. Yeah, we would like to see something back. That would be nice.
That'd be nice. That'd be nice.
Okay.
I'd be curious, but I'm a curious person. How about you?
I am a very curious person, definitely. And what I'm also curious about is the challenge.
Right. Yes. So there's, people that like a little bit of competition. And so we have a little competition running, and I can actually see this. There is a link there. See? It's the aka.ms/VACD-challenge. People can go there and sort of like register and start completing challenges or modules on Microsoft Learn. And there's prizes to be won, I believe.
Ooh, okay.
Did you hear about that? Or do you want me to talk about it?
Yeah.
You definitely want me to talk about it.
Yes.
All right. So you complete the modules on Microsoft Learn, and then you will show up in some sort of leaderboard. And we'll pick 10 winners randomly, of course. Like, we have no stake in this, so there's no sense in bribing us on Twitter or anywhere. It's randomly chosen. And you'll receive a Azure care package. You do need to claim the care package though, so you have to complete the modules until December the 12th, and then December 14th we'll have listed the winners on the page that is azure.community/challenge.
Yep.
Yes, exactly. And then you share your details with us, and then we can send you your care package.
Cool. We also have a code of conduct. It's on the website, so azure.community, and then in the top right corner there's the code of conduct, so please familiar yourself with our code of conduct and follow all of the rules and be kind to one another.
Absolutely, that sounds good. And that goes for people interacting in the live chat, but also on Twitter.
Exactly.
Cool. Well, I think we should get started, shouldn't we?
I think so. I think we covered all the admin.
Yeah, the house rules.
Yeah, exactly. Yeah.
Right.
All right. So at the last VACD, someone here in this room challenged our next speaker to dive into GitHub Actions. I wonder who that will be. I think the speaker will hint to that. It turns out that she really likes a challenge, and she's here to add another chapter to her book of Azure Automation Adventures. It's Esther Bartel, Solutions Architect at Cognition IT, and she will show you all about GitHub Actions. Esther co-founded the Citrix user group Community Women in Tech mentorship program. She's a Microsoft MVP for cloud and data center management, and she's awarded Citrix Technology Professional. Wow, sounds cool. Esther, welcome to our show.
Well, thank you for having me and for allowing me the opportunity to be the first speaker of today.
We're really happy to have you.
Awesome.
The floor is yours.
Okay, so I'll start sharing my screen and then we can have some fun. So as I was already introduced perfectly by Mark and Floor, I'm gonna dive into GitHub Actions today. Just to make up for a little bit of time, because I wanted to pack the presentation with a lot of demos, I'm just gonna skip through all the let's get to know Esther parts of this presentation. So as he already mentioned, doing community programs and mostly focused on DevOps and automation. Used to start with automating Windows and Citrix deployments, moved to cloud for the last year, and using REST APIs, JSON, and PowerShell. So today I want to focus on cloud DevOps, GitHub Actions, and Windows Virtual Desktop, because that's currently my end user computing environment that I want to automate and deploy, as you can see. And I promise to include some demos. First of all, cloud DevOps. Is there one tool to rule them all? Basically, that's the idea that I started with when I switched or dove into DevOps. But if you look at the definition of DevOps, it's mostly a set of practices. And that basically means that even though I translated it to certain tools like PowerShell scripting, using Windows Virtual Desktop for deployment and operations. And I started with my Azure DevOps adventure as well, to make sure that I fully understand and could embrace the whole DevOps culture. And as I mentioned, this demo or this presentation will mostly focus on PowerShell and Windows Virtual Desktop. But I did quickly realize, if we're talking about DevOps, we're talking about a lot of different tools for a lot of different stages in the entire DevOps process. So basically, there is not just one tool to rule them all. It's more, in my opinion, all about the journey or the adventure that you can have and the fun that the journey brings in automating and taking on some challenges. And if we're talking about challenges, I definitely have to go back to the previous edition of the Virtual Azure Community Day in July of this year, where one simple question basically started a whole new adventure for me. So the last time I already talked about Azure automation, how I'm building custom ARM templates using the Azure PowerShell module. Diving into Azure automation, and even tiptoeing Azure DevOps. And then there was this one question at the end of the presentation. So what about GitHub
definitely
Actions?
Check out GitHub Actions as well and get back to you on my experiences.
Awesome. So maybe for the next Virtual Azure Community Day, we can have you back on again and you can share part 2 of the story.
Oh, that would be awesome. I would love to do that.
Yeah, that's the deal then.
All right.
It's being recorded.
It's recorded, so it's real. Yeah,
Yes.
exactly.
Yeah.
So
welcome to part 2 of the Cloud DevOps Adventure. So let's dive into GitHub Actions, because I love a challenge and I definitely took on this challenge. So if we're looking at GitHub Actions, it's a tool that will help you automate tasks within your software development lifecycle. And I do have to admit that I'm more an operations girl. So for me, I'm still kind of finding what tooling and what processes to use for my infrastructure as code development. But the cool part about GitHub Actions is that they are event-driven. So you can run a whole series of commands after you specify the event that will trigger the workflow. So zooming in on GitHub Actions, it all starts with that event, a specific activity that triggers a workflow. And that can be a webhook or scheduled or even a manual trigger. And the workflow itself can contain one or more jobs. And each job is a set of steps that you execute on the same runner. So that basically sets up your environment. And if we're zooming in on the steps, these can be individual actions or. And if we're zooming in on the smallest part of GitHub Actions, we're talking about actions. And you can either create your own actions or you can use those provided by the GitHub community. And the other thing that we need to know is that the workflow syntax for GitHub Actions uses YAML. So that's something that you definitely need to dive into. And of course, there's to get you started with GitHub Actions, you can put your YAML workflow files in the GitHub/workflows folder. And this means that those workflows will be automatically picked up by GitHub automation. And I'll show you how that works in just a second. I did intend to include an entire YAML speed course in my presentation, but as I wanted to make sure that it was fully demo packed, I'm just going to skip through these slides real quick, ask you to freeze the recording for a second to really read over them, and then just assume that you finish your speed course in YAML. Because I want to focus on what the real fun is, those workflows, and how you can build your own GitHub Actions workflow. For instance, in my case, to deploy your Windows Virtual Desktop environment. First of all, I mentioned that actions can be either created by yourself or can be community actions. There's a whole GitHub marketplace that offers over 6,000 already pre-built actions. So please check it out before you start diving into creating your own actions, because for what you have in mind, there probably is already an action available. The other thing that you need to be aware of when you start with GitHub Actions is that you can use the secrets. And secrets are configured within your settings and allow you to import sensitive information in an encrypted manner in your GitHub Actions. So this makes sure that you're not exposing any secrets, security information straight in the workflows. And there is a special secret that I wanted to get your attention on, and that's the Azure credentials one. And I'll show you in a minute where to use it. But the cool part about it is that you can copy your JSON information file when you create your service principal for Azure. And use that information, use that JSON string in your secret, and that will automatically be picked up by a login Azure action. Zooming in on Windows Virtual Desktop, and I do realize that not everyone has infrastructure or end user computing background. So to make sure that you all understand Windows Virtual Desktop, I will include a little crash course on that one. So Windows Virtual Desktop mostly consists of a part that is managed by Microsoft. We usually refer to that as the control plane. And of course, there's this part that you control within your own subscriptions. And that is mostly focused on desktops and remote apps, because you want to make sure that you have your session hosts available within your environment to make sure that you can send that virtual desktop or that virtual application or remote application to your end users. So these demos today will also focus on those Windows Virtual Desktop components, the session hosts and the host pool that contains them. And if we're talking about Windows Virtual Desktop and creating a host pool, especially when it comes to those session hosts, there are two parts that you have the most influence on the configuration. And the first one is your virtual machine size, which you can select any virtual machine sizing that is available within your region. But the other cool part is that you can specify the image that your session host will be based on. And this can be a standard image provided by Microsoft through the gallery, But it can also be your own custom image that you have uploaded to the shared image gallery. And this is where I'm going to focus on first in the demos. Because I discovered that Azure, even though it's just, well, it is already a public preview and will be GA pretty soon, Azure provides the Azure Image Builder service that allows you, based on a template, to build a custom image automatically and then share it or distribute it to your shared image gallery within Azure. And this allows me to have a separate process to build my custom image and then continue the automation with the WVD deployment. So let's dive into GitHub Actions and check out which community actions I'm using with my WVD deployment automation. First of all, the build Azure Virtual Machine image action. And this directly connects to Azure Image Builder. And that allows me, if we're looking at the definitions file, which usually is your action.yaml file, you can see the kinds of input that I can provide with this action. First of all, I can specify the managed identity that Azure Image Builder will use within my subscription to create the machines and the images. Next up, I can specify all the source information like OS type and the actual image that I want to use as my source. For customizations, I can specify not just an entire folder or directory that I want to put on my runner for usage, but I can also specify which customization scripts I want to run. And last but not least, I can also specify where to distribute the image to once it is created by Azure Image Builder. And the action itself gives you some output back, so you can easily know where Azure Image Builder created your image. Next up, I'm going to use the Azure Login action. And as I mentioned before, this allows me to use that specific Azure credential secret, because this is the action that will quickly log me on to Azure and build my session. So I can use additional actions for follow-up actions. So as I mentioned, it's using that credentials special secret. And I can also use a predefined action to run Azure PowerShell scripts. And this will come in handy because in the process before using GitHub Actions, I already built some PowerShell scripts that allow me to use ARM templates to deploy Windows Virtual Desktop components and settings. And last but not least, there's also a GitHub action checkout that allows you to make sure that your GitHub repository is available on your runner, and you can use that and reference to it. But I do know that that's a lot of information. So let's try to make it a bit more practical and show you how I built my first workflow YAML file for GitHub Actions to automate my image creation. And as I mentioned, or as we're looking at my workflow file, I'll quickly go over that because I do want to go to the fun part. First of all, I had to specify an event. In my case, for demo purposes, it's easiest to have a manual trigger, but you can also automate it by using a push or a pull request. Next up, I'm using the environment section to define environment variables that are configured on the runner, because this allows me to basically provide dynamic input data for my action, which ensures that I can run this action multiple times and still have the required parameters set for my runner and use that within additional scripts. I'm going to specify to run it on Windows, but that's just because that's the platform that I feel most comfortable with. And as I mentioned before, this will use the Azure Image Builder action that is predefined. Specifying my source information, my customization, and the distribution type. So let's see how this action works. First of all, I'm just going to show you that currently in this Azure subscription, I do have an image, shared image gallery. I do have an image definition, but there's no versions or no images uploaded yet. So this is where my workflow comes in place. So I already showed you some of the examples, but this is just naming it, making sure that it's manually triggered by the event, setting up the environments for my action environment, zooming in on the jobs. As I specified, it's running on a Windows runner. And the first action that I'm using is to check out to make sure that my GitHub repository is available within on the runner. Using Azure Logon with the special secrets, and then going for the fun part, using Azure Image Builder action to make sure that I'm using a Windows 10 multi-user session with Office base template, and then adding those customizations to it. And last but not least, distributing it to my shared image gallery. And of course, I do have to specify which image definition I want it to be uploaded to within my shared image gallery. And I'm using the environment variables to make sure that I can dynamically reuse this workflow by just changing the environment variables. So if we're going to GitHub, you'll notice that in the .github/workflows folder, I now have that YAML file available. And if I go to the Actions tab within GitHub, that same YAML file is available as a workflow. And I can easily select it. And in this case, I can do a manual run of it because I specified that as the event trigger for this workflow. The workflow is started. So the job that is inside my workflow is now queued, being processed. So we can zoom in on the details of that job. And I fast forwarded it just to make sure that we're not sitting here for the entire session watching the action happening. Check out, log into Azure, and then the Azure Image Builder action kicks off. And we can kind of follow the process of how far Azure Image Builder already is by zooming in, checking for hidden types in our resource group, and seeing if it's created its own temporary resource group. Because this is where Azure Image Builder will store all the temporary virtual machines and settings that it's using to build that image. Just a quick overrun of how the Azure Image Builder process works. First of all, you create your JSON template. That template is submitted to Azure Image Builder, and then the template will be used to run your build, your VM build, or your image build. And once it has built that image, depending on the output, in our case, it will push it to the shared image gallery. Going back to my action, as you can see, it does take quite some time for Azure Image Builder to build that image. And this is me just getting nervous and double checking if everything is going as planned. So if we're now zooming in on our image definition in the shared image gallery, it's showing that it is creating an image there with a specific version. And you can even see that in that resource group, some of the resources changed and the virtual machine that it temporarily used is replaced by that image. So if everything goes right, Azure Image Builder should be finished up pretty soon, or at least I should have forwarded the video to the end results. So fortunately for me, everything went successful, and I can even check out details of the different steps that were performed. So one of the things that Azure Image Builder Action tells you is the name of the template. So that makes it easy to ensure that that template was created. Once again, going back to the resource group, checking hidden types, and then that template, image template is available. So you can even reuse that in follow-up calls. Scrolling down to the output that it generates, first of all, it will tell us whether or not the template was built successfully. And of course, it gives us the URI to that image that is distributed. So just double checking, because we already saw that it was creating that version. And now we can actually see that it indeed is succeeded. So that's basically my first hello Azure Image Builder world action. And I'm pretty cool that I got the result that I wanted in basically quite an easy way by using that pre-built community action. But this is just the first step, because as I mentioned at the beginning, I want to automate my WVD deployment. And specifically, I want to be able to automatically create a host pool and use that just created image for my session host within that host pool. So I also created a new workflow for the creation of a WVD host pool. Once again, using environment variables. And instead of using a pre-built action for an ARM template deployment, I wanted to have more flexibility in the actions that I'm performing. And basically, by using the option or the pre-built action for Azure PowerShell scripts, I can just reuse that script that I already created and copy that as an inline script for this action. And this script will read those environment variables to get the input automatically. It will create a template parameter object so that I can use that with my ARM template deployment. Let's just look at the action. So first of all, this is Windows Virtual Desktop, and I'm checking the host pools. There's already one, but I want to create that HP-WVD-CIG host pool. So that's what my action is going to do. Once again, it's going to be run manually. And as you can see, this is the naming of the host pool, the number of session hosts to create within that host pool, etc. So first of all, as I mentioned, I'm directing it, or I'm going to use that shared image gallery image definition. Then zooming in on the jobs, once again running it on Windows because that's where I feel most comfortable, using the Azure login action, using the Azure PowerShell action with that inline script. And just going over the steps real quick. So once again, it's gonna read the environment variables, retrieve even my sensitive information from key vault. I even specified a postfix in this case, and then I'm specifying all the input parameters for my ARM template deployment with a template parameter object. Making sure that I'm pointing to the right image definition. And because I'm not adding a version to it, it will always pick up the latest version. And my ARM template is also stored in GitHub. So I'm making sure that I'm downloading the latest version of the template from GitHub on my runner, and then I run my ARM template deployment. So that looks like a pretty good reuse of my already tested PowerShell script. So let's check out GitHub again. So as you can see, the YAML file is there, so I can easily select that workflow and use that manual trigger to once again start the workflow. So once again, it's queued, and then we can zoom in on the progress of the job. Logging into Azure environment, and then running my Azure PowerShell script. And because we cannot see the progress of that script while the action is run, I'm just double checking within Azure to make sure that the ARM template deployment is actually started. So this is just me making sure that everything is going as planned in my WVD environment and deployment. So this is the virtual machine or the session host being created. And that means that my deployment should be finished just about now, hopefully. So yes, that's good news. Once again, I have a GitHub action performed successfully. So what does this mean? So it should by now, as I can see, the deployment is completed. It should have created my WVD environment. So I should have a new host pool, check. It should contain one session host as I specified in my template, so check. And it should also have an application group created for the desktop and to make sure that users can connect to that remote desktop. And just to make sure that I can immediately test access and the content of that desktop, I'm just going to add one of my Ninja helpers and then assign it to this desktop publication. So he should be all ready, or she should be all ready for some testing. And I'm making sure that I add a friendly name to my workspace, because that will make it easier to find your right environment within the remote desktop client. Talking about the remote desktop client, that's the easiest way to connect to your remote desktop. So as you can see, I already asked my little ninja to help me out and to set up the remote desktop client. So it now has access to that virtual desktop and can start it after authentication. And as you can see, or at least as I immediately see, my customization scripts ran successfully with the Azure Image Builder process. So, and that added Notepad++ and Acrobat Reader to this image, which is not standardly provided by Microsoft. So for demo purposes, once again, checking if my customizations were actually copied to the local disk of the runner or the environment that Azure Image Builder created. So now I automatically can create an image, update an image, and use my WVD deployments to automatically have a full environment. So one of the other things that, and I'm double checking if I have enough time for this. So one of the things that this allows me to do is, as I mentioned before with the creation of the host pool, is that I can specify an image definition. And if I don't specify a version, it will always use the latest version. And this allows me to basically keep that action separate that builds my image, because I can use it to rebuild a new version of that image, and then use an ARM template deployment to add additional session hosts to my host pool. And these session hosts will be based on the latest version of the image. So they will have a newer image available. Once again, I'm using a PowerShell script for the ARM deployment to make sure that I can run that. So I'm just quickly going to run this demo video as well. So this is to show you that I already used that image builder to create a new version of my image. And it only has some slight adjustments. Going back to the host pools, making sure that you see proof that there's currently only one session host available. And in this case, I'm gonna, for demo purposes, already change the drain modes. That does not allow any new connections to this session host. And this will ensure that I can fade out or phase out my current session host with an older build image, and then introduce and activate those new session hosts that I'm gonna create within my host pool that will be based on the latest image. So once again, using Azure Logon and that inline PowerShell script, which will use basically the same mechanism. So it's reading environment variables, but in this case, I want to reuse the information of the host pool and the session host that is currently available. So I can build a more dynamic script that will have the latest details without me having to specify that. I'm even retrieving the VNet information and subnet information because those are input variables for my ARM template. Once again, creating a template parameter object, but this time I'm using all that dynamically retrieved information. And I discovered that there are different parameters that you need to specify whether you're using a gallery image or your custom image. So I'm taking that into account as well. As I mentioned previously, the ARM templates are on in my GitHub repository, so I'm downloading it to make sure that I have the latest version, and then using that with my ARM template deployment. Once again, using the latest AZ model. So this is the last workflow in my GitHub environment. And as you can see, it's once again directly available. So I can once again manually start it for demo purposes and zoom in on the action once it is in progress. Logging into Azure and then running that ARM template deployment again. So the only thing that I do miss is the direct feedback that I get with Azure DevOps. But as you can see, I know my way around Azure. I know where to look for the different tasks that I started. And I do know that I can keep track of my ARM template deployment through my resource group. So this is creating that second session host. Once again, joining it to the domain because that's required for Windows Virtual Desktop. And it's pushing some additional components like the WVD agent. So the job is finished. We can see that as well with the deployment information within Azure. And if we now go back to that host pool, it now has two session hosts. One of them has drain mode on, and the new session host is immediately available with drain mode off to accept new sessions. So asking my Ninja once again to test my virtual desktop. Authenticating. And I do have to maybe do a quick disclaimer that I did not make a lot of customizations in this new image version. So it's a new image, so I do get a new profile in this case. And as you can see, I basically mostly changed only the background image in this deployment. And just to show you that customizations folder is once again copied, you can see that it's always using the latest version from my GitHub repository, because in this case, I added the new desktop in the background. And this is the script that was performed creating the installer. That's the customization script, the PowerShell script that I ran. So basically, I figured that this was a good show of my little GitHub Actions adventure and a nice addition to my entire cloud DevOps adventures. And I wanted to make sure that I not only present my results, but make sure that for those of you who are interested in automating your WVD environment, that I kind of what I like to call create a GitHub repository with a starter kit for WVD automation. So feel free to check out the repository, because it's not only containing the workflows and the demo scripts and the scripts that I used in this demo, but it will also contain all the PowerShell scripts that I'm using with the Azure module. I will upload those and keep those up to date. But I also focused on direct REST API calls. So I included configuration files to pre-configure your Postman environment and the PowerShell scripts that I'm using for those direct API calls. And I think I made sure that I finished right in time. So there should be still time, first of all, to say thank you and to wish you a wonderful virtual Azure Community Day. And then check in if there are any questions.
Die camera.
Die camera.
Die gezamenlijke, toch?
Thank you, Esther, so much. Also a question, because I was trying to, type that URL. Could you post it in the chat later on? So
yes,
that we can
I will
share
definitely do that.
Because it went a bit too fast for me, because I was still grabbing my laptop like, oh my gosh, I need to grab this. But thank you for creating that for people. That's a huge help. Also, I really appreciated the sort of quick run through YAML. I think it could have gone a little bit slower for my co-host here.
Yes, because while I'm knitting, I'm now playing also the YAML course now, putting it on hold. So yeah, I'm definitely going to rewatch this.
Maybe learning too many things at the same time,
yes,
Mark. Maybe
exactly.
you should prioritize.
I can't multitask.
I'll make sure that I upload the PDF of the slide deck as well, so people can just
That'd be
not
wonderful.
have to pause the recording to get that speed course on the YAML syntax.
Awesome. That is great. If you could share that in the chat and on Twitter as well, and we'll make sure to retweet it so that nobody is left out and everybody can get started learning this. This has been really cool. So just because obviously a lot of the questions were about the shakedown for you, because you've done this for Azure DevOps and pipelines, using pipelines and now GitHub Actions. So if you needed to do a shakedown, which one would you rather use, or maybe for which use case does either fit better?
Oh, wow. So I'm convinced that the whole DevOps experience or the whole DevOps journey is all about finding those tools that you feel most comfortable with.
Yeah.
Mm-hmm.
Because I do not believe, as I mentioned at the beginning, that there's one tool to rule them all.
Definitely.
Love those references. I will not repeat it again. So for me, as you can see, PowerShell is still the most comfortable scripting language for me. Using a Windows environment is the most comfortable environment for me. And if I look at my Azure DevOps experience, I felt very comfortable using the GUI and only using the release pipelines. But now I'm a YAML expert. So
Wow. I need to go in training with you. Yeah. Okay. Excellent.
Maybe I'm just a Google expert and know how to document things.
Well, aren't we all?
Not
really?
sharing all secrets today. So for me, I do have a slide included that compares GitHub Actions and Azure DevOps pipelines, but I kept it hidden due to the time. The only advice I have is just try out different tools and find those tools that you feel most comfortable with to support the translation of manual tasks or manual workflow to an automated tasks and workflow.
Great. I have one more question.
Okay.
Am I allowed? Am I allowed time-wise?
Yeah, sure. Do it.
So you mentioned that there is a lot of actions that already live in the marketplace on GitHub, and that you should probably check those first before writing your own. I think solid advice. Is there an action that you found and you were like, that's curious, like who would ever need that? Or the funniest or weirdest action that you came across?
I have to admit that I was very focused.
So you're so professional.
I was time pressured to deliver this challenge. So I did not check out all 6,000 and more actions.
You did not?
Now.
No, that's not research. That is.
Could that be something for a next VACD?
Could that be something for a next VACD?
So let me record this and then make sure that I kind of earn my next spot on the next virtual community.
This is like a never-ending story. That's great. So to use Susanne's words, deal. Done.
Awesome.
So we have at least one talk for the next VACD. Apparently we're doing a next VACD. So there you go. You heard it here first. Thanks.
How to find curious actions in GitHub Actions Marketplace. Perfect.
I love it. I think it's a great title. Done. Yeah. All right. Thank you so much, Esther. I'll try and recover while we invite the next speaker to the stage. Because from GitHub Actions, we'll talk about containers in Kubernetes next. Wesley Hackman is going to join us. So containers and Kubernetes are this like shiny thing that developers are attracted to, and they all want to use.
Because of YAML, of course.
Obviously, which is also your fave thing in the world. Yes. And that often leads the ops department to deal with a platform that they're not too familiar with. And to sort of combat that and to give ops the fundamentals and the tools in hand to make sure that they can actually operate these things is Wesley Hackman, who is a Microsoft Azure MVP, also a lead Azure architect at Intercept. And then there were a lot of acronyms that followed. He's also a Microsoft certified trainer and also a certified information system security professional. Just rolls off the tongue. And you will give us the fundamentals, right, on containers and Kubernetes. So there you go. Whenever you're ready. I love your background.
All right, thank you.
Good
Thank you. Good morning, first of all. Thank you for having me. So my name is Wesley, lead Azure architect at Intercept, a bunch of certifications. Also, I'm definitely with you on the YAML thing. I have an ops background. YAML was never my thing, and it probably never will be, but we have to deal with it. So that's what we're doing.
I feel like this is going to be a red thread to the day. Threads, get it? Yeah.
Totally. Yeah, so
Wesley, please take it away before it gets any worse.
So what I want to do today is not so much a deep tech demonstration. I want to take people with me on the story that I've experienced with customers, with people in the community on what we see with Kubernetes. So is it a developer-only thing? Is it an ops thing? Who's being left out? I do have a bunch of unpopular opinions, so warning beforehand.
It's a content warning, this.
Content warning, no developers, no ops were harmed during the making of this presentation, but I think it will make up for a good story, and just want to share my view on the world of Kubernetes with everyone.
Cool.
Awesome.
Go ahead.
Let me share my content.
Drop the needle.
No.
No?
No.
There we go. Yeah, so my section was named or is named Help Our Developers Are Using Kubernetes. Why is that? Because that's what I see with a lot of organizations happening. People start using Kubernetes, then it goes into production, and then what? So where do you go from there? What are the problems you're going to face? And was there maybe a different way you could go about this? So we already talked about me. My name is Wesley. If you've got any questions, obviously you can put them in the chat. If you've got questions afterwards, send me a message on Twitter. I'll be happy to help you, happy to respond, happy to share my opinion. And then the agenda for today, we're going to look at a common scenario. We're going to look at the problem. And of course, we're going to look at the solution and give you some tips and tricks and advice on using Kubernetes and what you need to take into account when your organization starts using Kubernetes. But like I said, friendly content warning. I do have some opinions. No offense to anyone. No devs or ops were harmed during the making of this presentation. So before we start, we go back to a more basic question or a basic problem in organizations or a culture thing, if you will, and that's the dev versus ops thing. And if you start using things like container technology, and those containers need to run, so you need orchestration. So of course, you're going to deploy Azure Kubernetes services. Then who's going to manage that? And what I see is that dev versus ops problem becomes more evident when you start using things like container technology, because it feels like a really big gray area, but eventually it's not. So that's what I want to talk you through today. Let's first take a look at the worst case scenario. And I'm not saying that this is bad for everyone or this is the default scenario, but it is something you can come across or maybe will feel a bit familiar. So how it all starts, developers start using container technology. They've written an app, maybe they tried app services, maybe they've got some stuff running on-prem. And then they want to scale it, and then they want to have a better technology that's maybe faster, that scales better, that gives them more capabilities to do what they want. And Kubernetes is really accessible to developers, and container technology also is. So they usually start using container technology, they dive into it, they start using it, and then the ops team is like, wait, what's happening here? What are you doing? And then usually because the developers already invest a lot of time in using container technology, they're like, well, don't worry about it. We got this. We will deploy it. We will see what happens. And then we go, well, popular meme, like a few moments later, a few weeks later, that's when the problem starts, you know? The developers are like, well, that Kubernetes cluster, that container technology that we've written, it just went into production. And that's where the dev versus ops becomes way more problematic. And there will be a challenge on aligning the teams, making sure that everyone knows what they're doing, but it was a developer-driven project, so they already built stuff and went to production, and that's when the problem begins. And that's really what we want to prevent. We want to make sure that everyone's a part of the team, everyone knows what they're doing, and everyone is going to invest time in learning the right technologies. And this is really not the fault of the developer or the operations team. This is management. You need to make sure you plan your stuff beforehand. Are we going to invest in that technology? Which teams do we need on board? Because we definitely don't want this to happen. And of course, in the end, everything will be resolved, but it's going to cause way too much pain than it could have been. So then it begins. And if we go back to dev and ops, you know, developers, they build like the epic cars. They build the great cars, and then the ops team is responsible for building that road. It's smooth, and the cars can drive on that. So the ops, infrastructure management, scaling, deployments, and the developers just build that epic car. So the problem here is you can drive a Ferrari, but if you got a dirt road, it's going to perform pretty poorly. And it goes the other way around as well. You can build the Indianapolis Motor Speedway, but you need proper cars to drive it on. So that dev versus ops, if you go back to DevOps cultures, first of all, that shouldn't happen. You should have planned for that. But that's what we see happening with a lot of organizations, with a lot of people who start using Kubernetes. And that's also part of marketing. Kubernetes is largely marketed as something that's accessible to developers. It's easy to get started, and it definitely is, but not really for production. You need a team for that. You need to cooperate, you need to collaborate. And that's when the problems start. Like I said, it's accessible, it's effortless deployment. You can just next finish your container, your Kubernetes deployment. If a developer or the development team has written their microservices, or maybe they wrote a monolithic application, but either way, they put it in a container or they put it into multiple containers. It's really easy for them to just go to the Azure portal, click on new Kubernetes cluster, and deploy it. And that's when some people are left out. So, like I said, it's largely developer driven. And initially, that's my experience. I've got an ops background. My initial experience was Kubernetes feels more like development than it does ops. But that's definitely not true. That's something I learned the hard way. I learned it along the way. But what you see is, by extension, that AKS is usually deployed by the people also driving the container adoption. So that's usually the development team. And then what happens, and that's what that meme and that picture came from, is that the ops team are usually confronted with something that happened to them. So, all right, is Kubernetes, we're going to production. Good luck with that. And this not only steepens the learning curve, because to be honest, giving a basic intro or giving you what you need to get started with Kubernetes, that's not going to happen in 30 minutes. You need way more time for that. You need to invest time. You need to test it yourself. You need to do deployments. You need to read up on a lot of documentation. And there is a lot of good documentation out there. But having a semi or fully production environment and being confronted with that, or maybe a production ready environment, that steepens the learning curve even more, because Kubernetes got so many moving components that you need to manage and that you need to automate the deployment. You need to have a plan for it. You need to make sure which pods are talking to which pods, which container needs to talk to which container. Do I need services? Do we need an ingress? And if it's already running in production or in semi-production, that makes it even more complicated. So it's better to just start from scratch, collaborate, have the ops team on board when it all starts. And why you want to do this is that I just mentioned that next finish deployment. So someone goes to the Azure portal, click on Kubernetes, deploy it, give the basic information, so only the required information, next finish deploy. That sounds pretty good, but then you want to add features. Maybe you need monitoring, maybe you need secret management, maybe you want to integrate Azure Key Vault, maybe you need multiple node pools. And for a lot of stuff, you can do that on the fly, but some changes require cluster redeployments. And that's definitely not something you want to do if your customers are all already using Kubernetes or using your solution that runs on Kubernetes. So, like I said, initially, Kubernetes feels more dev than ops. But if we look at the definition as published on the Kubernetes website, kubernetes.io, you can also find great documentation there. Kubernetes is also known as K8s, is an open source system for automating deployment, scaling, and management. And those are the keywords here. And that sounds pretty ops to me. But the thing here is, and then we go back to that whole YAML discussion, so that's where I'm definitely with you. You have to write YAML code. And if you're a traditional ops team, if you do traditional infrastructure management, being confronted with YAML and managing an environment through code or with code, that can be quite challenging. So initially that feels like, well, that's more of a dev thing. They have to write code, but it definitely is not. And then we come to the next problem. Default AKS deployments are really not that good. And I don't want to be too negative about that, because you deploy them, they work. But for development and testing, that's great. Or for production, you're going to miss a bunch of features. You want way more features than just what you get in development and testing. Well, there is a solution for that. And that solution goes back into your organization before you even start using containers. You need to definitely plan for this. You need to plan for using container technology. You have to acknowledge the steep learning curve, and you need to allow people to make mistakes. And that's also one of the good DevOps practices. You want to have a shared responsibility, and you want to have the team learn it. So why not have the ops team on board from the start, have them deploy the development cluster, have them play around with it, because they need to test and develop as well. They need to develop the code, they need to develop the infrastructure. And you definitely want to give them time and invest in training. What I've seen happening way too often is that people just get started and then it feels production-ish, ready, so let's do it. And then they start running into bugs, they start running into scaling challenges. Oh, maybe my pod is not, it can't scale, my app isn't stateless, maybe you need a replica set, all that stuff. But that's the stuff you learn on the go, and that's what the problem is, because then you need to redeploy your infrastructure and maybe deploy a new cluster and test if it works there. So why not start with that from the beginning? And that's where that gray area should go away. And I don't want to be as direct as to say that developers should just write the container images or write the code, deploy the container image or publish it to a registry and ops does the rest. No, it needs to be collaboration, but you do need to know which team has which responsibility. And if you give the right team the right responsibility from the start, then they will build that great motor speedway and the developers will build those epic cars and it will work. But that's something I cannot stress this enough. This is what goes wrong so many times. And then what you can see on social media or in email threads is that Kubernetes, it's too complicated. There are too many add-ons, there are too many features. I need all this open source stuff. That's not the problem. The problem is that people are confronted with it on the go instead of investigating the capabilities and planning for it. And then eventually what you want to do is definitely automate everything. So you don't want to keep deploying files manually. You don't want to do Kubernetes configuration manually. You want to have that from the start. And that's where you need to start. You're going to stop thinking about deploying that cluster. You're just going to go back to your software architecture, back to the solution you already built or that you are building, and identify your workloads. So what am I deploying? Is it a front end and a back end? Do I need a database? What kind of software architecture am I using? Is it microservices? They go really well in containers, but maybe it's a more monolithic application. Maybe it's message driven. That's all good as long as you know, because that will really, really result in your update scenario. If you know what kind of services you're running, if you know what your software architecture looks like, then you can determine your update scenario. And that's where you can actually leverage the power of things like Kubernetes and containers. If you know what you're doing, you've got the right update scenario, maybe you can just update that one specific microservice. You do need to write scripts for that. You do need to have a pipeline for that. You don't want to do that manually. But that all comes together when you start building the inventory and identifying the workloads. And once you got all that, and the ops team becomes more familiar with the capabilities of Kubernetes, how containers work, they deployed the demo apps. There's some great YAML definitions on the Microsoft Docs page on Kubernetes. You can just get started from the go, use all the technologies that you want to get started with. It will definitely help you. And then you can actually start understanding the solution. So if the ops team gets a request, all right, this needs to scale. We don't just want to run one pod. They learn how to scale a pod or how to scale the configuration. Then they can go back to the development team and write, well, we need it to be stateless. You can't hold any state. That's how containers work. That's how Kubernetes works. Is that true, or do we need to make adjustments? And then you can get that bi-directional traffic or bi-directional communication, and they will learn from each other and build the right solution. Then you start looking at the capabilities that you need. Do you need persistent storage? Do you need, maybe you need a service mesh. If you're using microservices, you want to have that great update scenario. A service mesh like Istio is a great solution. Definitely something you should look into. But those technologies all come after you've identified the workloads. And then as ops, this is probably something you're being confronted with regardless of the technical solution you're implementing. How much capacity do I need? So that's where you start looking at your node pools. And that's when, if I go back to the default Kubernetes deployment, you just get 2 default nodes, maybe 3 if you play with the scaling a bit. For what operating system do you want? Do you want to have Windows containers? Do you want to have Linux containers? How many node pools do you want? Maybe you've identified those workloads, and then the behavior for one workload means they only need a little bit of memory, but for another workload, maybe you need like GPUs or a lot of memory or a lot of disk or a lot of CPU. And that would be the reason to have multiple node pools, because the node pools is actually the virtual machine size. So it can be a standard DS2 v3, or it can be a standard, maybe a burstable machine for different workloads. But if you identify those, then you can deploy the right node pools, and you can be really efficient when it comes to capacity. And in the end, that will also have a financial benefit. If what you don't want to do, and this goes pretty much for all public cloud solutions, you don't want to scale for that peak. If you have a peak moment in your solution and that peak happens every week, and it happens once a week, then maybe you don't want to have that huge virtual machine running for the whole week, but only for those couple of hours. Or maybe you just want to have specific workloads use that specific hardware. If you do that well, then you will have an efficient and financially interesting environment. So the node pool, it determines how much capacity you have. And this is pretty much the first thing you will look at when you're an ops team and when you start deploying Kubernetes. So node pools can be Windows, can be Linux. Good to know is that you always have one Linux node pool. The Cube system, the system management, that runs on a Linux node pool. So your first node pool will always be Linux. Then you can add a second one, you can add Windows, you can add multiple Linux node pools. Whatever you want, it goes, as long as you plan for it, because that's what you're going to pay for as well. This is actually the unit of pricing. And I just mentioned pods a few times, and this is where it gets a bit more complicated for traditional op teams. If you've never worked with containers or with pods, pods are basically the smallest deployable units on Kubernetes. And a pod can contain one or multiple containers. And this is where it also gets complicated. A pod can contain one or multiple containers. So the thing is, if you're using microservices and your whole solution is decoupled, then usually what will happen is one pod will contain one container. But maybe you've got 2 containers that are tightly coupled, that are dependent on each other, then you want to have those 2 containers in one pod. The reason behind this is that pods are also the things that scale. So and can be moved. So let's say I've got one node pool with 3 virtual machines. Pod 1 of my solution can live in virtual machine 1, and pod 2 can be scheduled to run on VM 2. If those pods both contain one container, I'm not sure how much I'm going to say container again anymore, but if they both run one container and they are tightly coupled and heavily dependent on each other, then there's actually networking and a virtual machine and a whole bunch of networking in between those 2 containers, which you probably don't want to have. So that's the reason why you would put 2 containers into one pod. And that's also the input that you need to gather from your development team. All right, is this tightly coupled? Is it decoupled? What is it? The thing with pods also is that they scale. So if your app is stateless, which I would highly recommend, if you've got one pod running and it needs to scale because you've got a lot of customers accessing it at this specific point in time, then you can scale up. And if you want to run 100 pods, then you can do that. And then you just have 100 pods or 100 instances of your app running on Kubernetes. How you can manage that, we'll come to that in a bit. But be aware that pods are like the lowest or the smallest deployable unit on Kubernetes. Everything is about the pods. So what is all that? And like I said, I'm not going to talk about everything you need to know about Kubernetes. I just want to help you get started, have you in the right mindset, and help you get started with deploying that first cluster. So what do you need to know about when you start talking with your development team or with your organization? What ingress controller do you need? What ingress resources do you need? What services do you need? And what pods do you need? There's a whole world outside of these 4 subjects, but this is what you really need to figure out before you start deploying. So how does that work? And when I started with Kubernetes, this was like a black box to me. It was so annoying to understand. And then I started testing with it and I started mapping it to my traditional infrastructure knowledge. And that's where it became a bit easier. But you will read about ingress, you will read about services, and you will read about pods. And let's start with that pod. So on the bottom here, we have those pods, so those smallest deployable units. They run on a node. And then you can see a service on top of that. And these pods, let's say this is one, let's say that this is one version of your app. So this pod is scaled to a replica of 3. So there's 3 pods servicing the same app. So let's assume that these are stateless. And then you have the service. And that service, we could call that a load balancer. It's way more than that, but let's call it a load balance or the dependable endpoint for your pods. So nobody's talking directly to the pods, they're talking to the service. And then we have an ingress. And well, before we go to the ingress, a service can also have a public IP. So if I want to skip that whole ingress part, I can have a pod and I can have a service, and that service will have an IP address, an external IP address, and it will provision a configuration on the load balancer in Azure if you're using Azure Kubernetes, and then your pods will be accessible over the IP address of that service. But a service doesn't necessarily have all the security features that you want. Maybe you want to do TLS termination, maybe you want to do host header recognition, maybe you want to do a bunch of stuff before the traffic even hits your pod. That's when you need an ingress. So that ingress consists of 2 parts. We have an ingress controller and we have ingress resources. And this is where it became complicated to me, because I just thought, well, I need an ingress, and that ingress will forward traffic to my service and it will go to the pods and it will work. That's where I was wrong. So what the ingress does, and let's start with the ingress controller. I always try to explain it as this is like your firewall or router. Maybe not a firewall, maybe a router. So at home you have a router. If you have a corporate network, you have a router. And that's the piece of hardware that you need to allow access or make access available to your environment. So we have that router, the ingress controller, and that comes in a bunch of versions. You can, depending on what hardware you buy or what ingress controller you select, that will also determine the capabilities that you have. Something we come across a lot is Nginx as an ingress controller with a community maintained image. We can use Azure Application Gateway as an ingress. If you're doing service mesh, maybe you want to use Istio as your ingress. There are a lot of ingresses out there. I will post a link in chat later because there's a really good document out there that will show you this is what ingress XYZ can do. This is what ingress B will do. And then you can select the right technology for your solution. So you've selected the right ingress controller. Let's say we did Azure Application Gateway. And then what Azure Kubernetes will do is deploy an Azure Application Gateway to your Azure environment. And then we have those ingress resources, and those are really the important ones when you start configuring traffic from your ingress to your service and then to your pods. Because the ingress resources are basically like the routes. So I've got the router set up, I've got that piece of hardware, the ingress controller, and then I'm going to configure rules. I want to configure routes, and that route table, that route configuration, that's what you could see as ingress resources. And that ingress resource will say, I've got this host name, so you can listen to aks.cloudadventures.org, and it will redirect, it will do TLS termination, it will give you the certificate, it will do the termination, and then it will forward traffic to the service in the backend, which will be this service, and then the pods will service their app. So those 4 components pretty much determine if your solution will work, yes or no. There are also other ways to do it, but in its very basic form, this is what you need to get your application up and running. And if you then go back to that problem where a team already deployed an AKS environment, is where you see, oh, they published it directly through services. They didn't use any ingress, so the server is just an IP address, and they mapped some DNS to it, and that accesses the pod. But then you don't have your TLS termination, you don't have TLS at all, you don't have the right routing, you're not able to implement additional security. So that's something I really want to stress. Get this into your head, these 4 components, understand how they work, and then you go look into different technologies. Then you go look at how do I want my stuff to scale? How do I want to use namespaces? How do I want to use event-driven scaling? All those technologies come after you understand this. And you can just do this by deploying Kubernetes to Azure, get the demo app from the docs.microsoft page, and it will deploy this for you. So you play with it, you test it, you break it, you fix it, and that's the start of your journey when you start experimenting with Kubernetes. So definitely, please don't do that next finished cluster deployment. I cannot stress enough. It's going to cause so many problems that you just want to plan beforehand. On the other hand, what you also want to do is automate everything. I mentioned it before, you want to have your whole deployment scripted. So what you want to do is be able to throw away your Kubernetes cluster, redeploy it, and have the same functionalities and have your app up and running. Because other than that being a good practice and help you standardize your solution, it will also provide you with a DR scenario, disaster recovery scenario. Because what if something happens in Azure West Europe, where I deploy most often, and you want to deploy to North Europe, or maybe you've got a customer in East US that needs their Kubernetes cluster to run there because of compliance reasons, then you can just redeploy the cluster to a different environment. And all you need to worry about is replicating your data. All the other stuff, the configuration Kubernetes, the deployment of the pods, your container images, that should be scripted. And with the push of a button, you should be able to deploy it. And that sounds like a lot of work, and it definitely is, but it will save you so much time when you actually need it. So first things first, you definitely want to learn how to write deployments in YAML. It is hard, but then again, it also isn't that hard. I've got a little example here. YAML. So what I have here is basically that configuration that I just showed about that ingress service pods. And you can see that it is a lot of code. And actually it's 3 different deployments with 3 different definitions here, separated by the dashes. And what I've got is I've got an app, and that app, or that I've got a deployment. It's called ASP.NET app. It's exactly the same as the example that you get from Microsoft. I label it, and then I'm saying, hey, this deployment contains 1 container. It's named ASP.NET image, or that's the name of it. And then this is where you can grab the image from. So it will pull that image from that public repository, and it will make it available on port 80. So this is the pod, that lowest deployable unit. Then we have a service, and this is like the load balancer. And this will deploy that service. And what it will do, I will get to the labels in a bit, but what you can see here is that I've labeled this deployment ASP.NET app. And here that service will look at ASP.NET app. Why is that important? If we go back to the picture, I can run 1 or multiple pods. So how does the service know which pods it can access? Which pods can I access for that specific application? And that's what I'm actually telling the service here. So you can, if someone calls you their service, you can forward the traffic to the pods with the label ASP.NET app. So if we go from bottom up, we've got the pod, we've got the service, and then we've got the ingress. And the ingress control is not something you define in your deployment. This is just the ingress rule. So this can be your routing rule. And what you can see here is we've got demo aks1.cloudadventures.org. If you just open a new tab, it will probably work. I think I've deployed it correctly. It will listen on path /, so the default path, the root, and it will forward traffic to the ASP.NET service. So this is about 84 rules, 84 lines, and this will deploy 4 different domains and then forward traffic to the ASP.NET service. So what's happening is I'm going to demo aks.cloudadventures.org. The control says, oh, I got that. I've got some rules for that. That means you need to connect to that service, and that service will publish those pods. So that ingress is not even talking to those pods. It's just talking to the service that's forwarding traffic. So if I decide to change pods or scale it back down, scale it up, introduce new pods, maybe with a different version, different label, that's all right, as long as I make sure that the service is talking to the right pods with the right labels. So stuff, I think we're already coming up on time, but stuff you probably want to set up. These are just some best practices that you're missing out on if you do the next finish deployment, and some things do require a redeployment. Deploy your cluster with managed identity enabled. If you do Azure Community Services, you probably want to use or leverage additional Azure services, use managed identity. Also enable Azure Active Directory authentication. By default, that's not enabled. So what's happening is that if someone's got the kubeconfig file, then they can access your cluster. What you actually want to do is enable Azure AD authentication. There will be a group in Azure AD, and if you're a member of that group, then you can access the cluster. Then what you also want to do is enable Azure Monitor. It's the click of a button, but I see a lot of people forget to do that. You definitely want to have insights into your container workload. So it is running. Now what? Is it performing? What's the capacity? Azure Kubernetes Service has some great workbooks built in. Can probably show you some of that. If I've got my browser here and I go, right, all right, so here's the app running. Pretty cool. If I go to my AKS, and we scroll down a bit, and this is really scaled down. Let me, AKS, make it a bit bigger. What you can see here is that Azure AD integration is enabled. These are the node sizes I'm using. I've got the version, got some integration, which is Container Insights. And that means that if I enable Container Insights, all the logging will go to a log analytics workspace. So other than just the workbooks that Azure Kubernetes provides, I can also build some triggers and build some alerting based on what I see in my log analytics. So something that you want to do, and we will talk about labels, or we already talked about labels, but the importance of labeling is, one, what we saw with the services. So I want to have this service talk to these pods, but also to keep identifying your workloads. If your solution starts scaling and you're running hundreds of pods, what is every pod doing? So just like tagging in Azure, what a lot of people forget to do, add labels to your app. Make sure you can identify it. And then you can also identify them through the log analytics workspace. So if I want to have a trigger on, hey, if the app with this label starts jumping up and down and starts restarting containers, I want to have an alert in Azure Monitor. That's something really simple, but really valuable. So enable Azure AD authentication, also disable the Kubernetes dashboard, because that is already given to you by Microsoft if you use Azure Kubernetes. Let me see if I can grab it up on the screen. Probably can. So the Kubernetes dashboard usually gives you access to, well, a lot of information about your Kubernetes environment, but that is already done by Microsoft now. So that's the control plane you get in Microsoft Azure. You can see the namespaces, you can see the ingress, you can see the pods running, you can even show all the labels, you can filter on that. So that's basically a GUI on top of your Kubernetes environment. Then what you also want to do is integrate with Azure Container Registry. So if someone pushes their image to Azure Container Registry, you can add additional security there. So maybe you want to do vulnerability scanning on your images, Azure Container Registry, and then integrate with Azure Key Vault. And all that stuff is what you need the managed identity for. It's out of the box, it's still next experience and stuff you can enable in the portal. But of course, after this session, you will do everything through scripting or through ARM templates, learn yourself some YAML. And the last thing I really want to stress, I've seen really large environments with hundreds of pods running. Please use labels. It's trivial to the success of your environment. If you, in a period of a year, when you start scaling your application, when you deploy multiple stuff, so the whole thing with containers is, hey, we started small, it works great, let's add more stuff. If you don't label it, then in a year's time, you will have an unmanageable environment. So please use labels. Thank you.
Great. What was the last piece of advice again? I didn't get it.
Labels, labels, labels.
Use labels.
Yes, that is great advice. Thank you, Wesley. This was a great overview. Perfect. We have quite some questions actually, so let's get through some of them. Bas is asking, well, he's actually curious what your take is on updating Kubernetes clusters in production environments. Do you have some tips on that?
Yeah, so if you use Azure Kubernetes, obviously you can deploy it through the Azure portal, which works great. I have to say I'm a bit more traditional about it. So what I just talked about, I like the whole scripting thing. So I can script everything, I can deploy everything, I can redeploy my whole solution. I tend to do that as well. So deploy a new cluster with the new version, see if my solution is running, if I don't run into any troubles, and then it works, and then I update the production scenario.
Okay, and then regarding tooling-wise, you mentioned scripts. So does it also include ARM templating or Terraform, or is it more like PowerShell or something else?
Yeah, I think that's a matter of personal opinion. Kubernetes and Azure PowerShell, I'm not a big fan of that because we're missing some functionality. Azure CLI works amazing. Azure CLI and Kubernetes are really best friends.
Cool.
ARM templates, they work great as well, but if you want to have some logic in your deployment, it can be a bit challenging, but maybe a bicep in the future will be the solution to that. Because I personally don't want to end up with ARM templates that are multiple thousands of rules, and then scripting, it might be a bit easier. And what we didn't talk about today is things like Helm package manager. So you start with YAML, you start learning YAML, but then you want to scale deployments, you want to automate it, you want to have versioning on your deployments, and that's when you start looking at stuff like Helm.
Cool, thanks. I have one other question from Mark. It says, given the heavy support of Kubernetes, is the adoption of Swarm a fruitless exercise, or are there still compelling reasons to do so?
Sorry, come again?
So, given heavy support of Kubernetes, is the adoption of Docker Swarm a fruitless exercise, or are there still compelling reasons to choose Swarm over Kubernetes?
I have to say, I played around with Docker Swarm, but I was never an expert at it. I just prefer Kubernetes overall. One, for all the community projects out there. If you want to do event-driven scaling, we've got projects like Kida, we've got service meshes like Istio. They integrate so well in Kubernetes. Just from a feature perspective, I prefer Kubernetes. I'm not saying there's anything wrong with Docker Swarm. I just never really got into the nitty and gritty of it.
Okay. Sure.
Nitty gritty. Did you get it?
Ooh, I like that reference. Thank you. You had some more questions for
about that? Yeah.
I definitely had a question. So yesterday there was a little bit of commotion on Twitter about the whole Docker being deprecated in Kubernetes. Can you tell us a little bit about what effect that would have for the casual user of Docker for it being deprecated?
Yes. So what's happening is that in Kubernetes, Docker is being deprecated and will be replaced by Containerd. That caused a lot of commotion. It's not necessarily bad. It's not a bad thing that's happening. It, in my opinion, will be more efficient. But I don't think people should be scared. It's something you can test. I think for a lot of scenarios, it will work out of the box without any problems. I think what was less fortunate is the deprecation warning, and some people on Twitter explained it really well, but a lot of organizations standardized on using Docker containers or Docker technology. So I think it was a bit of a shock when people read that, and maybe that could have been communicated a bit more carefully. But well, that happens in IT. But I don't see a lot of problems coming from that. Well, there will definitely be scenarios where it will be a problem, but I'm sure that people can resolve that. I'm not too worried about it.
Communication is hard, I'd say.
It is.
Do we have time for one more question? Think maybe, yes?
A quick one.
Quick one. Okay. For a beginner user, would you say rather go for a managed Kubernetes service, or would you go for Kubernetes proper?
If you really want to learn Kubernetes and you're looking to do the certification, it will definitely be a good thing to deploy from scratch. And I'm not saying use the deployment scripts that are provided, just really understand the technology behind it, learn how to set up the API, the etcd, the controller. Not because that's what you will do in production, but that will definitely help you understand how
what's going on.
Kubernetes mechanics work. Yeah.
Awesome. Thank you very much.
You're welcome. Thank you for having me.
Have a great rest of your day.
Okay, then it's time
What's
for
next?
our next speaker. So the days of dragging a bulky development laptop are over. Affordable cloud tools are made a powerful yet lightweight development environment a reality. Here to explore such a lightweight development environment with Windows Virtual Desktop, VS Code, Azure, and GitHub Codespaces is Callum White, a .NET developer and a Microsoft MVP. Callum loves organizing community events, from local meetups and hackathons to global conferences and roadshows. He is an active contributor to open source projects, a regular speaker at tech events, and as well a co-host of weekly YouTube series Umbra Coffee. Welcome, Callum.
Oh, we can't hear Callum yet.
Yeah,
Hey,
there you go. There you go. There always have to be a first one who's on mute, so it's okay.
Yeah. It's not an online conference when there is not someone who has to come up with.
Did I get the points first? You're on mute of today.
Exactly. Yeah, we have a bingo card here, and you're the first one. So thanks for those points.
Fantastic.
Loving the seasonal background, by the way.
Oh, nice. Yeah.
Well, yeah. I can't take any credit for that. That was entirely my girlfriend. And I'm loving that we've got Bit and Octocat in some winter wear as well.
Exactly. They need to stay warm.
Yeah.
It's very important because it's a bit chilly here. So, yeah. Okay, we are ready for your talk, Callum. Please go ahead.
Fantastic. Hello, everyone, and thank you for having me back at the virtual Azure Community Day. This is my second one. It's great to be back. And as Mark said, I am going to be talking about breaking up with your dev machine. This is a sensitive topic for people because for developers, a laptop or the computer that you do your day-to-day work on is, it's a core part of your life. So we're going to talk about kind of maybe changing some things up and what the future holds for us as developers. Who am I? I'm Callum. You can find me on Twitter. I'm a Microsoft MVP and an Umbraco MVP. It's an open source .NET based CMS. I run my own company here in the UK. I'm a .NET developer by trade. And when all of this COVID stuff wasn't happening, I would love to travel the world, speak at events, organize different events, and just generally enjoy community life. So for those of you who have maybe been coding a while, it might be that you started coding on a machine like this, maybe an Apple II or a ZX Spectrum or one of these kind of machines from the 80s. And this was a fantastic machine, a fantastic technological innovation. And then when we look ahead to, say, the 90s, you probably had a setup that looked something a bit like this, maybe running Windows 95 or Windows 98. And this may have been how you started learning to code, or you started your professional life. Of course, that's a whole 10 years later, and you can kind of see how things evolved. If we then jump forward to the noughties, you probably got a laptop, and you probably had one of these huge, chunky laptops that you'd get kind of back pain by carrying it around in a backpack. It was so thick and so heavy, and especially for developers, you'd get these beefed up laptops with extra memory, extra powerful CPUs, huge batteries in them, and it would mean that yeah, it would be even bulkier. This was always a challenge that I found carrying around laptops. If I travel a lot, I want something a bit lightweight and something that can go in my backpack, but also something powerful. And then kind of to present-ish day, where we've got things like the Surface Book or the MacBook Pro, which are, of course, fantastic, powerful machines. They've got super, super thin nowadays. And yeah, some incredible power underneath them, 12-hour plus battery life, really, really capable dev machines. Now, of course, it's totally up to you what you decide to use as your dev machine. For me, this is kind of a perfect choice because it's something that I can carry around and I can, you know, feel comfortable with. The interesting thing here is it seems like every 10 years there is an evolutionary shift in the type of machines that we as developers use. Of course, back in the 80s, we're talking about this kind of all-in-one Apple II machine. Go to the 90s and you've got huge, bulky desktop machines that you wouldn't dream of kind of dragging anywhere. They're too heavy, too big. Go to the noughties and you've got, you know, chunky laptops, and this was when we were starting to see the value in portability. And then the present day where we've got these ultra thin, super portable machines. So every 10 years we're having this kind of change. Perhaps we could say breaking up with our previous way of working. And we're about on the cusp now of a new change. So let me just go through my current setup. I run a 2018 MacBook Pro. It's got a 4.1 gigahertz i7, 32 gig of RAM. I really, really like Mac OS. And as a .NET developer and someone that works with Windows, that's a bit challenging. So I run a boot camp partition. This allows you to run Windows on a Mac. And I've installed VMware to have some virtualization there. And I can set that VM up so I can run it side by side with my MacBook, meaning I can do my kind of emails and my day-to-day work on Mac OS, but my actual coding and all the stuff I need to do on Windows. The primary reason for a lot of this is because I still work with a lot of .NET framework stuff, and despite that being, you know, deprecated now, unfortunately the world hasn't quite moved on all the way there yet. I'm hoping that as my work moves further and further towards .NET Core or .NET 5 and beyond, that I can start to reconsider whether Windows is actually part of my day-to-day working life. Of course, I use Visual Studio 2019 on that Windows VM. As I mentioned, .NET Framework, .NET Core. I have a SQL Server 2019 instance, which I run locally. That's really handy because then I can work offline. Whenever I've been traveling around to events, I like to be able to fire my laptop up, start developing on a project where I've got the database locally and I can run everything locally. Maybe I'm on a train or a plane that's not going to have Wi-Fi or any kind of reliable internet connection. So this has been a really important part of my workflow. Of course, for connecting to infrastructure and stuff, I have a VPN that I connect to. I use Azure for most of my hosting, and I use GitHub for my source control. I would say this is a pretty typical developer setup. Whether you're a Mac or a Windows user, hopefully this resonates. So where do we go from here? Of course, I'm pretty happy with my setup. It's portable. Like I say, I can jump on a train and continue working. I know others will prefer a desktop with multiple monitors. I don't feel like I need multiple monitors. I'm quite happy working off a single screen. And when I do, I've got an iPad that I use separately. So when I need a second monitor, you can actually use that as a second display. It's kind of convenient. I've geared my whole life up towards portability. Now, with the whole global situation going on and the kind of remote future that we're looking at, it really does beg the question, what happens to these computers? Are we going to move further towards have everyone having a bigger desktop, a powerful desktop machine in their homes because offices are no longer a thing? Or are we going to see actually people far prefer the idea of not being tied to anything? They want to be able to move. They want to, you know, spend a month in another country and work remotely. Well, maybe a laptop is preferable there. Equally, you only have to look around at the news of the past, say, 2 or 3 months, where you've got Apple bringing out brand new state-of-the-art machines running their own silicon chips, and these things are absolutely blowing like certain Intel machines out of the water in terms of performance, battery life, capability. Equally, even the iPad. The iPad over the past few years has become an incredibly powerful personal computer. You've got all these accessories now where you can clip on a keyboard. Of course, this has been the case for a while with the Surface Book too, with Surface and Surface Pro, sorry. So we're starting to get these far more portable devices, and they're becoming more and more powerful, but they maybe don't quite have the same experiences. Mac OS is, of course, a desktop class operating system. iPad OS that runs on the iPad is not. It's certainly kind of more touch focused and not necessarily the thing you'd think of when you go, "Ooh, I want to write some code. I need a productivity tool." So yeah, where do we go from here? This is a really interesting question. I think with the advent of certain cloud technologies and cloud just becoming ever and ever more present, we're going to start to see the developer machine becoming less relevant. Gone are the days where you have to carry that bulky, powerful machine around, and you'll actually just have access to those, all of that power at your fingertips. It will be something that you can just boot up and kind of get on your way. I like the idea that maybe the gateway into all of that is just some kind of shell device in future. It's an iPad with relative amount of power, but the experience is all powered by the cloud. So today, I'd like to show you some already existing solutions for ways that you can get up and running in a virtualized world, using maybe a lower powered machine as your primary driver, but having all of this power behind you in the cloud. Like I say, my requirements are really that I want something powerful. I want something lightweight so that I can travel easily. It can fit in my backpack. And so that I can work anywhere. I do like working on trains and planes, so I do need a solution that's going to fit all of those needs. Perhaps I'm being a bit demanding, but there's definitely some solutions out there that are going to meet these needs, and let's have a look at them. So the first one I'd like to talk about is something called Windows Virtual Desktop. Windows, of course, people are familiar with, runs on single. You can install it straight on your machine, but you can also run it as a server. And enterprises have been doing this for a long time, where they'll have, say, a central server with all the storage and everything for the whole enterprise, a domain that you can just log into, and you can get access to kind of any machine in your organization. You can log on. That's all great, but traditionally that works for kind of single site or on-premise operations, whereas what we're moving towards is a more remote future. Through Microsoft 365, there is a service called Windows Virtual Desktop, and it allows organizations to spin up pretty large clusters of compute and use those as kind of their on-premise IT infrastructure, just all hosted in the cloud. They can have a domain, they can assign users to that, tell users what they can log into, they can make sure that they can roll out changes and profiles to all of those machines, so when a user logs in, they get everything they'd expect to be there. The benefit here is, of course, they can log in from anywhere they want. In fact, even more so with Windows Virtual Desktop, you can log in through the browser, and you can interact with literally your desktop through the browser. You can even use an iPad app to fire those things up, so you can do kind of pretty advanced computing just directly through an RDP type connection. They've also got apps, and apps are a way of, running, say, the Office suite in the cloud, and you can then just connect to a single app rather than having to load and open up a whole virtual machine. This lives in Azure by default, and you can configure it all there. So I'm going to just quickly show you actually what configuring that looks like. So the Windows Virtual Desktop service in Azure, like I say, is primarily targeted at enterprises, but to be honest, you could use this with a small team as well. We'll look at the costs in a bit. So you have to create a pool, and all that a pool is a collection of virtual machines that you say, I'm managing under this big this virtual desktop environment. And it means that when a user logs in, they will be directed to any one of those virtual machines, and they'll have their own bit of dedicated compute power running on one of those machines. When you go in and you try to set up an environment, of course, you do the kind of usual stuff when you machine. You do the kind of usual stuff when you're setting up an Azure resource. Give it a resource group, give it a name, and choose the region. Currently, Windows Virtual Desktop on Azure is only available in the US regions, but I'm sure it will grow as time goes on. And then you can set a kind of a configuration. If you set it to be pooled, that means that everyone that logs into your organization could use any servers. If it's personal, they're kind of allocated to a specific virtual machine. For now, we'll just choose automatic assigning for personal users. We can also go one step further and configure the virtual machines that we want. In here, we can define specifically the spec of the machine. And these are just standard Azure VMs. So you have full flexibility to choose whatever you want and whatever your budget kind of allows. This is pretty cool because, of course, Azure has a huge array of different machines for different purposes. If your developers are typically doing, let's say, a lot of AI, you could actually give them a machine with a really, really powerful GPU or something extra that they maybe wouldn't be able to get normally in their desktop machine, perhaps would just be too inefficient. You choose your machine, you choose the region you want it in, and you choose the number of virtual machines you want. In this case, I just want one. And then you can give it a name. You can choose an image either from storage, which you have provided. Let's say you had, as an organization, one image that you wanted to roll out to all your VMs. You can do that, no problem. Or you can choose an image from Azure's own gallery. In this case, we just want Windows 10. Choose your disks, choose your configuration. The important bits here, though, is you tie it to a virtual network, a VNet in Azure, meaning you've got full control over all of the networking that goes on in your virtual desktop environment. You can configure the subnet rules, you can configure the kind of inbound and outbound rules, and you have literally full flexibility over what you can do. That's pretty impressive. This is the kind of stuff you get with on-premise infrastructure, but you actually get it all in the cloud here. Like I say, configure your domain and you're kind of away. You can also choose how many users get assigned to specific get assigned to a specific VM. So if you want to make sure you're balancing the load across 3 or 4, you could say only two users per VM if you wanted, or you could ramp up the VM size and have far more powerful VMs, but with less people, or with more people on them. Of course, this actually takes a long time to spin up, so I've spun one up already, and we can just have a quick look at that. This is a typical one. I've got nothing configured really. It's a very, very basic setup. You have a concept in here called groups, where you can say, well, our developers, they get assigned to a certain spec of machine, and our admin team, they get assigned to maybe a lower spec of machine. That means you're not going to be paying for a kind of huge cluster of servers that maybe you don't need. You can kind of balance that as you wish. Equally, applications are incredibly powerful tool. These are not virtual desktops. These are virtual applications that run in the cloud. Like I say, Microsoft Office or Outlook, tools that someone wants to be able to click a button and just pick up where they left off before. I'm going to quickly just show you the the amount of resources that this creates. So when I've gone in here, I've created a virtual desktop environment, and it goes and it will create IP addresses. It's going to give you a VNet. It's going to give you the virtual machines. In this case, I've got 2 virtual machines. Each of those gets an IP. You get security groups for each of those. You can literally do everything you would normally do managing virtual machines on Azure, which is really, really cool. But they are just standard Windows 10 servers running in the cloud. As an example, let's say I'm a developer. I've got a Visual Studio solution that I need to run, and yeah, that's here. So I've got two, in fact. I've got a .NET Standard one, sorry, a .NET Framework one and a .NET Core one. In this case, this is the just the sample .NET Core application, and in this case, this is actually .NET Framework and Braco CMS, which is, as I say, an open source .NET CMS installed. These would be probably two typical applications that I would work with. They're checked into a Git repo on GitHub, and I've pulled them down here, in this case, onto my virtual machine on my Mac, that is. Now I've got on my desktop, I have got a, oh, is that going to try and connect to the wrong thing there? Ha, demo gods fail. Give me a sec. So yeah, I've got these virtual machines running in the cloud, and I can log into those directly from my from any Windows machine as a kind of remote desktop environment. But also I can log into that from the browser or from a few other things if you are, say, working in an organization. I've got this configured to use a domain that I've got. Hopefully this will work. So I can just log in, connect. And great, so I'm logged into one of my pools of servers, and I have got here my environment already set up. I've got Visual Studio installed. I've got all the power you'd expect from Windows, but it's running in the cloud. I'm running this, of course, on a Mac. I don't have to have any special hardware to run or build any of these things. The only thing I really need in this case is an internet connection. As a quick example, just to show you that it's working, this is the same solution that you saw in my virtual machine on a Mac, but of course here I am running it on the virtual machine, and I'm going to boot up the .NET Core solution just to show you the kind of things we're dealing with. Well, hey, cool. So we've got, yeah, standard .NET Core app. I've been able to build, run it on my virtual machine. I can check that in, and then whenever I go and pick up my connection somewhere else, I can just pull down the repo and I can continue where I was working. The one thing that if you're using a Windows Virtual Desktop for actual desktop and not for the individual apps, it doesn't retain the state that you left the VM in. So if you were to fire up another connection to this exact same user on the same virtual desktop network, then it would just give you a blank desktop. You'd have to open Visual Studio and whatever again. If you're using apps, it does retain the state. So you could fire up Word and you'd be exactly where you left off. So like I say, this is pretty cool. You can access it from anywhere. I have full flexibility over that machine. It is just a Windows 10 machine running in the cloud. I can install all of the software I need. In this case, it was Visual Studio with .NET Core and .NET Framework. You can scale it elastically to your needs. So as I mentioned, you define the VM size, you say exactly how many users you want per VM, or even what type of user you want on each type of VM. The organization can manage this all centrally, so you don't have to worry about spinning things up yourself, configuring things yourself. Organization can roll out patches, security updates. That's pretty cool. And I think the really important thing here is they have full control over the network. Let's say you had a corporate VPN. Well, that can already be just tied straight into the VNet that you've got configured there, and you'll have access to any internal infrastructure you've got or any things that the VPN can access. There is a few downsides here, and for my use case, I don't think this is going to work. It requires a stable internet connection. So let's imagine that I have nothing but an iPad, and that's how I work. When I want to do development, I'd have to have an internet connection to fire that up. I can't start developing on a plane or a train. Trains notoriously have very patchy Wi-Fi, and planes, almost non-existent. The organization does have to patch these VMs and apply updates just like you would on any other network. That's okay. It just means there's a bit of maintenance overhead for the organization. And for now, it's US data centers only, which for me wouldn't be too much of a problem, I don't think, because the performance-wise, it should be fine. But I know a few companies that maybe deal with sensitive data. This wouldn't be a suitable solution. Of course, the million-dollar question is, how much does this cost? Well, the actual Windows Virtual Desktop service in Azure doesn't cost a thing. All it is a management service. What you end up paying for is the underlying VMs, the storage, the networking, the IP addresses, all of that sort of stuff. The base cost would be $70 a month for a pretty small virtual machine, 8 gig of RAM and 2 cores CPU effectively. You need a Windows license. You can bring your own and bring that cost down with the hybrid benefit, but it's starting to look expensive. When you look at that over a year or 2 years, $1,500 over 2 years, you start to think, oh, maybe actually this isn't any more cost effective than running a powerful laptop or something. Of course, you can scale this up infinitely. This is just the kind of recommended configurations that you might want to use, and multiple people can use a single machine, which is quite nice. My view is, if you have dedicated workstations, let's say some lower powered desktop machines, as an organization, this is a great move to bring some extra power to those users, but you probably wouldn't want to use this as your daily machine if you were traveling around doing all that sort of stuff. So the next solution I'd like to talk to you about hopefully solves some of those problems, and it's something called Codespaces. Codespaces started life as a Azure DevOps service, as Azure DevOps Codespaces, or Visual Studio Codespaces, I think it was. And this allows you to spin up a VS Code IDE effectively on the fly, and you can access it in the browser. You can interact with your code, check out a repo, work almost as you would locally. It's very impressive. Of course, VS Code is actually built in JavaScript as the application. It runs on Electron, and that does mean that you can lift a lot of the shared components there and actually run them in the browser. So we do get some of the benefits there of having like effectively the same IDE that runs on the desktop can run in the cloud, and more so when it comes to extensions. So we can install the same extensions that run on Visual Studio Code locally, and they can be ran directly on Codespaces. Codespaces is a GitHub service. It's currently in a preview, a beta that you can apply to, and I have a link for that in a minute. Of course, it would be silly talking about this unless I just showed you it. So, as I mentioned, I've got 2 repos here. I've got a .NET Core repo, and I've also got a .NET Framework repo. I'm in the Codespaces beta, so I'm able to spin up Codespaces with kind of a click of a button. As it's centered around GitHub, you have to have a repo in GitHub in order to get started with this approach. You open up your repo, you go to the Code tab, and then here you have a little button that just says Open with Codespaces, which is really cool. I've created a dev machine in preparation for this, and this is going to spin up in the cloud, hopefully, as you'll see, my repo inside a VS Code instance, or something that looks very like VS Code. What this is doing under the hood is this is using a container. It's bundled my repo into a container and my development environment up into a container. You'll see that it maintains state, and it can kind of, understand exactly what I was doing and where I left off. It's pulled out my whole repo here. I have access to Git because it's just a Git repo. It's even kept the tabs open that I had open before. That's really, really cool. I can go in and make a change, but also I can actually run this locally, or almost locally, which is really, really nice. Of course, I can build code, I can make changes, but wouldn't it be cool if that, pulled through to the front end? So how about we go .NET build, and you'll see this is just a command line, hopefully something that we're all very familiar with working with .NET. It's going to build my solution. That's wicked. I'm just going to change directory to .NET Core sample and go .NET run. This is the really impressive bit about GitHub Codespaces. You can not only build, but run your solutions that live in this container, but actually in the cloud on the internet. I'm not running anything locally here to get this up and running. You'll see here it's my .NET Core app is listening on port 5001, but of course I can't go to localhost 5001. This is running in the cloud. You can follow any localhost links though and actually get this up and running. So this is a GitHub Codespaces URL unique to my Codespace that has my app running and listening on it. The second I stop the app, the URL dies. That's pretty cool. And just to show you in real time what that would look like, I just dropped an exclamation point on welcome, and hey, you can edit your code live in real time. That's really sweet. Of course, because as I said, this is effectively Visual Studio Code, you can manage all your extensions and do everything you'd normally expect to be able to do here. So I've got a C# extension installed. That's because I'm working with C#. But you can literally, start to install anything. Let's install GitLens. It's a fantastic solution, and that's away. Next time I clone or open up my my Codespace, all of my settings, everything that I had before is going to be there, and we're going to be ready to go. Like I say, you can also just spin up your repo exactly where you left off with the files, and you can commit these changes directly. So I've got a few changes here. Let's hang on. Let's just stage that and put a message adding exclamation point commit, and we're done. So the next time I spin up this, pull down this repo in another environment, it could even be on my Windows virtual desktop, that change is going to be there. That's really cool. So the benefits of this, it runs in the browser. You do get a choice of Linux or Windows. That comes with a caveat though. For the GitHub beta, it runs in Linux only. If you're part of the Visual Studio GitHub Codespaces trial, you also get access to Windows containers. And the benefit of Windows containers is, of course, you can run some slightly more advanced things. And I'm hoping maybe even .NET Framework could one day build in that. Right now, you can't run that on Linux, so it's not possible. It does seamlessly integrate with GitHub, which I really love. The fact that I can, jump to a repo, click a button, and I'm away is truly, truly excellent. And within a minute or two, I'm connected, I'm up and running, and I even have a local-ish development environment running in the cloud at my fingertips. VS Code extensions do make this experience a lot less painful. You'd kind of think, oh, running an environment in the cloud, I've not got an operating system, I can't install, the bits of software that I need. Well, a lot of the kind of runtimes and languages that you need are in the container already, in the Linux container already, so that's okay. But for the maybe dev tools that you're missing, you can install VS Code extensions, which is great. And I've been trying out recently Fake Sharper, which for those that like ReSharper, you can actually install this. You can install this into a Codespace or into VS Code, and it runs the ReSharper CLI underneath to give you some of the benefits of using ReSharper in the cloud, which is equally cool. There are a few downsides. It does require an internet connection. However, unlike with the virtual desktop, the internet can drop in and out, and it sort of self-recovers. So every single file that you load up, when you click on it, it's going to do a request to GitHub to go and get that file, pull it down. And equally, your local environment is polling the container remotely, and you're just seeing a preview of that container running. But if your connection drops out, your connection's a bit flaky, it doesn't just kill your session. You can kind of keep working, keep coding. So maybe this is a bit of a compromise for me. When I'm on a train, I can run this and it's not going to affect my work too much. The other downside is storage. So you do have to be a bit careful about what you're persisting. Of course, if there's files you don't want to check into the repository, maybe a lot of temp data, those live in the container, and that's all great. If you destroy the container, you lose all of that. So you do have to consider that maybe you need some kind of storage service. And this comes hand in hand with the next point, which is if you have a database or any kind of external service you need to integrate with that previously on Windows you would have just installed, can't really do that here. You do need to use a cloud service. So for GitHub Codespaces, you would use, say, Azure SQL for your SQL databases. You'd use blob storage for your storage, and you'd keep that all outside of the container if you could. And then, of course, you are a bit limited to the platforms that it supports. Currently, I think it's only .NET Core 2.1 and .NET Core 2 and .NET Core 3 that it actually gives you. Of course, we don't have .NET 5 support yet. I mean, it's been 2 weeks. You need to hurry up on that. But yeah, you are slightly limited to the platforms that are included with these. I'm sure as the product evolves, goes into general availability, we'll see a bit more control over what you can actually configure a CodeSpace container to be. So perhaps we can put something custom in there. You can run Docker containers, so you could put a SQL instance inside a Docker container and run that in a CodeSpace. It's entirely up to you, but you are slightly limited to what the platform dictates because it's a managed platform. The pricing, it's about 10% cheaper than running a virtual desktop instance, starting with 4 gig of RAM and 2 cores, going all the way up to 16 gig of RAM and 8 cores. Now, of course, you can't share these, unlike before, where you could have one VM and that could have 3 or 4 devs on it. This time you can't. This is per user. I'm sure there will be some kind of enterprise level plans as the product comes into general availability, but right now you can't. Now, of course, developers get a little bit touchy about the specs of their dev machines, I think, and someone will probably turn their nose up at 4 gig of RAM going, what the hell is that? But there's a different way of looking at this, which is, like most cloud services, you aren't paying to run the underlying infrastructure. So where Windows might, take up 500 meg, a gig of RAM running on any server, running on any PC, this doesn't. This is purely the amount of resource used to run your container, run your environment. So you don't need to worry too much, I think, about the specs. I actually think a 4 gig of RAM, 2 core CodeSpace would be ample for most average development, which is really nice. But of course, you've got options. Now, the final thing I wanted to talk about was something called, VS Code Remote. And this is one of the most promising and most exciting things that I have seen in a little while. VS Code Remote allows you to connect via VS Code to any container, SSH, WSL service. You can have tons and tons of different things you can connect to. And it makes the experience of developing a hell of a lot nicer. Rather than coding in the browser like you would with VS Code, with Codespaces, you can still use VS Code directly. They're also extending this to Visual Studio in one of the 2019 previews. If you've had a play with that, you can actually log into Codespaces directly through Visual Studio and create them and create Windows ones and do a hell of a lot more. So what does this experience look like? Again, just to refresh, we've got 2 repositories in the cloud. We've got a .NET Core repo and a .NET Framework repo. Oh, I think I might need to just stop whatever I had running. If that's it's still running. Cool. So I'm going to connect to the exact same GitHub Codespace, but I'm going to connect to it directly from VS Code on my local machine. Let's imagine that I have a Mac. I don't want to install any. Is it still booting up? I think it is. I don't want to install any frameworks or anything on my machine. I simply want to just connect, get up and running, and be on my way. In VS Code, we can do exactly that. So if you install the GitHub Codespaces extension, you can see all of your Codespaces. In this case, I've got my my dev machine for my .NET Core. I click power, it boots up VS Code, and it opens my Codespace. You could, like I say, this can be any container really. It doesn't have to be a container running on GitHub's Codespaces. It could be a container running in Azure or that you have even on internal infrastructure. I can boot this up, I can edit my files. You can see it's got the exclamation point that I added a little bit earlier. It's even got the Git Lens window that I was previewing only a few moments ago in my GitHub code space. And hopefully I can do my .NET build that I would have done before. This is going to do a build. And I can do cd net core sample. I can go .NET run. Yeah, it's failed because I, in here, need to kill this process. And it's being a bit weird. It's not actually, terminal, there we go, .NET run. Net core sample, .NET run. Hopefully I can run this one still. No, I can't. So because it's sharing the same container, you can't run it twice. And I, for some reason, can't stop this one because it's probably because I killed the code space. Okay. Well, you'll have to trust me then for the sake of time as well. But what this does is I've connected to a container. I can edit my code. I can run .NET build. The .NET build does not happen on my local machine. That is happening in the container, which is fantastic. I'm on a Mac. I can do building of .NET stuff, and it happens in the cloud away from me. I can kind of work with almost any language in this environment, which is truly, truly cool. When you do .NET run, just like you did in code spaces, it will spin up a local development environment and it will proxy the container for you. In this case, rather than being on a github.com URL, it's on localhost and gives you a nice port. So that's really, really cool too. You have all of the access to Git and everything you could do before because it's in VS Code. As I said, benefits here: connect to code spaces, containers, SSH, WSL, a whole bunch of things. And the benefits of that is because you can run your own container, you can install anything you like in that container. So if I did want to run .NET Framework on a Mac or develop with .NET Framework on a Mac, I could create a container, install the .NET, the Windows Server core, and install the .NET Framework stuff, and actually I could work very happily. It does feel like developing locally because I'm still on my local machine. And I do like the fact that I'm not diving in and out of a browser. I'm using, say, a native application on my Mac, which is great. There is the downside, the same downside as with GitHub Codespaces. You do require an internet connection to actually push changes and to build, but it does handle a little bit better intermittent connections than, say, the Windows Virtual Desktop. Same things as before. Storage needs to think about what you're persisting because that gets stored in the container. And equally, any infrastructure you need to connect to, then you may need to consider that too. Remote databases, or put a database inside your container yourself. It's entirely up to you. There is one other benefit that I would add with this, which is because you can manage where the container lives and all of that, you do get a little bit more control over the security of it. So if you needed to run a VPN locally, you could run a VPN locally. That would just fall to the responsibility of whatever machine you're using. If you needed to protect where that container lives, you could password protect it or something. If you weren't comfortable with it being stored in GitHub. Equally, for customers who need control over, our data can't be in this country or has to be in this country, you get that control here. So a quick comparison of all three, and I'll share my opinion too. So virtual desktop, you can run that on a browser, desktop, or an iPad. That's really cool. The fact that I can just kind of pick up any device, be on my way, is really nice. Codespaces is all in the browser, so you can do that through the browser or on an iPad through the browser. VS Code Remote, I do like the fact that it's on my desktop and it's kind of integrated into my environment, but it means I don't have to have a hugely powerful desktop. I'm just running VS Code and it needs an internet connection. The virtual desktop does require a strong internet connection. And like I say, I probably wouldn't recommend it for someone that doesn't have a fixed setup. If you're trying to code on a train, it's just never going to work. The other two, they require a connection, but it can be intermittent, which is great. The virtual desktop, you do have to install every single thing that you need, but then you get, infinite flexibility there. Whereas the other two, you can install things, but you're slightly more restricted. You either have to install it in a container or wait to see what the platform actually offers you. Virtual desktop, you have full control over all of the security and the access, but you don't get that with Codespaces because it's currently all public. We'll wait and see what happens when the product goes into general availability. Of course, as I said, with VS Code Remote, you have some control over your local machine, but the container would ultimately be, however is being configured. My personal view is that virtual desktop works great for organizations, big organizations that need, fixed stations. People have a dedicated station, they work on that. And for the occasional travel, it would be fine, but you do need that strong internet connection. For GitHub Codespaces and VS Code Remote, it's far better for having personal control and flexibility. When you choose, you actually do want to just spin something up in the browser quickly, even check something on an iPad. Codespaces is fantastic for that. You click and you're up and running in future. And I'm certain that as the product matures, they're going to add enterprise level features that mean this is going to become far less of a challenge. I mentioned that I'd share some reading. There's some helpful resources here. Virtual desktop, getting started there. Codespaces preview, go sign up to that. Equally, the VS Code or Visual Studio Codespaces preview. Highly recommend applying for that, trying that out. It's really, really cool. Fake Sharper, if you want to try and run ReSharper in Codespaces or inside VS Code. And with that, I think I've gone a bit over time, but thank you so much for listening. I'm on Twitter if you've got any questions, and I'll happily take some from Floor and Mark as well.
Welcome back, Callum. Thank you for your talk. We do have a couple of questions. Do you want to start with yours?
Yes, because I am a very big fan of VS Code, and I also signed up for the beta of Codespaces. So I just opened it up actually on my Surface Go, so it works there brilliantly. But I was wondering, since I'm using quite a lot of extensions in VS Code locally on my development laptop, is there an easy way to get them on Codespaces there without reinstalling every one of them?
Absolutely. So just like locally, when you install extensions, that you get that .vs code folder, which allows you to set your preferences or your configuration. All of that is stored when using Codespaces. So you can create in your GitHub account a repository. I think it's just your username, and create a .vs code folder inside that, and drop all of your configuration in there. Meaning every time you create a Codespace, that will be pulled into that specific Codespace, and you can be up and running with your usual configuration.
Excellent. Cool. Thanks.
Yeah, I was just sharing with Mark when, back in the days, that's like 3 months ago, when it was still called Visual Studio Online, all right? When people would share like a little shield or a badge on their GitHub repo where you could just open it up, the project up in Codespaces or Visual Studio Online. And that was just so immensely helpful for people just getting started with the project. A question from Twitch, because we're also live on Twitch for the people that don't know that, from Duncansor W, I think that's the best username forever, was if the tooling that you discussed, is that limited to web development or also for other?
No, absolutely. So you could use this with virtually any stack and with anything. If you were just doing .NET services or developing open source projects, even, as absolutely applies. I've not really experimented with, say, running test suites in Codespaces. I assume you could do that. So I don't know how it would work necessarily in something where your end product, the deliverable, is a library that you'd want tested. But it's something I might go away and look at, because yeah, it definitely, it's just a development environment in the cloud. You can do whatever you want with it.
Perfect. I have one quick question. I love that you did a little shakedown at the end. But for the people that just want like straight answer, what is the most bang for your buck in terms of cloud dev environment?
Ooh, that's a great question. I think in reality, if you wanted just a virtual machine, then a VM in Azure would be the way to go. If you're working as a team, or maybe want something more lightweight, then CodeSpace is absolutely best bang for your buck.
Awesome. Thank you so much.
Yeah, thanks, Callum.
Thanks for joining us today. Well, and on to the next topic, because we don't break, apparently.
We just go.
We just
we label everything and we go.
Very good. So in the current situation of working from home and being remote and having these virtual events, it's even more important to take great care of yourself and of each other, I guess, and maybe adopt other routines and patterns in that way. I work in a remote team, and so I'm really used to the whole, distributed working. But still, I think working remote in pandemic time is very different from working remote in a normal situation.
Yeah.
I have picked up knitting. I think people saw it when they were following the stream for a little bit longer. Just sort of stress knitting. And you will not believe it when you see Mark right now. But I think until this year, you were completely oblivious to the greatest invention of all time, which is sweatpants.
Sweatpants. True story. Yeah.
You bought your first sweatpants this year,
during
which I
the
think,
pandemic.
oh my gosh.
Exactly. Yeah, no, I have heard about them. So I did know they exist, but I didn't think they were for me. So, but I was so wrong. I was completely on the wrong path for so many years. So I'm really thankful for all the people who said, "Oh, really? You should really try it."
I'm happy you converted.
Yeah, and now we even have company-sponsored sweatpants. So. Yeah.
That is great. Your company gets it.
Yeah, exactly. They totally get the working from home thing. So it's really comfy, like super soft, a bit oversized. Perfect.
So do you do like Business Friday then now, if you're not doing Casual Friday anymore?
Yeah, exactly. Yeah, so the reverse Casual Friday thing
I love it.
will now become a thing. Yeah, definitely.
Awesome. Well, I mean, we know nothing about the topic, right? But luckily, we have an expert on who will share with us what kind of practices we can all apply. And Coral, you're a development team lead, a developer, and a community event organizer. And you care very much about the people side of technology, making sure that our industry is as inclusive and empathetic as possible.
Yeah,
so
I try to. Yeah, Mark, that hoodie is impressive. I love it.
Yes, I borrowed it from Floor, but I'm not giving it back.
Sweatpants and hoodies. That's it. Just 2020.
Thanks.
So
whenever you're ready, we're very ready.
Sure, I will share my screen right now. And hopefully you all can see that screen.
Yes, perfect.
Perfect. Great. So we'll just get started. So Fleur's already given an introduction to me, but I'm a development team lead and a community meetup organizer. And this year, obviously, a lot of that's went virtual. And you can catch me on social media or on my blog, just on the handles there. And in case you can't tell by the accent, I'm based in Scotland. I'm in Glasgow. I'll try my best to speak as slow as possible. And like Fleur mentioned, I'm really interested in the people and the community side of tech, as well as I'm a developer, a .NET developer. So I help run the meetups for Ladies of Code Glasgow for the Glasgow on Braco meetup. And I also I'm a co-host of a podcast with 3 awesome developers called Candid Contributions, and we talk about open source development, but we also talk about the people side of open source, and there's so many different ways to contribute. So as part of that, what I've really been thinking about in 2020, you see it not in the context of engineers or anything like that, but you hear quite a lot in 2020 about self-care. And this is the definition that we're talking about here. So the practice of taking action to preserve or improve your own health. And the second definition there that I included, it's particularly during periods of stress. And I think that's really important this year with the pandemic, where everything is just a little bit extra turned up to 100 on the stress scale. So anything we can do to make our own health, our mental and our physical health better, and to be mindful of it, I think is really important, and we must try our best to do that. I will say this this isn't, I'm a developer, I'm not a doctor. So if you have serious concerns, or if you have issues, obviously reach out to a healthcare professional. But this is me. What I could have called the talk was what I've learned about self-care while working from home as a developer, but it just wasn't quite as catchy as self-care for developers. So this is just what I've learned and things that I've picked up over the last 9-10 months of working from home as a developer, and a part of the development community too. So the basics. I'm really, really rubbish at the basics of self-care, including drinking water. Like basic things that humans need to survive, I'm really bad at. So bad enough in the office, whereas at least I've got folks around me to say, hey, that water's been sitting on your desk since this morning and you've still not drank it, or making sure I go and get cups of tea and things like that. I'm really, really bad at that. So may seem like an obvious one, but let's get the basics down and look after the things that we need to do to look after ourselves. And it's amazing how much staying hydrated really helps. And move. I'm really, really bad at just sitting right here in this corner all day and all night. So trying to get up and to move. Lunchtime yoga has become something I try and do, even if not real yoga, and it's just kind of stretching around at lunchtime, or getting out for a run when I can, because I know that's something that really helps both my physical and my mental health a lot. So yoga and running won't be it for everyone, but find what works for you. And even if it is going for a walk, or just making sure you get up out from your desk. I know a lot of people have standing desks as well, and I've really recommended that. Didn't quite work for me. Maybe I have to persevere, but whatever works for you, just make sure that you move around. We don't have our commute at the moment. We don't have even walking around the office to different meeting rooms and things. So you very much can just sit in one space all day if you let yourself. So have to be conscious and mindful of that, and actually make the effort to move. And sleep is something that I know myself and a lot of people, with the change in routine this year, was interrupted. But you don't have your usual, like I say, commute to and from work, and the commute back home from work was always quite a good way for me to mentally, close one door and then come home and then have evening routine and sleep well. It was something that I had to kind of adapt to quite a bit with working from home, and I know a lot of people have been the same too. So if you have any advice that you've been following, like do share with us, because I know different people have different techniques. For me, it's podcasts. Whenever I'm really interested in a podcast, I seem to fall asleep, which is annoying, and I have to go back and find the place where I was. Yes, those are the basics. Let's make sure we look after ourselves at a most fundamental level. We hydrate, we move, and we sleep. And then from there, one of the things that is really important is the work-life balance. And I know it's something we hear about a lot anyway, even before the current situation that we're in. But I do think while working from home, that work-life balance is even harder to find. And something that I have heard from quite a lot of people is you're not working from home, you're living at work. And I think it's quite important to see it that way sometimes, of make sure it doesn't cross over to the wrong work-life balance, and to balance the two, essentially. So one thing that I've found really important, and I know a lot of my friends have too, is making sure that the environment that you're working in is comfortable and friendly, and that you're happy there, even if it's, I've got little Lego pieces on my desk. I know so many people like me have invested in plants. I don't think house plants have ever been happier than in 2020, because so many people are trying to make their workspace as enjoyable as possible. And even if it's putting the Christmas tree up weeks earlier than you normally would, if it makes you happy and it makes you comfortable and enjoying being at work or being at home, then yeah, go for it. And logging off. This is one that I really, really struggle with. And as a developer, I know we're not in person, but I'd say put your hands up if you've ever done this. So many times I know that my husband has heard this. Yeah, I'm going to log off soon. I'm really close to fixing this one thing. I just need to compile it and test it, and then I'll log off. And 2 hours later, I'm testing another version. But yeah, it's definitely the last time though. I fixed it this time. And we've all been here as developers, and we've probably all been in the situation too where if we do give up on it for the night and then go back to it the next day, we'll probably fix it in the first 5 minutes, and you need to switch off and let your brain think about it in the background. And quite often in the morning you will have fixed it. So don't always follow my own advice on this one, but we must try to, and don't just keep working on the same issue into the evening. And as part of that, actually switching off, logging off and switching off are two different things. So yeah, I can close my laptop, but one thing I realised is my brain just kind of ticks along, still thinking about the same problems I was trying to work on. And I do think not having to commute is a big part of that. That used to be where I processed my day. On the walk home, I used to have like a half-hour walk home, which I don't have now. So ways to switch off. Find whatever your thing is. It's not going to be the same for everyone. Fleur mentioned earlier about knitting. I've been crocheting the last few weeks to try, and I like to keep busy, but not to be looking at screens all the time. So that's been the way for me to keep busy, but to not be always looking at a screen and a device. And also reading as well. I'm really quite guilty of reading a lot of technical books or books around the tech industry. So I've really tried in the last couple of months to read a lot of fiction as well, to just really switch off from coding, from tech, and just from work in general. And we're all on calls all the time at the moment. And what I do think that we sometimes miss out on is that walk to the meeting chat, or the start of the meeting chat when you're waiting for folks to all join and to get started, that you would have in real life, but less so working from home. So I do think it's important where it's appropriate in the meeting to still have time for that catch up with colleagues, and the same for meetups as well. So I know there's a lot of virtual meetups. I think it's really great to not just jump straight into the talks and to the presentations, but also make time for the social conversation, and make sure that our brains are getting that part of kind of social interaction that we need and that we're used to getting before everything was virtual. But on a kind of similar but opposite note, Zoom fatigue is a real thing, and I did find that myself and some friends at the start of working from home and everything being virtual, were saying meetings are just so much more exhausting than they were. Like, I could sit in a workshop all day physically and not be this tired. Like, why is it? And it has been proven, why it may be like that. And apparently even the delays of it can be like between 1 and 2 seconds, a delay sometimes between you speaking and someone responding, and your brain picks up on that, and it's different to what it's used to processing, and it's having to work that bit harder to try and do all the things that we do without even thinking about it. So like reading kind of social cues or people hand gestures or anything like that. So our brains are having to work harder just to do the same thing as we've done previously, which is go to meetings or have conversations with people. So Zoom fatigue, or Teams tiredness, as I like to call it, it's real, and it's okay to be a bit more tired after a day of meetings than we'd used to be. And I think it's important not to beat yourself up about that. And even I know that Teams has come up, I think Zoom has come up with a feature where you can hide your own camera view, because that's another thing people have really struggled with, is that you're not used to looking at yourself all day in that little corner where it shows your camera. And it's kind of like having a whole meeting in a meeting room, but in front of a mirror, where you have to look at yourself the whole time. And it's just something that, again, that our brains aren't used to doing, and it's that extra tiring. So although meetings, with lots of meetings, there's lots of virtual catch-ups, a lot of social Zoom calls and things like that. But sometimes it's okay to say no, or to say yes, but I'm not putting my camera on. And I think even acknowledging that, and even saying to other people, you'll realise that a lot of other people are feeling the same way too. But what, through all of this, like I said, is what I've learned the last 9 or 10 months, but what's right for you? And that's the important thing. Different people are different, and different things work for different people. And I think it's important to be mindful, be conscious of what works for you and what doesn't work for you, or any days where you're more tired than you would have been, or you're not as great mentally as you have been other days, or days where you're feeling really great. Then take note of that. What happened that day? Any changes to routine that might have influenced that, and take note of it. And yeah, what might affect both your mood and physically? If you went for a walk that day and then felt great in the afternoon, then observe that, take note of that, and maybe that's something you could build into your routine a few days a week. Or if your mood was really good after you changed your workspace a bit, and I moved from working at my dining table to actually getting a dedicated desk a few months into working from home. And although it's in the same room and I can almost touch the dining table, it made a lot of difference just having a dedicated workspace that I can leave in the evening. So to take note of what helps and acknowledge that. And it's really, really important to be kind to yourself, because I think it's really easy when you're working from home to maybe be negative, or when you have had a bad day or you're not as in great a mood, to blame yourself, or to think it's only you. Other people are experiencing this too. We're all doing this for the first time. Even folks that have been working from home for years acknowledge that that's not the same as working from home in 2020. So be kind to yourself, the way that you would give yourself the advice that you would give a friend. And it's all about learning and adapting and trying something. If it doesn't work, then that's fine. Learn from it and try something else. And if it does work, great. And it would be really good to share what does work for you, what you found works. And if we could tweet on the hashtag developer self-care, it would be really, really awesome to start a conversation of what's worked for some people, what hasn't worked for people. And we can all kind of learn from each other. And that's me. That's hopefully in time. I know we're running a little bit over, but yeah, please do tweet and share, and we can chat about what works for each other. Thank you.
Thank you.
Super. Thanks, Carol. I have to admit, I'm definitely guilty of not taking too much care of myself, because especially the logging off part, I'm very bad at that. I know that. So I definitely need to have a bit more self-reflection when it comes to self-care and working from home. So this is a good reminder of doing so.
Yeah, and on Twitch, one of our viewers shared that they use music for productivity, and also people are what keeps them positive. So yeah, please keep sharing what makes you happy, and indeed use the hashtag.
Thank you.
Thank you so much.
Thanks
for having me.
All right. We are ready for our next speaker, I think.
And it's our last session.
It's
the last one that we're hosting together.
Exactly, yeah, because we're doing a handover as well.
Yes.
Okay.
We'll have a new set of hosts after this session.
It was so nice.
It was wonderful. Thank you.
There will be another VACD, right? Because we already invited Esther.
Maybe the other hosts will be fine as well. Let's give them a chance.
Yeah, okay, fair. All right. Next up, Jonah shares her insights about gender inequality problem in the tech and IT industries. Why is inequality a problem, and what can we do to fix it? Jonah Anderson is a Filipino-Swedish software developer and IT consultant at Forefront Consulting. Jonah studied computer science and agile system development. She enjoys solving challenging complex problems like the gender imbalance in tech and developing applications full stack in C#.net. Welcome, Jonah.
So it's a great privilege for me.
Awesome, even better.
Cool, we're happy to have you.
Yeah. Can you hear me well? I just want to do an audio check.
Perfect.
Yeah, that's perfect. Go ahead.
Yes, great. Okay, so I'll just share my screen. Oh, can you see my screen now?
Perfect.
Yes. So Okay, so today I would like to share with you a talk about gender inequality, why I think it is a problem, and what can we do to fix it. And this is a topic that I'm very passionate about, and I really want to advocate to our industry. So let me start by telling you a story about a little bit about myself. My name is Jonah Anderson. I'm a software developer at Forefront Consulting. Forefront Consulting is an IT consulting company with about 400 employees in 7 offices in Sweden. And to start with, let me share you my journey to tech. Originally, I am from the Philippines. I grew up in the Philippines. And when I was young, I wanted to be an engineer. It's because I enjoyed sketching buildings and helping people build modern homes then. And because of economic circumstances back then, my parents, we were in the middle class family. My parents couldn't afford to send me to school to study engineering. And in the Philippines, then it is not free to go get a degree in college or university. So what I did is I took the initiative to take a community test where I had the opportunity to take a scholarship and study computer science. So in year 2001, that's when I started my journey doing and getting into programming. So my first programming language was, I believe, I remember back then was written in a Tube computer and Windows 98 operating system, and it was Visual Basic was my first language. And I also remember the 3.5 floppy disk with small size storage in it, and also learned about binary codes, logic gates. So after computer science, I worked in different branches in different industries. And then when I moved to Sweden 9 years ago, I decided that I really want to pursue my passion in technology, and I really like working with computers and modern tech. So I studied for 3 to 4 years more about agile system development in C#.net and even in Java. So looking back from 2001 to today, I'm working from tube computers to multiple flat screens computers in modern technologies like Azure, in modern languages like C#. So let me share to you a story that I cannot forget when I started my career in tech. I was on my interview, a job interview, in which I was invited to do programming tests. And the first interview went well, and the programming test was the second one. So when I was invited in that interview, I was in a room with 2 or 3 programmers. I was prepared, and I received a programming test to do, and uh, I was they were at the back of me while I was answering my lines of code for that programming test. So I was kind of intimidated, and I lost focus. And to make the long story short of that scene, I felt very nervous that I quit and I didn't continue that programming test. And I came home asking myself, is programming really the kind of job that I really want to do? Is tech really the kind of like industry that I really want to work in my entire life? But I thought to myself, I really want to work with computers and I want to make a difference. So I didn't make that situation a hinder in fulfilling my dream to become a software engineer or a software developer. And I would like to share to you, when I started working, I like reading facts or statistics on the internet. And I noticed that we have challenges when it comes to gender inequality. We know that women are still underrepresented in tech in most of the major companies. And when I see this picture of a woman dominated by male, I can really relate to it, because sometimes working in as the only software developer in a team sometimes makes me feel left out or alone. So I really want to advocate that we need to make changes on these problems. And then in year 2002, there was 2013, there was a survey that in GitHub, they had women had to hide their gender to have their pull requests approved. And I think that is not good to hear for me as a female developer, because we are in a modern world, and I believe that we should have the freedom to disclose who we are regardless of our gender. So I believe this is something that I wanted to share with you. And then there was also a project called Gender Shades. I'm not sure if you have read of it, but if you want to check it out, there's a website for that, gendershades.org, in which it was a project that evaluates the accuracy of AI in classification products. And we still have a challenge of AI misunderstanding the face and of the female subject. So there's still a high rate of error there. So so I asked my question. I had a lot of questions about these things that I read online and me working in tech, and I can completely relate to it. And I dig deeper and search what gender inequality really means. I don't want to involve it with feminism, because I believe being equal is a freedom, and gender inequality, as its description, it's being treated as equal regardless of gender. And then I would like to share it with you a favorite quote that I have of Albert Einstein, that if everyone is genius, everybody is genius, but if you judge a fish by its ability to climb a tree, it will leave itself, it will live its whole life believing that it's stupid. So just like also females, if they were told that they're less than men, then they will spend their whole life believing that they are. So I personally identified some challenges that I see in our tech industry right now that I believe that we need to face and try to solve. First is we have a trend of gender stereotypes, gender bias in AI learning and machine learning. And unfortunately, we have high rates of women living tech jobs, not because of that they're not competent with the job that they're doing or not skilled enough. That's because they are not comfortable with the company culture. And most of the research done, what is the cause of this? It's because the women doesn't feel accepted for who they are at the workplace. And we lack female programmers. It's because we have a shortage of female role models. And we also have, unfortunately, we have a problem of discrimination in workplace. And I personally is a living testimony to that, and that is a separate story. But I see it as a challenge as well. And we need to build a future that is sustainable, and that requires diversity and with different ideas. And our digital skills, along with our modernization, digital skills are also essential. So we need to act now and do something about it. At least try to do something about it. It's not easy because there are challenges for that. But I believe that tech companies should create or start creating a gender equal and inclusive, diverse workplace. This means that a technical role, for example, like programmer or tech lead, doesn't have to be connected or doesn't have to be connected to a gender. So a male or a female or anybody can be a great programmer without specifically identifying it to a specific gender. And then we need to raise better awareness of equality in our workplace so that few women working in tech feels comfortable and they don't want to leave the company or the organization. And we also need to encourage female role models. We have a shortage of role models, and that is a great barrier in achieving the equality in our branch. For example, there was a study done by PwC in UK. Oh, sorry, in UK, and there were females that were interviewed. And were asked about their favorite female role model working in technology, and they don't know anybody. 83% of the respondents don't know anybody. So this means that we women in tech need to get out of our closets, and we need to get out there and inspire others, because we need each other. Not just men and women should help each other. And here also, we need to inspire technology to the younger generation. This is me on this picture when I was involved in teaching programming to kids using Scratch and Tinker and some robot programming. And I did this on the side of my job as a programmer, and I believe that we can make a difference by inspiring technology to our younger generation, and that starts at home, in school, and even us technologies can make a difference by sharing about our knowledge and the good thing about this tech stuff to our kids and to the younger generation that we met or get a chance to get and connect with. And also, as developers and people working in the IT field, we need to build applications and technology products and solve problems with equality in mind. This means that when we build applications and services, we think of others too. We think of different genders and different diversity in our end users and that will use our products. And then it all starts with leadership and good leadership. So if our leaders don't understand the importance of diversity and the benefits of it, then we will still have the same problem. So it is important that our organization leaders understand the importance of diversity, not just for the sake of having equal men to women ratio, but it also improves our workplace, like faster problem solving, increased creativity, and there will be reduced employee turnover. And also create a safety, collaborative learning environment for everyone. So when I was starting in technology, I had to really work hard to try to level up with my fellow male programmers. So this is important for junior developers, that when they start in a company, and they need to feel that they are welcome and they get the support that they need from other developers. And then diversity in tech talks, that like we're doing right now, virtual Azure Community Day, are welcoming me, including myself and other women, to talk about tech. And I believe this is something that we need to do more, hackathons and even in programming events. And what am I doing then to help fix the problem? So I volunteer to inspire and mentor different women, young women, old women who wants to get into tech. So regardless of ages, it's not too late to get into tech. And I am involved in several organizations here in Sweden and even internationally, and volunteer to do mentorship when I have free time. And when I have a chance, I inspire tech to others and my friends. And I'm also part of the gender equality group at my workplace, where we're trying to advocate and make changes in our organization, that we will be more equal, more developers, and make a difference that way here in our country. And lastly, we shouldn't forget the women that made a difference back then in order to create the modern computing that we have today. We have the ENIAC women, we have Grace Hopper, and even Lady Ada Lovelace. So let's inspire and motivate to have more of them in our industry today. And lastly, equality is freedom, and it is the freedom to be ourselves and to be valued for that. And if you have questions, you can contact me on these contact information. And I would like to thank you for the opportunity to talk. Tusen tack in Swedish, and maraming salamat in Filipino. Thanks.
Thank you so much, Jonah,
Yes.
for highlighting all these challenges. I can definitely get behind all of those. I do recognize them. And definitely, representation matters, and in this case, so we have to make women and people who identify as
Yes.
women more and more visible. So you mentioned you were actually mentoring in some programs to make a difference.
Yes.
Do you know of any other initiatives, either locally or more globally, that we can point people to learn more about this and to help more?
Yeah, sure. As I had in my slides, there's locally in Sweden, there are a few like Teknikvinnor, Data Shay, and locally in my city, I have the Guidance Network, where I get to meet the women studying programming, and we meet online because it's Corona or COVID right now. So we meet online. I inspire them. They ask questions. How does it work? How does it mean to work as a programmer? What are the challenges? What's the difference between working in an IT consulting company compared to working directly in a product company, for example, directly in Microsoft? So I have that questions, and I'm really passionate about it, and I'm very glad I have the opportunity to talk about it, because we need role models to make a difference. And if women out there who are very good programmers are just hiding in their closet and just don't want to show up, then we don't inspire others. So, and I was also teaching kids programming, and I noticed that in my class I had like 10 or 15 class in school. I noticed most of them are boys, and then there were like 2 or 3 girls. And I noticed that they were not so interested in learning about Scratch and Black programming. And I asked them why. And then I tried to inspire them. But they were too busy with Instagram and other things like that. So we need to change that.
Cool. Agreed. Yeah. The one initiative I can think of right now is Global Diversity CFP Day.
Yes, which is coming up January 23rd.
Exactly.
Again.
Yeah. So that's good to mention. And yeah,
especially when you talk about representation. I mean, I think it's good if people get more comfortable with public speaking. And Global Diversity CFP Day is definitely a great.
Yeah, lots of mentors doing offering their free time and giving help. Yeah, cool.
And just one day before, because that will be an online event as well. I think that's one of the key things this year, and I think that's been good in terms of accessibility. Also, is C#. Get it? C#.
Mm-hmm. I think it's very sharp. Okay.
I think it's very clever. They'll do a community day on January 22nd. So that's also I can share the link in the chat later.
That is good.
That would be good.
Yeah. Cool.
Yes. Yeah.
Many
thank you so much for. I'm really glad that I got this opportunity to speak
Cool.
in this
Well, it was
event.
great
And
to
I
have
hope
you.
there will be more so I can inspire others.
Very good.
Exactly. Go for it. Thank you very much.
Yes. Yeah,
Bye.
thank you.
All right.
That was it for us as well. But
Exactly.
We want to plug, I think, the challenge one more time.
Yes, exactly. What was the link?
I feel like a proper YouTuber.
aka.ms/VACD challenge. That's the link, right?
Yeah.
Okay.
Don't like and subscribe, but just like
Oh no. That's
Compete in the
my
challenge.
other YouTube thing. Yeah. Okay.
exactly. And do so. We'll have a little break coming up, so this is actually the perfect moment to check out the challenge and maybe get started with completing some of the modules, and then our next host will take over.
Excellent. Okay.
Thanks again, Mark, and thank you all for
Thank
tuning
you,
in.
and
enjoy the rest of your day.
stay tuned. Enjoy. Bye, everyone.
Well, thank you for staying with us here at Virtual Azure Community Day. In case you haven't noticed the beautiful video, if I, have to say, you can join us for the Cloud Skills Challenge and you can win a beautiful backpack. We will give away the prize if you join and complete it. You have until the 12th of December. And after that, we will randomly pick 10 winners who will get this beautiful backpack, and probably we will put some other stuff in there as well. Also, you saw the little QR code for Azure Heroes. You can earn the Learner Badger, and Azure Heroes is a community program where you can either earn a badger by completing a challenge or doing a hackathon or just by watching this event, Virtual Azure Community Day. Isn't that wonderful? And you can also nominate other people, for instance, to recognize them because they are an inclusive mentor or leader, or they generate cool content which you enjoy. So please check it out at aka.ms/azure.heroes. Well, as you can see, we have changed. Let me introduce myself. I'm Susanne Daniels. I'm a developer engagement lead at Microsoft. And we have this other person. Hey.
Hi.
Hi.
Hi, so I'm Roel van Gint. I've been working in software development for about 8 years, and 3 of those I've been working at Capgemini. I really enjoy keeping up with all the latest and greatest on .NET and Azure, and I think maybe at this point I'm up to the challenge to maybe share some of my knowledge. So I won't be doing that today. I'll be hosting together with Susanne, but maybe you'll see me on the other end of the screen in the future.
Well, that is, if you have watched earlier today, you know that this is a thing, right, at VACD, that if you say, hey, I want to do that's a promise. So we expect your session for the next Virtual Azure Community Day.
Yeah, so I'll start preparing.
Yes, so what will it be about?
Well, that's a good one. I've been messing around with Azure Functions lately a lot, and I think that will be a cool one to show some integration with all of the other Azure components it can integrate with.
We love Azure Functions, so that's brilliant. We also made a little switch with plushies. So we are joined by Brady, our open source mascot, and Octocat got a friend, Octocat. Enough with goofing around, I think. We are running a little bit late, I guess. So let's take a look at the next session. So Roel, what is the next session about?
Yep. So next up we have David Pasdera, who's telling us all about flexing your Azure muscle with Bicep. And Bicep is a really cool new technology, but I don't want to take his space. So let's introduce him.
Are you there?
Yes. Yes.
Awesome.
There he is with a cool.
This is the thing about life, right? Like, oh well.
He's not showing up.
Oh gosh, I'm live.
There he is.
Yes.
Cool. Welcome.
Okay.
Hey, David.
Thank you. I hope you can hear me well.
I can. Yes.
Perfect. So, greetings from Norway. Snowy but rainy a bit. And welcome to my session that surprisingly won't be about fitness. And I should probably share some content as well.
Yes, please.
Yes, please. But it will be about a very interesting project that can help you with adopting infrastructure as code practice on Azure. Just let me double check that I can see stack as well. Yes, perfect. So my name is David Pasdera, and I work in Microsoft Norway as a senior cloud solution architect. I've been running many projects where large customers were really trying hard to adopt infrastructure as code practice, predominantly using ARM templates. But also be Pulumi or Terraform. And of course, we all can agree that authoring and using ARM templates is hard. JSON as a sort of foundational language is very verbose. It requires you to sort of be very mindful about columns, about the precise syntax and the structure. So the team around Azure Resource Manager, they kicked off a new project they are now calling Bicep. Why Bicep? Because we have ARM. So I actually like the name. There was a poll about what the future name could be, but for now it's Bicep. And so we will explore what the Bicep is, what it is not, and we will walk through from a simple examples going to more advanced workflow, something I do when I'm working on Bicep files development. And in the end, we will look into some automation through GitHub Actions and the roadmap that is also publicly available for anybody to see. So the project Bicep, its goal is to create a new DSL language that would be sitting on top of a resource manager templates, and as such, it is an abstraction. So it is not trying to compete with ARM. It is actually something that sits on top, as you can see in the diagram. And when you want to deploy your Bicep code, you actually need to compile it or transpile it, depends how you want to call it, into a proper ARM template. And then you can use your regular tools like AZCLI or PowerShell module to run the deployment. So it's in this way, it's really an abstraction, and we can think about ARM JSON as an intermediate language from that perspective. So you still require your standard tools to do the actual deployment, but what is exciting is that we will look how simplified the syntax and the use of Bicep language is. So as I mentioned, there are several goals that this project has. So reduce current pain. That's probably goal number one, and help people with adopting infrastructure as code that is in the ARM JSON world not very easy, and you need to be quite skilled to actually do that. Since it's a transparent abstraction, it means that it can leverage all existing benefits from the platform. It also means that anything that you can do in ARM language, ARM JSON language, you can do in Bicep. There are a few exceptions, and we will look at the roadmap, what is available currently in 0.2 version, and what will be available hopefully beginning of next quarter in 0.3. But that's the whole idea. All the functions that are available in ARM language, they are currently also, with few exceptions, available in Bicep. But the second most important goal is to provide modularity. You know that when you begin with ARM templates, you start with adding more resources and maybe parameters to one single file. And in the end, you can end up with hundreds of lines of code. So there is currently in ARM a possibility to sort of detach some components, and you can use so-called linked templates. So having the parts of your code in a separate files. But it has a few caveats. First of all, you need to stage those linked templates to some place where the ARM API would be able to reach out and pick them up for the deployment. Bicep is actually reducing this pain in form of a new capability called modules. It's also good to talk about what are not goals for the language. So it's not something that would override all other great possibilities that are available. Bicep is not trying to compete with Terraform. its primary focus is Azure, and it will. I can't say never, never say never, but I don't believe it will be used to deploy to AWS or GCP any time in the future. But there might be some additional capabilities, maybe around Kubernetes, for instance. But it's really an abstraction for ARM JSON. And since ARM cannot provide or deploy to any other sort of providers, then of course the focus is clear. It's also not a general purpose language. It's really a DSL that should abstract the complexity and help you with writing your infrastructure as code for Azure. And it's even though the syntax is of course new, it's reusing a lot of similar constructs that you will actually find very familiar from other languages. So today we are on version 0.2, and it came with a lot of great capabilities. First of all, support for tooling. So the primary tool for Bicep today is Visual Studio Code. It's not a surprise because it's still ranked as the most popular IDE. And it has an extension that now in this new version provides full IntelliSense and code formatting, and so we will actually see that in the demos. It also provides the ability to split your code base into those modules that I briefly mentioned, and it also introduces something called scopes, so a possibility to deploy to both subscriptions and resource group level in one single template, for instance. It's also good to remember that it's still an experimental language that is not ready for production. So in other words, you cannot today submit a support request to the Azure support, but this is something that will probably be coming with 0.3 version. When it comes to existing limitations, even in this new version, you still can't use copy function to use loops and generate more resources based on that, and conditional deployments using condition property. One more thing is also the single line objects and arrays, meaning that you need to actually stretch them into multiple lines, one array member, for instance, on each line. But apart from that, there are so many exciting new things. And when I checked, if you were following this project on GitHub, because the whole project, its backlog, the code base, of course, and the roadmap, everything is published on GitHub, and you are more than welcome to contribute. If you were following the progress and the plan, there was a feature scheduled for V3, which was called a decompiler, allowing you to take your existing ARM JSON template and compile it back to Bicep. But surprisingly, this feature was actually released already in this 0.2 version. So we will actually begin with looking at it because this can help you with taking your existing code and looking at how does it look in Bicep. Switch to a really nice web tool. So in case you don't want to install any tool yet on your machine, the Bicep Playground is a great way to start. So it comes with 2 panes. One is, of course, the Bicep code. One is ARM JSON. And you can start with, there is a number of samples that are part of the GitHub repo. So if we take the VM simple windows, you can immediately see on the left how the Bicep code look like, and on the right how does it translate or compile to the ARM JSON. So the nice thing is, of course, that you can start adding new things. So I want to add a new parameter. And as you can see, this tool is actually telling you compilation failed because you need to complete writing that specific block of code. So some param and string, and when I complete that, it should compile well, and the new parameter would be simply added. So in this way, you can take those existing samples. But what is also quite useful is that you can take your existing template and actually decompile. So if I check, let me see which one it is. Yeah, so that was something I wanted to show as well. If your existing JSON, ARM.json file includes some of those properties that are not supported, in this case, it's actually complaining about nested templates. It won't decompile for you. So let's take something more simpler. Yeah. So I took my existing ARM template I was creating for one demo, and now I can see how it looks in Bicep, and I can just take that code and refine it and forget about the JSON, and I will be able to compile it using the CLI. And after it is compiled to ARM, you can use any additional tools that you're used to for testing and validating and deployment. So it behaves in exactly the same way. So that's Bicep Playground. I highly recommend you to just look at it and see for yourself how this look. And of course, you can even start from blank and start typing, but it has support for sort of code coloring, but it doesn't give you any IntelliSense. So I wouldn't use it as a primary tool. We will definitely switch to VS Code shortly, and you will see how different the experience is. So still, if you don't want to install anything on your box, you probably heard about Azure Cloud Shell. This one can be used to sort of play with Bicep as well. Since we are in this experimental phase with the Bicep binary, it is not included in the image that is supporting your Cloud Shell. So you need to install it yourself. And just a word of caution, you cannot really, since you are limited with permissions, you cannot add it to the path. So the only way how you can add it is to install it somewhere else. And I will show you how this was done. So David install that. So this is a simple script, and I would like to call out Chris and his great build59s.com website, where he's publishing a lot of great articles about Azure. So this simple script allows you to install a Bicep on the side in some directory, and then you would be able to call it and use it to compile or decompile. But yeah, so it is. You can use this rudimentary code editor or any other built-in code editor if you're Vim expert and similar. But again, the primary user experience is tailored around Visual Studio Code. So I would like to switch to this one. It's interesting how my otherwise powerful device is now extremely slow due to the broadcast, but I hope it won't crash on me. Come on. Okay, now it's working. Perfect. So there are two components that you need to install in order to start using Bicep. It's a Bicep binary. Of course, it is cross-platform and open sourced, and you can get it from the deployments artifacts from GitHub. And the second is extension for VS Code, and that one is also available in the same repo. So the product team has published a really nice guide on how to install it depending on what what operating system you use, and how to install the extension from the marketplace. If you use some previous version, you need to uninstall it first, because that one had to be installed manually using a file. Great. So I've installed all the tools on my machine already. So I can just check that I have Bicep installed. Yes, it is. There is a really nice tutorial with animated GIFs showing you some of the capabilities around IntelliSense, around code completion, some basic set of snippets, as well as code navigation. So anything that you're used to, peak definition, find all references, everything is working in the same way as for other languages. But I think the most powerful thing is if we really want to start from scratch, even though I have a lot of examples. Bicep. If you want to start from scratch, it will give you a lot of leverage just by hitting control space and sort of getting what should be the next block of code in your syntax. So obviously, Bicep supports comments, both single and multi-lines. So this is just params. So if you type a keyword, you can now have several options. So I'll just use this one, and you can say, let's say, location space, and it's string. This could be enough. If you want to extend it with some default value, you can say Norway, and that's fine too. If you want to extend it a bit more, then you actually need to provide more than that. But here I can just hit Control Space, and I don't need to remember how these things are called in Bicep comparing to ARM, where the names of those properties were, of course, a bit different. So allowed, yeah, this could be obviously an array. So I can say Norway East and Norway West. These are the local regions. What I sort of realized while trying to write the Bicep code from the beginning, I was doing a lot of mistakes by adding the commas, because you're used to do that when you're working with JSON. So that's nice. If we switch for a second and look at the declaration, this is basically a copy from the repo. So you can see you have a full power of what types, data types you have available for parameters, for variables, and the definition is really sort of nice and clean in that sense. So, and of course, if you want to run and say I want to compile, so you can hit Bicep. And by the way, if you're seeing this, I hope you are. This is a new AZ predictor. It's a really nice new feature for PowerShell, where it can show you not only the history, but based on what commandlets for Azure modules you're using, it can actually predict what would be the logical next step. So it's powered by some artificial intelligence. So I can say not really decompile, and I say declarations. But of course, I would need to be in the right folder. Okay. Arguments. Oh, sorry. Yeah, you're compiling, but the right keyword is actually built, right? Not build. So hopefully this time it will produce the right. No, it didn't. Perfect. So that's something that you will get when you try to run that command. But the IntelliSense in that extension is actually showing you some of these warnings and error already. So first you can see that I have two objects, or there is one parameter and one variable, and they both have the same name. In ARM.json, this wouldn't be a problem, right? Because you always prepend it with the function. It's either parameters or variables. In Bicep, you actually need to make sure that those sort of logical names that you have for each sort of code block are unique. So I need to change the name and make sure that it is unique. So that's the first one. Then it actually tells me that I don't have any endpoint property in DNS zone resource. So it's not just giving you hints about any syntax errors, but it also can cleverly check if that kind of declaration makes sense, or that kind of expression makes sense. So I can't really use endpoint. I would need to change it to something else, like zone type, for instance. That should work fine now. And then, of course, you can see here that there is, it's another example from the docs. So there is no example resource provider. So obviously that one wouldn't compile. So I can change it to something else. And there is typically a lot of questions around, will Bicep support new changes coming in ARM and resource providers, and how frequently will it get updated? Well, the thing is, it's a transparent abstraction. So even if you're running some older version of the Bicep CLI, and you put some sort of a really brand new version of the API as part of the resource declaration, because that's how it's structured. It will warn you, but it will actually compile it. So if you, for instance, have an access to some private preview, an API that maybe the language server is not aware of, it will still allow you to compile it and deploy if that would be valid for your environment. Okay, so that was a simple explanation of some of the key syntax for parameters, for variables, resources, and outputs. So again, much cleaner, much simpler. The power of using or referring to properties with dot, that is well known in other programming languages. It's extremely useful. If you compare it to a standard expression, you would need to come up with to define such outcome. So as I said, once you have your code compiled to ARM.json, you can use any tool that you're used to work with it. So I would like to move on a bit. Yeah, we went to this one. We set up our environment. So this is an example of a workflow I sort of adopted while working with Bicep. So I first author my Bicep code in VS Code, then I compile it, then I validate the template using ARM test toolkit. Eventually, if I want to, I can use this really cool extension called ARM Viewer. And I can actually continue with my validation and run the what if deployment or run a deployment with what if. So I can see the difference between the state in Azure comparing to the code I actually work with, and eventually use AZCLI to deploy to some test environment. So in my workflow, what I did, let's say use this one as an example. I have a simple, it's really slow. I have a simple Bicep file for creating a network interface card. So of course I could start typing those commands in the built-in terminal. But what I thought would be really nice is to use built-in tasks. So if you're not familiar with VS Code tasks, so you can run a task, and then I have defined these 4 tasks. So first I will do Bicep build, and it should actually build my code to ARM, and it did. If I want to, I can also look at it through the ARM viewer. If this happens to launch, okay, it's not really interesting, and even as I can see, the label is somewhat corrupted, but it's a single resource, so it won't give you much of a value. But the next step would be to run next task, which is tested with ARM test toolkit. If you're not familiar with that tool, it's a custom PowerShell module, and it's using Pester, which is a great test framework for PowerShell. So it should, based on the sort of predefined set of tests, give you some output about the health, and if you're following the best some recommended practices for authoring your ARM templates. So as you can see, it's complaining about the hard-coded location. So if I change that in the Bicep, recompile, and then I would run this again, this would result in much cleaner syntax. And of course, the last one I could actually use is what if deployment. While it is running, I'll just show you how I created those tasks in VS Code. So it's a simple task.json file that you can have in every repo in VS Code, .VS Code directory, and it's a definition where you're declaring what should be running, what arguments, etc. So now we can see that my what if is getting the status, because ARM.json don't use any state file, unlike Terraform, for instance. And you can see that the result of this test or what if is that, okay, I will deploy one new resource to that defined resource group, and one is ignored, meaning there won't be any change. Fantastic. So all that code, of course, I will share on my GitHub repo. But I thought this was an easy and a nice way how I can, and of course I could attach some code binding to those tasks, so I could simply have that workflow in a sort of semi-automated fashion. So when I'm happy with what I produced, then I could probably step up and and take it forward with more advanced scenario and use some automation, for instance, GitHub Actions or GitHub workflows. But before I do that, I wanted to call out that great new capability that is using modules. So module is, let me find the right example. Module is like any other bicep file. It doesn't have any special syntax, so you can include the declarations of parameters, variables, resources, and outputs. And then if you want to use it, no, that's not this one. Declaration. If you want to use it, what you would do is you would simply use a keyword module, give it some name, and then a provided path to it's a relative path to the file system where you have that module located. Then it has some body where you can you have to define a name. That name will actually be used as a nested deployment name, and then you can or should provide any parameters that were declared in that module, and maybe pass through those from this main template declared parameters and variables. So that's how you sort of connect those. You can have as many modules in this main file as you like. You can even refer one module from another module. But what happens in in the end as a result, when you build using Bicep CLI, it will produce one deployment file with several nested deployments. So if you're familiar with linked and nested deployments are those that have actually embedded the entire template inside the main template. It's not referring to some external endpoint where you can find the code. So and one module equals one nested deployment. But of course, one module can contain as many resource declarations as you like. So that's how it would look like when you compile it. So that's a capability that is native to Bicep. I would also like to call out a second option, which I also find quite interesting, and it's a possibility to use template specs, which is yet another new feature in the ARM sort of language family, if you will, allowing you to store your templates directly in Azure, meaning that you will be able to refer to those templates like it was any other resource using its resource ID. So this is an example of using such deployment. If I just can highlight that variable storage template link ID I'm using resource ID function, and I'm using, since that my template spec, this particular one is stored in another resource group than where I'm deploying to. I need to sort of refer that one as well. It's the resource type is template specs versions, and then I'm just adding the spec name and version number. So in this way, I could also reuse the code that I have built in using template specs. But of course, then the deployment of those template specs to Azure is happening in a different workflow. It's not part of this one. So just to show you how it looks like, in Azure you have template spec and you have main template. It also can have nested templates. So template specs are a really interesting way how you can share your code base across teams, for instance. all you need in order to refer to this template spec is to have a reader access to the resource group where it was deployed. So that's it's not really directly related to Bicep, but I like the fact that you can combine these two and maybe leverage some of the new things coming to Azure Resource Manager. Template specs are in public preview, if I remember right. So the last part, I would just like to show you how you can automate this workflow using GitHub Workflows. So what I did is there is so many great articles and great content provided by the community. So I would like to call out Sebastian Graf. I probably pronounce his name incorrectly. He wrote an article about GitHub Actions for Project Bicep. So he created a custom action. Actually, there are two. So you can simply, of course, you can view the source code and inspect what it does, but more importantly, you can easily start consuming it. So in my YAML file for the workflow, I'm just checking out my code base. I'm logging into Azure, not using the Azure provided AZ login, but that's also Sebastian's action. And then I'm using the deploy using Bicep. So this action will first compile the Bicep file into ARM, and then it will also deploy it to a defined resource group and location. So just to show you how this looks like in my repo, and I must admit that I've been playing with it quite recently, and I don't think I managed to get it deployed end to end due to some small mistake. But it's an interesting way how you can sort of automate the deployment. Yeah, so there is some error I will need to work with, but feel free to create your own custom actions or just fork Sebastian's and maybe improve it and send him pull request. I believe he would appreciate it. So when it comes to the roadmap, just to close a bit. So code reuse, we talked about both modules and template specs. For the deployment using GitHub workflows, I will provide a full reference to the article that Sebastian wrote. And if we now look ahead and see what's coming, you can check the roadmap yourself using the projects in that Bicep repo on GitHub. But what is planned to come, hopefully January, February, is first of all, you are getting, they are planning to complete the parity with ARM templates. So everything that can be done using ARM JSON language should be possible in Bicep. They will complete the gap that is very much used, and this is loops or copy function and conditional deployments using conditions. And then possibility to deploy Bicep files directly from Azure CLI or PowerShell. And last but not least, it will probably reach like a support status by customer support services from Azure, meaning that it will be ready for production usage, and you will be able to create support requests if you run into any issues. So I think I would like to just provide the link to the repo, and of course I would encourage you to follow Bicep Blank on Twitter. So you will get any updates, what's coming, and they also publish events, community sessions that are streamed online. So that's a great way how you can meet other community members and hear directly from Alex Frankel and his team about the development of this great and interesting project. Okay, I think that's all from my side.
All right, thanks a lot. We're kind of short on time, so I just have one question for you. You showed a custom GitHub action that can deploy the Bicep file directly to Azure. Will we see dedicated tasks for that for Azure DevOps pipelines as well?
Yeah, so that's also something I probably forgot to mention. As of now, since the project is in this sort of early stage still, there is no like a official Microsoft provided GitHub action or Azure DevOps task or Azure pipeline task that would be coming from Microsoft. But if you sort of look into the what needs to be available in either in the GitHub runner or in pipeline agent in order to compile and deploy, it is really not much that you're missing. You just need to make sure that you download that Bicep CLI, depending on what agent you're planning to use, and then make sure that it can execute the compilation. And then you would use a regular AGCL, which is baked into to those, at least in Azure DevOps, it's baked into the agent and deploy.
Okay, awesome. One more thing I wanted to say, knowing which outputs you have available is awesome. Instead of having to look them up in the documentation everywhere. So thanks a lot.
Thank you. It was my pleasure, and thank you for the opportunity to talk on this in this great event.
Cool. Thank you.
Thanks.
Thank you.
All right, Suzanne. So next up, I think we have Chris.
Yes, we have Chris coming up, and well, Chris, I don't know if he needs an introduction. He's a long-time MVP all over the Belgium community. He is also organizer of the Cloud Brew conference. So how's that coming along, Chris?
Well, as I wanted to state in my presentation intro slide about myself, well, this year due to Cloud Brew, due to the pandemic, we couldn't organize Cloud Brew, unfortunately, because we're really looking forward to that, seeing all the people having a drink, have good sessions, great food, which we're also known for. So we had it for a year. So hopefully 2021, end of year, somewhere in December, we might do our Cloud Brew.
Oh, let's hope so, because, well, I think everybody who's watching as well, we can really use some great community and enjoy some brewed beverages as well.
Oh, yes. We're so looking forward to that. Seeing people again face to face, having a drink, sharing a laugh. Yeah.
Great. So you're going to do a session about Blazor. Really looking forward to it. So please take it away, Chris.
Okay. Let me start here by sharing my screen. When you can see my screen, please shout out. Okay, super. I see something upcoming. So good afternoon for all those people around the globe following this session of virtual Azure Community Day, 3rd of December right now. So welcome in this session about serverless web applications with Blazor. So first, a little bit about myself. I'm Chris van der Mast. I'm based in Belgium. So for me, it's like let's say 56 at the moment. I'm a Microsoft Most Valuable Professional, since 2007. First for ASP.NET, and around 2016, I became an Azure MVP. I'm also part of the ASP Insiders group. I also run, together with some other great people, the Belgian Azure user group, Azure. And as we just introduced, Cloud Brew, unfortunately not this year. We were also thinking about doing it virtual, but given the fact that so many conferences are nowadays virtual, and we really want to share the beer, hence the Cloud Brew part, we also want to share basically the beer, especially the very tasty Belgian beers. So we decided to move it to December next year. So hopefully, fingers crossed, we'll get the Cloud Brew next year. So with the pandemic, most of Belgian shops, for those people who are familiar with Belgium, we have a lot of small shops, like family shops and such in Belgium, who are not really on the internet yet, who didn't have a web shop or whatever. So I decided to make this presentation about a local web shop where I personally like to go. It's called the Broodbroeders, which is like 3 kilometers away from where I live. And you see all those smiley faces over there. Those are the people who actually work over there. 2 of them are the founders. They started around like 10 years ago. And as you can see, they've grown with quite some people. And it's still a very nice traditional artisanal shop. And they make very tasty bread, like you can see here, all based on sourdough. These, which are also very yummy. And yeah, my wife's favorite actually, some croissants. So really very nice and tasty. I sat down with those people. I asked them, by the way, permission to make use of all their images. So we're covered on that part. For them, the requirements is like it should be easy to use and the report should be in Excel. Okay, so I came up with the idea like, look, let's try to make some ingredients and make use of Blazor, some Azure Functions, Logic Apps, and because of the Excel, OneDrive and Excel Online. So traditionally, some person, and sorry about my drawing skills, I'm not as great as my father used to be. So this is a person who wants to buy something through a browser on the internet. And traditionally, you would put it on a server, connect with that, have some program running over there, and hopefully you get your bread. Of course, here you can print it out to either Excel, or traditionally you would also put it into a database. Now, this service traditionally puts on-prem, so basically in their local shop, somewhere here in my city, 3 kilometers away from me, I remember. But what if they want to scale out? Say, for example, they get like way more places and so much demand because everyone is ordering online nowadays. So they would have to scale out. Of course, they have a very tiny shop, so not that much place for such machines. Let's try to think like traditionally lift and shift to Azure, of course. All of a sudden, Azure, we would replace this like the local database running on a small server or a local machine. It would become like SQL Azure. And all the servers would most likely be lift and shift to Azure App Services. Pretty good, but you still pay an amount per server, per Azure App Service. And perhaps you don't need it because A, they're closed on Sundays. Perhaps people don't want to order back then or during the night. Perhaps also people don't order because I think there's like a cap at the moment for, let's say, after 4 o'clock, you're not allowed to order anymore for the day after. Such kind of things. So perhaps you don't constantly need all that power and payment at the end of the month. So I was thinking like serverless. Now let's go for this one, this small solution. So this is going to be a rather low cost, but one that's still scale out if you want to. So our person is going to still use a browser. It's going to download a Blazor WebAssembly app, which basically is something cool and new, running in the browser. It's going to connect to Azure Functions, which on its own is, well, I didn't want to write most of the logic myself or buy another component to write something to an Excel. So I had the feeling like, okay, we can put this through Excel Online on a OneDrive, which they can access. And there's also something like in the serverless space called Logic Apps, which has great connectors to connect either to SAP or whatever you want, but also to Excel Online to add extra rows into it. And with that, most of our slides are already gone. And let's try to go to demo time. And this is, of course, already going to be like one of the end results, basically our Excel file, which is running on a OneDrive. And as you can see, I tried again 8 minutes ago to make sure everything is still working. And this is basically what we want to have. Like at a certain date, something has been ordered, how much the total amount, by whom, and of course, this is a fake mobile phone number, so please don't dial that one. I just made it up. Okay, so let's get started. First, with the Blazor application. I'm first going to try to run everything on-prem on my local machine. And once that's done, I already have it prefetched in Azure because making a storage account and Azure Functions, it might take a while before it gets in. And we're very limited on time. So I'll show the end result when we get there. Now, let's start with Blazor app. And that can we do from the command line. We can also make use of Visual Studio, but I'm going to make use of Visual Studio Code because people also like to make use of other alternative operating systems besides Windows. So let's try that one. So .NET New, let's see if I can still type. Blazor WASM, and the output is going to be the Broadbrothers, because basically it's for them that we're creating something. Okay. Now, see. And if I do here, like, look, this has already been completely created by that using that template. And if I now go into code, I get to see this one. So what has been created over here? It's like a program.cs. And let's restore everything in the meantime. Okay, super. So this is how to start it up. Yes, I would like to have them now. What basically now just happened for those people who are not used to Visual Studio Code is that I created here, by accepting that one, some extra tasks and a launch. So whenever I now press F5 or start debugging, Visual Studio Code knows where to go to, set up the URLs, etc. Lovely. Now, in Blazor, we have an app.razor, and basically, as it needs to be running in the browser, it always needs like a place to go to, like an HTML page. And this index.html is going to be the root to go to. So here it tries to load in several CSS styles. And this is one of the most important parts, that blazor.webassembly.js. So yes, it's still a bridge between JavaScript trying to load in the Blazor components, which is basically .NET compiled, running inside the browser. And if you're worried about like, yeah, but this is perhaps too new, it will not run on my machine. Well, most of the browsers nowadays, also on mobile apps, will run Blazor. Basically, this is nothing more than WebAssembly, which is in standard, so you can use it in C#, my preferred language, but you can also run it in other languages, like, say, for example, Java or whatever. We're on the Microsoft stack, so we're going to make use of Blazor. Now, here you also see some pages, and people who are used to making use of ASP.NET MVC, they should know this syntax, this extension, sorry. So here we have an index page, just in hello world, a counter, which we're just going to run soon, and a fetch data. So let's try this one and just make use of terminal here. Let's open that one. Great. So I'm just going to do .NET run. It's going to build, because basically it needs to be built. It's an assembly, remember. Great. Sorry about my voice. I noticed yesterday that my voice is a bit deteriorating. It must be something in the air, I guess. I don't think it's going to be COVID, but just a regular cold or something. So I'll try to hold on. So basically, this is my index.razor page rendered. This is that counter, so I can click here, and I can fetch data. So this comes standard out of the box. Very easy, quickly up and running. As you can see, there's some styling over here. Now, about this, we'll see soon where it will come from. I can close this one. We are going to see like there's some funky, weird things here, and that's also being added by Blazor. So also the CSS is going to be transpiled by Blazor. So if you can see, instead of like just our page, it tries to make an extra selection over here. This is quite specific to Blazor. I'm not going to go too deep in it because this is virtual Azure Community Day. So but if you want to look more deeper into that, just be sure to study it a little bit. It's quite easy, actually. Okay, now let's go back to our code. And I can show this one. Okay, so we want to make like a small web shop. And we're going to create here a new page. And we're going to call that shop.razor. Be mindful, behind the scenes is going to be compiled to a class. So following the conventions, this should start with a capital letter. Otherwise, it will not compile and complain. This is our shop. And I'm going to be very lazy now. I'm just going to copy paste this one over. But we're going to soon change the small parts. So this I'm going to call shop. And let's see here. Shop, yeah, I don't need this one. And okay, so this should still work. Now, I come from the ASP.NET web forums, like way back down in 2002 timeline. And I'm not really much fan of putting code together with my Razor file. So I'm going to close this one over here. And also this one I'm going to take out. And I'm going to create a new file called shop.cs. I'm going to need a namespace into this. And this is going to be worldbuilders.pages. And this I'm going to write a public partial class called shop. I want to inherit from component base. Okay. Now, let's add in some code from my code snippet, if I can reach to it. Okay. Okay. So what do I have here? Okay, I need to add some class. And first I'm going to use here these ones. Okay, super. I'm having problems with switching my screens apparently. So let's add in some code. Oh, seems my mouse is not working correctly. I had some problems with this computer today. let's add that one. And sorry about that. And some products. Okay. Okay, so these are some side classes that I will be needing. And let's see if now things will work. Okay, I got here, got my icon lookup. So basically, this is going to be generics inside the browser. So you might as well do that. Because we're going to have a web shop, we're also going to need a couple of images. And let me copy paste those in underneath the root. Add folders to workspace, or just, okay, let's copy these over. So here I have some JSON class. And here I have some images. Let's say, for example, here, some of our bread or whatever we're going to make use of. This is a simple part, okay? And apparently here, this one is not very much liked. So let's make this products. And products comes from this protected variable over here. And there's another one here. That's of course because I copy pasted it. So let's say again here. And now a part of my code here. And replace this one. Great. So if all now goes okay, I should be able to run this. I can also here add something over here to my product. So whenever I click one of my button, that button in the row, it will update that. Now let's try to run this again. I'm going to shut down this one because now, since recently .NET 5 came out, and the nice thing about this is that I can now watch something being done. Okay. So let's see here. Shop. Okay, super. Now let's see if I can just do this. As you can see, I'm not a designer, so. Okay. And let's add this side, and let's add this one to that side, so that we can see if something is going to happen over here. Great. I would like to show, because I was calculating the quantity. As you can see, I have lovely IntelliSense over here. And now, because I changed something over here, it got automatically saved. You can see here directly in the browser, you get an update. So let's see if I can update this again. Let's add that one. Great. So 34 plus, basically we made a calculator at the moment. Cool. I like the layout, but it still says here like date, date, date. Let's try to make it a bit more sporty looking. Okay. And let's see. And this one over here. Let's go to this one. And instead of just showing this, we're going to show this one. Again, and let's see if everything works. Okay. And let's see if this still works. And then I click add over here. Okay, super. So basically what was done over here is I made a looked up products, which is going to be of type I look up day of week, hence what you see over here, the Tuesday or the Wednesday, and again, the same product. So here I made use in the browser, I can't stress it enough, I made use of generics and then link. So pretty cool. No more heavy JavaScript duty or whatever anymore. Just beautiful code in C#. If you like that, I like it too. So now we also have like a function, because I told you guys we're going to make use of Azure Functions. So what I'm going to do here is I'm going to create a new function. And as I already shown you before, I have here several already. Let's see. And I'm going to create here a new project. And no, let's go to, I think I put the other one in here. And just and I'm going to make use of a C# one. I'm going to make use of a HTTP trigger. And I'm going to call this one current data. And this is okay for the moment. It's going to be anonymous. And I opened it in the current browser. Okay, so this is some template code created by the generator. And we're going to take basically most of this out. Restore. Okay. That's nice. First and foremost, before I continue, I would like to try and test this one out locally. So what I can do is in my local settings over here, I can add here cross origin. So by this wildcard, it means like I can call it from any other website locally, because my Blazor application is running on localhost port 5000 or 5001 for HTTPS. And my function is going to run on this local HTTP port. Let's quickly see if I got this correct. Okay, super. This one can go. This one can also go. I just want to leave the log information. And let's quickly see over here. Okay. So basically, there's nothing going to do but the current date time of the server. Okay. Let's see if I can start this with debugging, because I would like to put a breakpoint over here. So if all went well, I can go and call this one. And it should show the date and time. If I go to my breakpoint, of course, let's take that breakpoint away for future reference. But as you can see, you can easily locally debug an Azure function. Okay, so let's try that again. you see here some processing and logging thanks to this one over here. Okay, let's stop this one. I'm also going to add future reference, this one, which is going to be like another function, which is called purchase. It's only going to be post. So this one is get. So basically I could take out this one for the moment. And let's copy in some other classes for this one. Okay, super. I'm going to copy paste these already here. Okay, great. So everything should work here. I got here some errors, so generic collection. Okay, super, should work. Now in my Blazor application, we'd like to get the date and time of our service. So in our initialize task, we're also going to put a call to our service. And we're going to call that like this. And of course, we need here a date time called current date. See here. Sorry, I'm going to call this a string just to make sure. Okay, so this would correspond to this and call this one. So let's see here. I'm going to put here a breakpoint. I'm already going to run this because, as you saw, this takes a little bit. Okay, that's not so nice. Let's see here. Okay, this one. This should supposedly run. Let's try that again. Oh, that's because I'm making use of system.text.json. And apparently the template comes with the former version of newtonsoft.json. So there was a namespace collision over there. Okay, so while this is running, takes a while. As you can see, also our next, our other function over here got here. So 771. Okay, that looks exactly the same thing. So now if I run this one, and over here, let's see, over here, this should hold the result, basically the current date time of the server, thanks to an Azure function. Okay, so let's start this one. Net run. So here I got into my breakpoint, coming from our Blazor application. And if all goes well, I got here the exact same time. And let's try it again, just to make sure. As you can see here, our function gets hit. Okay, cool. I can close these two. Let me see, how am I doing on time? For the people in the Netherlands, I still have enough time to go on? No response, so I guess we're good. Okay. And I'm going to let this run over here. Sorry. This one that I need to be in. As you saw, it's always a bit annoying to, for me to keep on typing like in the browser that shop. So let's fix that one. And let's go here to shared. This is our main layout, and I need to be in our nav menu. So I'm just going to copy paste this one. Don't have to type everything myself. We called it our shop. And let's call this shop. Now, this name corresponds to this name. So now whenever I go, see, I didn't call. I didn't build, of course, because I didn't use .NET Run. Let's see here. So as you can see, you have to recompile whenever you do something, because behind the scenes, this is all being translated to C# files, being compiled into an assembly and run off there. So now let's see over here. So here's my shop, and everything is still good. Okay, great. I don't need this. It will go away. Now my file over here, whenever I do something, of course, I also want to send in a purchase. And let's grab it over here. And let's quickly add some test code just to see if that works. Okay, list order. I need to put in again, generics. Okay. My service over here is still running supposedly. And let's add over here a breakpoint. Sure here, okay. Now. I think it's a better command to use at the moment. So let's start this one. Okay. Now let's say we're going to buy 9 of these and 5 of these. Now, let's go here and debug. And as you can see, I got 2 orders because I made up some sample code. And now we're going to send it to our logic app service. So here I'm going to flatten down things. I would serve everything over here. Now, this morning, when I was rehearsing again this application, and that's why I'm a bit nervous at the moment, is because it didn't work anymore. For some reason, with the latest new version of this that I tried, my call to my logic app made things go awry. So basically, it didn't work out for me anymore. But luckily, I have a backup solution to make it run. So if I now can go into this one, so basically now this would just call my logic app on Azure. I'm going to stop this one, and I'm going to try to get rid of this one. Okay, and that doesn't want to seem to go. Okay, it wants to go away. Super. So what I can do here is make a new file and copy over these. And we're going to mimic, just like I would call a post to my service. So basically, this is my workflow. We're going to show that soon, what's going to happen. So here I'm going to say Susie, and let's say Henk is also in the call. And Henk likes to eat a lot of croissants over there. So, and thanks to the REST client, I'm going to now call this one. So as you can see, it's pretty fast. It only took like 300 milliseconds to call and get a response back. So basically, what I did now over here is just mimic what I would normally do here in code. And as I told you since this morning, when I looked into it anymore, this is exactly the same service, but unfortunately, somehow the JSON didn't get accepted anymore. So I don't know if it's like due to a new version since recently that I tried it, or something else. So I have to figure it out later on. I might put a blog post about it later on as well. But luckily, I can still make it work like this. If you're curious of what I'm using here, this is basically just like an extension, and I have quite many extensions, as you can see over here. So also for Azure Functions, Storage, Azure, for C#, nice looking theme what I'm using right now. And the one that I'm looking here for now is called REST Client. That's this one. So thanks to REST Client, you can do things like what I just did over here. So there's a nice explanation if you want to get used to it. I also like to use it instead of Postman. If I don't want to open Postman and I'm already in Visual Studio Code, I can make use of this one. So if you want to try that out by yourself, it works, and it works very nicely. Okay, super. So let's see. Look, and already, so you can see I'm not kidding you. I ordered Henk instead of Suzanne during my other things, my other presentations over here. So this gets added. So how did I set this one up? I created a new OneDrive. I added a new Excel workbook. And here I gave the date. And say, for example, I can do here like 12/3/2020. And let's make that Chris. Now the magic trick is over here to select these and insert a table. So this is how you make up a table. And that's also what you need from Logic Apps, so that you can connect those two things together. Now that I showed you those, so here it comes in. So you saw here just like these just got called in. Let's try that one again, just to make sure that I'm not kidding you. And it takes a bit of time. Let's say and Ome Henk from a very famous TV show in the Netherlands in the past. Let's make this 48 croissants. Of course, it also needs to be a bit more expensive. That one again. And hopefully in a couple of seconds, look here. So Ome Henk got here and got 48 croissants. So you see, that's still working. Now, how did I create that one? is just by going to a logic app. So what I create is a new logic app. And whenever HTTP request is received, we're going to do this. So basically, that's an address. Yes, I got that. Thank you very much. So I created here a whenever a new logic app in the designer online, and this is being generated by me if I put in like a sample code. So basically, what I did is just that same JSON collection that I just showed you to put in the post command. I entered that over here. It made up a small scheme over here. The next step is because, yeah, it just received something, but what should we do with it? So I took here the body, and as you can see here, I have many other things that I can make use of what it gets in. And here we're going to parse that one. And then the next step, because this is a collection, I want to have like row per row, item per item that I get in through my JSON collection. I want to write it down in that Excel online file. So here in the for each, I make use of the body from that former step, which came in here. What I also find handy is that this color corresponds to this color. So this is a for each control. And here I have my Excel file. So here I can connect that one. I can go to Broadrooters, for example. And here I can select my Excel online file. And, oops, sorry. And here I can select then the table. So because it's Excel online, I didn't open it in an Excel on desktop. It just gives me the table one. Otherwise, I could change it over here. And this is basically like, yeah, all the things from the JSON that got parsed from the former step that's being shown here as as another step. Sorry, as a variable that I can make use of here. So here I'm going to correspond in my JSON file. So the JSON request that I sent and parsed, I can make here use of date, type, quantity, and such. And then thanks to this one, add a row into a table, which is something from Logic Apps itself. I can have that part inserted into my Excel file, like you just saw here. Now, so far we have been using everything here offline on my PC. So even I want to create, say, for example, this can go away. Even I want to make and upload that, it's going to take some time. So I already did that before. But for the function app, I can just say here, like deploy to a function app service. I select my description, for example. And I can create a new one. And testing this one out, just to be globally unique. This not yet .NET 5.0, and here in West Europe, and here it would send this one out. And for the shop, it's something similar. We're going to put it online on a storage account. So what we need to do here now, the following step is we're going to publish our local assembly, .NET publish. So here's going to create a DLL file. And it's going to be here under the another publish whenever it's done over here. So it's doing some tree shaking over here, compressing, so it's not too big. Should show up here soon. In the meantime, I can already go here to storage, create a new storage account. Okay, that's unique enough. Okay, so this one is ready at the meantime. I think I made a small mistake over here. Either way, this is going to keep on running. So I already did that before you. Look, so now basically what you can do is in this publish file, right click on this .root, so because basically here you're going to see the index.html file that we've seen before. Basically, this is your starter point. And this is an important one. It has been enabled for static web hosting. Okay. I don't know why it's put here that this one it's trying to make something, but it's not finding anything. So that's good. So what we now can do here, for example, is deploy the static website via Azure Storage. And I'm going to make use of this one over here. And I just made a Azure test, if I recall correctly, Blazor. As you can see, I've been trying test on this account a lot already. And now it should start. Of course, what I didn't do in this sample is basically not change all these URLs. So these URLs are still pointing out to the local version and not to the version which are going to be deployed online. So make sure if you have like a DevOps scenario that you put these keys in. I just want to show like how do you deploy that over there. Just make sure that you get the URL from the functions. Let's see, I put it over here. Say, for example, you want to go over here. This is a sample that I created before. And here I can see, for example, functions. And here I can copy the function URL, for example. Let's try. Let's put this in comment. I just want to make sure that we're going to get at least the time over here. And we're going to .NET publish that one again. See, it's now a bit faster. And the reason why I do it twice is because I want to show you like, yeah, it will show you another pop-up, meaning like, hey, I want to replace something. So basically replacing means deleting stuff and then later on uploading it again. So this is done. Again, under the publish. And make use of this one again. So now soon it will say, voila, delete and deploy. I feel my voice going down, so I'm going to drink quickly. It's taking a bit longer than I expected. It's okay. Well, as we're going to wait for this a little short, I'm going to round up over here. So let's go back to this one. Hopefully you like the demo. There's now some part for Q&A that I need to keep open. And of course, if you want to reach out, you can connect to me on Twitter or send me some email. And let's see over here if this one is slower going to upload. It's taking a bit longer than usual, which should be okay. So Henk, back to you. Are there some questions so far?
So thanks. We're still looking for Henk over here, but you'll have to do with me. So one of the questions I have is Blazor or maybe WebAssembly in general going to be taking over from JavaScript altogether?
Well, I get that question from my brother-in-law, who is a renowned JavaScript author. Well, he's writing a lot of articles about mostly nowadays Vue.js and Angular. Is going to replace, I think there's going to be place for both of them. There's still so many people out there who have been writing JavaScript, also in combination with, for example, Node.js or whatever. So JavaScript is still going to be there for quite some foreseeable time. For me personally, Blazor is interesting because even though I wrote a lot of JavaScript during the last years, I've been making use since I think 1997 I was on the web. So I was trying to fill out JavaScript or whatever it was back then in very old browsers. I also played around with Vue.js, with jQuery, a lot of time of production-ready applications. Also with Vue, with Angular, I also fiddled a bit around with React. But the last couple of years, I did mostly backend development. And so a lot of C#, so it kind of watered down my JavaScript knowledge. Whenever I take a look, I can still read it, I can still see it, but I'm not really following up on all those big fancy things anymore, like Angular or whatever. So if I want to do some new stuff with that, I would have to learn it again. But with Blazor, I can keep on writing C# code. So for me as a developer, I can be more productive more easily, faster, because I can stay in the language that I know and love. So from that point of view, for me personally, Blazor is actually like, the next best thing, because otherwise I have to go and study again. I don't mind that, but for being productive and quickly, so say for example, like half a year ago, I was in need of a dashboard application at my customer. And instead of trying to figure out like, how should I do it? Which framework should I use? I was just like, oh yeah, there's Blazor. Let's try that out. And that's how I got also rolled into Blazor. And for me, it was actually very easy to set something up. So within a day, I had a full dashboard application that's still into production right now.
All right, so it stays around, but Blazor is there to stay as well.
Yes, I think there's an ecosystem. There's a place for both of them. I think, especially people who are more fond of using their own language, like say Python or Node.js or Java or whatever, they can create something that compiles into WebAssembly, because WebAssembly is not proprietary to Microsoft alone. It's just Blazor, which is the flavor of Microsoft to create WebAssembly applications. So I think WebAssembly on its own might be very interesting. The most important thing is also we don't need a plugin like we used to have for Flash or Silverlight in the past. And I think that's a big advantage. So it's now baked into the browser. It's fully supported by all major browser vendors. And that's why I think it has a future.
Cool stuff. Okay, you showed us a whole lot of stuff in about an hour, I think. And we really want to thank you for that. And with that, I want to hand over to Suzanne.
Yes, thank you. Okay. And hope to see you again soon, and hopefully in person at one point.
Oh, yes.
Okay, so we have a lot of great stuff coming up for the rest of the day. We will have a session about KIDA. We will talk about security, about serverless, hosting your WordPress site, automating your social life. There's a lot of stuff going on today. So check the schedule below. Also, we have a Cloud Skills Challenge, and you can win a backpack. The URL is down below here, aka.ms/VACD challenge. And you can win and have some fun. So just join the challenge and join the fun. We're going out for a very, very short break. And after the short break, we are going to listen to Eleftheria Batsu about how to design with your users' needs and expectations in mind. Yes, I would like to say see you after the break. but that's not true because our hosting duty is unfortunately over. So we are going to switch around in the break, and after you will see the new hosts. Thank you, and stay tuned.
Bye-bye.
Hello everybody and welcome to my session. It's easy to create a good looking product, but how about useful ones? My name is Eleftheria and thank you very much for the invitation. It's an honor talking here, and I think that we already had some amazing talks by some amazing speakers. Feel free to catch me on my social media. I'm quite active on Twitter, but also you can find me on my email or on my Instagram. Now I think that without further ado, we can start. First, the contents. We are going to talk about UX versus UI. What is UX? What is UI? How you can use it? What's the differences between those two things? We will continue with heuristics and we will see what are they, why are they important, and how you can benefit from them even if you are a developer. We will see the 10 usability heuristics and we will continue with the do's and don'ts of UX, and the same we will do with the UI. Okay, so UX and UI. If you search over the internet, you will find like a ton of content out there, but what's different here is that we will try to cover these two topics from two different angles. One is the angle of the user, and the other is the perspective of the designer. And although, again, as I said, you may find a ton of content out there, most of them, I'm afraid, they are doing a poor job just because they are covering only one of those two perspectives. So let's get started. We will start from the user's perspective, as I think it's a bit easier to be understood. Now, from the user's perspective, a user interface is what a user interacts with in a product, what taps or clicks on, and the whole experience is localized in a device, like a device like a mobile phone or a laptop. But from the other hand, like the user experience is how a user interacts with a product, how a user feels with it, like is he cracking a smile, is he moody, and again the whole experience is localized in the physical body. So just by looking someone like working with an app, you can understand if he or she is happy or not. Now let's talk a little bit about the perspective of the designer, and here things are a little bit different. I will start with an analogy. When you see a big icicle like that one in the image, you only see the tip of that huge icicle, but beneath that one is a whole mountain. Now, if we want to transfer this analogy to the UX world, we would say that the UI is the top of that icicle, but the UX is what lies beneath that top. So from the designer's perspective, the user interface is what you can see and interact with, but the user experience is what you can see alongside with what you can't see, and everything that holds everything together. So let's go a little bit deeper this time and try to give you some more details, and hopefully you will understand these two terms a little bit better. Again, let's start with UX. So UX can be subjective, meaning that like some questions that we can ask is, does the user connect emotionally with the app by cracking a smile? Are the icons and illustrations understandable enough? Is the user pleasantly surprised by an animation or a feedback? And from the other hand, it can be also objective. Does the user actually accomplish what he or she wants to do? Is the speed of response satisfactory? And is the swiping gesture more effective than a tap? All of those things are questions that can be answered with UX. UX has to do a lot with the usefulness and the satisfaction of a product. These two are like the key words, satisfaction and usefulness. So let's also see an example. What app would you prefer? And we will talk about a ride-sharing app. Would you prefer a sharing app that doesn't let you save your favorite destinations, doesn't let you have like multiple stops for you and your friends, doesn't show you in real time where you are, where your driver is, or where you're heading at? Or would you prefer a different kind of app, which this time it will let you have your favorites, favorite destinations, will let you have multiple stops again for you and your friends. It's going to be quickly, it's going to let you do things with 1 or 2 taps. So which one would you prefer? Okay, that one was a drastical example, but I think that you get the point. And sometimes when we are working on our own products, because we know our products, we feel that everything is fine, everything is cool, everyone can understand our product. But try to give it to a user and not explaining to him or her like anything about your product. Will he or she will be able to use your product? Will they be able to find everything in your product? Let's see. So I hope that by now I have convinced you why UX is so important, but let's also do a quick recap. So UX is important because at its core, it's about putting people before technology. It focuses always on create positive experiences for the user, and by some results, by some techniques and some methods, it creates beautiful, useful product, which in the end is a win-win situations both for the users and the business. So now, what does a UX designer really do? And before I give you the answer on that question, we will do a quick history lesson. Yeah, it's going to be a quick one, so don't worry about that. Everything started by this person in the picture that you're seeing right now. This is Don Norman, and this is the father of UX. He originated in the late 80s with Apple's, and he started as an engineer, but then he also continued with his studies by being a psychologist, and he focused on observing people and observing how they were using computers and how they were using machines. So he was a pioneer in that field. Before him, no one observed how people interact with machines. So he started then working with Apple, and now Apple is what we know it is. Now I'm not going to get a lot of details because I promised you that it would be a quick lesson, a history lesson, but also do take notice that if you want to learn more, Don Norman has also written a ton of books, and one of the most famous one is The Design of Everyday Things. Side note here, you can also find it for free over the internet. So yep, let's go back to our question, which was, what does a UX designer do? And the simple answer is UX solves real problems for people, and UXers practice the UX. Now, UXers are the facilitators who brings everyone to the table together. So not only other designers, but also programmers, marketeers, and of course users. Users are the most important thing for UX designer. So the UX designer, since he has his user, he will ask some questions like, who are the users and what do they want? What are the main features the user needs? What are their current behaviors? How will the product connect with them? What type of content users want and need? And last but not least, what does the product look like? And when they have the answers to these questions, they will go in multiple rounds, in multiple circles, and they will ask more questions. And again, not only to users, but to other people as well, like again, marketeers, programmers, stakeholders, everything and everyone that has to do something with the product. So continuing a little bit more, we can see this pyramid here, and these are some of the things that the UX designer will have to do. Very quickly, let's see them. I will start from the bottom to top. We have user research and analysis, content strategy, information architecture, interaction design, and the visual design. Now again, starting from the bottom to top, a UX designer has to do a lot of things that has to do with user research. Some of those things are user interviews, user behavior studies, focus groups and surveys. And when he has like all the information that he needs or she needs, then he can continue with creating user personas, user stories, empathy maps, and customer journeys. And when again we have all those information, and only then we can continue to the next level, the next step, which is the content strategy. This is a really crucial step. Some people may think it's quite boring because the designer has to do things such as writing product copy and micro copy, selecting the right wording and tone for the target users, and writing emails, messaging, and designing emails. But after this step is also complete, the designer can continue with the information architecture. This is again like a really important step. It connects the two previous one with the two next that will come. And like how the data is organized and presented to the user plays a really big role on how the user will perceive the product and how he is going to use it. So in this stage, some of the things that has to be done are card sorting, sitemaps, wireframes, and user flows. If we continue a little bit more, we have the interaction design and the visual design. In the interaction design, here not only the UX will work, but also the UI designer. We will talk about the UI designer in a bit, so stay with me. Let's continue with the UX designer. In that step, the designer will have to see the user interfaces that are easy to navigate. He will have to work with micro interactions that enhance feedback, screen states for real-time system status, and interactive prototypes for user testing. And in the last step, in the visual design, we have to make sure that some design principles are there and we are working according to those things, according to those standards. And some things here that we have to take care of are combining colors effectively, using typography, and also having some icons and illustrations and images that are satisfactory for the user. Okay, so by now I think that you have understood quite well what is a UX designer, what he does, and what is this discipline. And now we can continue with the UI designer, and we are going to follow the same structure, and we will start with what is UI. Hint, it's not only how it looks. Now, a lot of people think that UI has to do only with the colors, only with the icons, only with the images, and that's about it. If you are one of those people, you are wrong. I'm sorry. UI designer has more to do with other things as well, and I'm going to give you an example with that. UI design is, for example, that image that you see here. UI design is not only visual, but it can be audible too. Imagine Siri or Alexa from Amazon. Like, you can just shout out to a machine and it will give you an answer. It will tell you the temperature, the time, it will play songs, it will change the temperature of your room. It can do so many incredibly things. This is UI, this is audible. Now let me give you another example as well. UI design can be also textual. I didn't say I'm going to give you a good example. I just said I'm going to give you an example. Imagine the terminal, like the CMD. It's just, usually at least, it's just a black screen, and you type something usually with white color, and you have like a minimal type family and font size. It's something very, very minimal, but again, this is UI design. Okay, so now let's see why UI is so important. A well-designed UI adds value to product. It creates a friendly environment that users can establish. It establishes a strong and clear visual language, and it creates smooth interactions and an enriching experience. Now, what does a UI designer do? And this time I'm going to show you again this pyramid, but we will focus only on the two top levels, the interaction design and the visual design. So in these two stages, in the interaction design, the designer focuses on the surface details, yes, such as colors, buttons, typography, but not only that, he will give the finishing touches to the whole product and experience. And a UI designer is somebody that has to have like a lot of knowledges in many different things, such as typography, color theory, iconography, illustration, visual hierarchy, alignment, layout, spacing, readability, and contrast, and again, like many more things. And then in the last step, in the visual design, here the focus is on possible variations of the screen and how it will respond to the user's input. Everything has to be covered, and in this stage the UI designer has to apply design patterns effectively, create component libraries, and establish complete design systems. Also, don't forget that technology changes all the time, so a UI designer has to be very well informed about the latest trends, which can be quite tricky. Alright, I hope that by now you have understood the differences between UX and UI, and I hope that you have understand a little bit better what a UI designer do and what a UX designer do. We cannot have UI without UX. UI is a part of UX, so these two forms are really connected. From the perspective of the user, these two perspectives, like these two disciplines are quite distinguished. So a user can understand what is UX and what is UI, but from the perspective of the designer, these two disciplines are more connected. Now we will change gears a little bit and we will start talking about heuristics. So what is a heuristic evaluation and why do you need it and how you can take benefit from it as a developer. In simple terms, like in a nutshell, heuristic is about making decisions with the information that you already have. And I will start with a quote here, a quote from Don Norman that I really like. Good design is actually a lot harder to notice than poor design, in part because good designs fit our needs so well that the design is invincible. Think about that. It's easy to create a good looking product, but how about a useful and a product with satisfaction for the user? Now let's see heuristics. What are they? So heuristics and heuristic evaluation is a key part of designing a great product that users can easily engage with and find value in their interaction. The purpose behind that is to detect usability issues that may occur when users interact with the product and also find ways to solve those problems. And it's conducted against a predetermined set of usability principles known as heuristics. And we are going to talk about those heuristics in a bit. Now, although there are numerous heuristics and numerous ways to inspect them, we will not focus on everything due to time, obviously, but also because the efficiency and the validity are different, although the end goal may be quite similar. I'm going to show you the one that you can see on the third column, the heuristic analysis. So let's dive into that. How to conduct an effective heuristic evaluation. The heuristic evaluation is something that it's being done in steps, but these steps are like well thought. You have to make some research before you start the heuristic evaluation, and you have to follow a specific order. Let's check that one. So the first thing that you have to do is to define the scope of your evaluation and ask yourself, what do I want to test? I think that this is one of the most important steps. Secondly, know your end user. Who is this product for? Who are you developing for? Continue with choosing your set of heuristics and which usability principles should be followed. Continue with setting up an evaluation system and identifying the issues. How will evaluators assess and report a usability issue? And last but not least, analyze and summarize the findings. Like, what do the findings show? Again, this is one of the most important steps, because maybe you did your research, maybe you know your users, maybe even you have like a pretty much good product, but how you can improve that, what your findings are, and how you can benefit from there. You have to analyze them. Let's also see another quote, another statistic that I find quite impressive, that says appointing 5 to 8 heuristic evaluators should identify over 80% of usability hitches. This is a big number, and you can understand how important is heuristic evaluation. Now let's dive into the third part of this session, which is the 10 usability heuristics by Jacob Nielsen. And as we said earlier, Jacob Nielsen is the father of UX. Him with Don Norman, they wrote a manifest which included like the 10 usability heuristics, which is something like the 10 rules that you should be following. Let's start. So the first one is visibility of system status. Always show to your users the things that they have to see. Imagine, for example, your mobile phone. Like, even if you hold it right now, you will see quite a few information, such as the time, the notifications. So if you have like emails, you will see the temperature, and I don't know, maybe you will see your steps. If you have a counter, you will see a lot of things. How would you feel if those things weren't there, if someone like removed those things for you? Wouldn't you feel quite weird, like something is missing? So always show to your users the things that they have to see. The second rule is match between the system and the real world. Users use other apps, so they know some things how they work. Don't try to change those things. Something that we have here is this skeuomorphism design. What this means is that as a designer, you will try sometimes to design something as it is in the real world. For example, think the icon that you have from the compass on your mobile phone, or a folder on your mobile phone, or I don't know, the bin maybe. The trash bin, it's exactly the same as we have them in real life. This is because we want to have some similarities between the real world and our phones, so everything is a little bit easier for the user. Don't try to change everything. The third rule is user control and freedom. Give your user the freedom to do what he or she wants to, and always have like something like an emergency exit mechanism. This can be an undo action, this can be a trash bin. You always have to have something for the user to click away from it, because sometimes the user will just misclick something. Maybe he is in a hurry, he won't take care of something that he or she should be. So always have that mechanism to go back. The other thing, which personally I find it one of the most important things, is consistency and standard. Just because you are different doesn't mean that you are useful. Think about that. And again, like 80% of your users, not 80% of your users, but the users, 80% of their time will use other apps and not yours, or other products and not yours. So again, they know how some things work. Don't try to change them. Think of the functionality of copy and paste, for example. It works everywhere. the same. You don't have to change that. Let's continue with the fifth rule, which is error prevention. Again, this is something like quite important. It's believed that there are two kinds of errors. One of them is the sleeps and the other one is the mistakes. Now, on the sleeps, the user will do some errors just because he's not very careful, and yeah, you cannot do a lot of things about that. But as we said, you should always try to have some feedback mechanisms, or you should have some clear exit buttons so he can undo the action that he tried to do. From the other hand, like the second part of the errors is the mistakes. This one is a bit more serious because it means that the mental model is wrong, and it should be the mistake should be something that it should be found in the testing phase. And this means that the user wants to do something but he cannot accomplish it because maybe there is an error, but it doesn't have to do anything with the user. It has to do with the way the product has been designed. Let's continue now with the sixth one, which is recognition rather than recall. Again, we have two different types of memory. We have recognition and we have recall. Recall is when you try to think and try to remember about something. Usually this has to do with numbers and sometimes with people with names.
So, welcome back everybody. We've made a quick host change over the last session. My name is Jorrit Meijer and I will be hosting the next few sessions together with Esther. Maybe a short introduction is in order, Esther.
Well, for those of you who missed the opening session, I'm Esther Bartel. I'm a technical consultant, end-user computing background, and currently switching to DevOps and Cloud DevOps.
My name is Jorrit Meijer. I am a co-organizer of Azure Thursday Meetup, and we are also organizing this event today here from the studio. It's very nice to be here. My first time on an event like this, but yeah, I'm looking forward to the next sessions. So the next session will be from Erwin Staal, and I don't know if he's already in the session, but let's bring him in.
I am, yes.
Hi Erwin, how are you?
Hi, good afternoon. Fine, thank you.
Great. So yeah, I've read something about you, and so I've seen that you're calling yourself a DevOps engineer, but also an architect, which really is interesting to me. So how do you make that work?
Well, what I like to do in my job is I always like to be in multiple areas. So I do like developing stuff, thinking about how we can architecture our systems, but also really like thinking about and making sure that if we make a change in code or configuration, how do we get that into production as fast and safe as we can? So I kind of like to be in all of those fields at the same time. That's what I really love to do.
Yeah, I can relate to that. I'm feeling quite the same, working as an architect, but being also heavily involved with the DevOps team. So, and today you will be doing a session about serverless architectures, right? And event-driven, KIDA. Yeah, I think without further ado, let's go to your session because we're really looking forward to it.
All right, cool.
Good luck.
Let me share my screen. Here's the one. All right, so for the next 35 to 40 minutes, we're going to talk about KIDA. KIDA stands for Kubernetes-based event-driven autoscaling. So KIDA basically is a component, a thing that we can install on any Kubernetes cluster. And that helps us then to do event-driven autoscaling on Kubernetes. Because as we will see in a bit, that is something that Kubernetes cannot do by default. So that's where KIDA comes in. And it really, really makes it simple to do event-driven autoscaling on Kubernetes, as you will hopefully find after the demos. So we already talked about me a bit, so we can skip this one. I'm from the Netherlands. That's probably the only thing we didn't talk about yet. All right, so before we dive into Kubernetes and Kata, I want to go very quickly over what is a container and what is Kubernetes, so that whoever hasn't done anything with Kubernetes at all yet can still follow this session and can still see where Kata fits in and what it can do for you. So I'll make it really quick for those who do have experience. So what is a container? A container is this very simple, lightweight package that contains whatever your application needs to actually run. So where in the past you had to install all the dependencies on a virtual machine, for example, to run your application, make sure there was a web server available, all that stuff you now put in the container, and all your virtual machine or your hardware now needs is something to run that container, a container runtime. As long as that is available, then your container will run there. You don't need all the specific dependencies of your application anymore because they are in the container, making it very flexible. But just having a container isn't enough. Especially when you want to run a container in a production environment, you probably want stuff like high availability and fault tolerance and stuff like that. So we need something to manage all of those containers in production for us. And that's where Kubernetes comes in. It's a container orchestrator, and there are more out there, but Kubernetes is by far the most well-known and most used one out there. It's available on all of the bigger cloud service providers, etc. So Kubernetes mainly consists of two main components, which are the masters and which are the workers. And the master is responsible for making sure that what you want to run on your cluster, what you tell it to run, that it actually does run on your cluster. And the workers are then responsible for doing the actual work. That's where your application will actually run. And then if you want to run anything on your Kubernetes cluster, you provide your master with a definition on what you want to run. So you could, for example, give it a YAML file, which specifies the application you want to run. This is a very simple one. It's not even complete. I don't even think it runs, but you'll get the idea of how that would work. So you would have to specify a few things in this file, like what is the container you actually want to run? Here it's a Grafana container. On which port do you want it to run? And how many instances, how many replicas of your application do you want to run? So you create this file and you give it to the API of a master, and that master will then try to figure out where to run that particular workload and try to divide it over the workers you have available in your cluster. And it will then continuously try to monitor if the state you told it to be in that application, the YAML, if that's always the state in your cluster. So if in the unlikelihood event that a worker would go down because of a power outage or a network failure, for example, then the master would notice that you no longer have 3 replicas running, but then now just 2. And the master will try to get that fixed for you by moving that workload into another worker, making sure that it still fulfills your needs that you specified in the YAML file. So that's kind of the basics of Kubernetes and getting something deployed here. So let's dive a bit into how scaling works. So scaling in general could be done horizontally or in a vertical manner. By horizontal, we mean that we would add additional machines to our compute resources. So we could add an additional virtual machine or additional hardware. By vertical scaling, we mean that we resize the machines we already have. So we could be adding additional CPUs, we could be adding additional memory, stuff like that. If we then look at what there is by default in Kubernetes in terms of auto-scaling, then this is kind of the table that we get. So there's again horizontal scaling and vertical scaling. And in Kubernetes, we can do that based on nodes or the pods. And pods are kind of the smallest thing that we can run on a Kubernetes cluster. For now, for the sake of simplicity, see a pod as just a container. So we can scale the number of nodes in our cluster, and we can also scale the number of containers, the number of pods that run on it. So in terms of horizontal, we can simply add or remove nodes or pods to get more compute resources if we need it. And in terms of vertical scaling, we could resize the number of the nodes, add more CPUs, more memory, etc., to the existing nodes we have in our cluster. And since we can also limit the amount of resources a pod is allowed to use, we could also play with that to give it more or less resources as it needs. And it depends a bit on where you run your Kubernetes cluster and which version, etc., which of these features you actually get, because not all of the Kubernetes versions on all of the cloud vendors, for example, have all of these 4 auto-scaling options available. So we would have to look into the documentation to find out what you can specifically use on your cluster. But the thing is always that this whole scaling thing that's by default in Kubernetes can only react to the symptom. It can only see, for example, that the CPU is going up or memory is running low, but it can't react to the actual cause of why that is happening. And that's where Kada comes in, because Kada can. With Kada, we can do event-driven auto-scaling and actually react to events instead of to CPU usage going up. We can also install Kada on any Kubernetes cluster we like, in any cloud, on your local machine, doesn't matter. And that's very easy, very simple to do with the Helm charts that are available for you. So this is a bit of an architectural overview of Kada. So let's go through it. As you can see, Kada only kind of consists of 3 components, and it really tries to leverage what's already in Kubernetes by default. So first of all, let's talk a bit about the scalers. The scalers are the things, the components, the little components that can read a particular event source. So for example, in the first demo later on, we're gonna see a demo of an Azure function that uses an Azure queue. So our Azure queue here is the event source. So there is a scaler that can read how many messages there are available on the Azure queue to get that metric and then do scaling based on that. So today there's quite a big list already available of scalers in Kada by default. Here's the whole list of it. And as you see, there's quite a few on it that do some things with Azure resources. But although Kada was originally created by Microsoft and Red Hat, it's not a Microsoft thing at all. As you can see, there's lots of scalers available for non-Microsoft related stuff. There's MySQL, there's Postgres, there's IBM stuff, there's Google Cloud stuff, AWS. So there's lots of scalers out there that could help you with the scaling stuff. So then when a scaler grabs a particular metric, Kada then uses its metric adapter to expose that metric to the horizontal pod autoscaler in Kubernetes. So most of the scaling of your workload isn't actually done by Kada. It's been done by the horizontal pod autoscaler that's in Kubernetes by default anyway. When I say almost all of the scaling, what I mean is that Kubernetes by default can only scale your workload from 1 and up and down to 1. So you can never scale down to 0 instances of a particular workload. With Kada, you can. So that's the main role of the controller you see here in this image. The main thing that a controller does is scale down to 0, or make sure that if we want to scale up from 0, that happens as well. So that's a nice additional benefit of Kada. We can actually scale from it to 0, and that is something that we cannot do by default in Kubernetes. But other than that, Kada really tries to use whatever is available in Kubernetes already instead of doing that itself. So one important thing here is that a scaler will grab the metrics of your event source, like the number of messages on a queue, but it will never grab the actual message of the queue. It is still up to you, up to your workload, to do that actual work. So it's still your event source. What do I mean by that? this is kind of how Kada works in that flow. Kada, and then specifically the scaler, will reach out to the queue to find out how many messages there are on that particular queue. It will go back with that metric into Kada, and then a potentially scaling of your application happens. And then your application needs to go out to the queue to fetch the actual data. Kada is not going to do that for you. There are alternatives in the market to Kada to do scaling on Kubernetes and scaling of serverless functions, for example. They do it a bit different. They do grab the data from the queue and then actually also pass that data into your application. And that's mostly done via HTTP. So the benefit of that second approach is that your application doesn't need to know anything anymore about the actual underlying event source. So your app doesn't need to know anything about queues. It only needs to know about HTTP. But the downside is that because you don't have to know anymore about the queue, you also can't work with the benefits that you get from that particular queue, like dead lettering out of the box, things like that. So there's trade-offs between the two, but Kada, as I said, doesn't give you actual data. That's up to you. So the first demo we're going to look at here today is one that uses Azure Functions, because I really think, I hope you will see that in a bit, that combining Azure Functions here with Kada is really a powerful combination. And we're going to run that on a combination of AKS, the Azure Kubernetes Service, and the virtual nodes, which are then being backed by the Azure Container Instances. And here in this event-driven example, that's really a really good combination. And here's why. Imagine that you have a queue, for example, and that's being used to import data into your system. And sometimes 1 million messages are being added to that queue and need to be processed. But other days, there's nothing to do when nothing actually gets added onto that queue. So the workload there is very unpredictable. So if you would handle that workload on your default already proficient AKS cluster, you might be overloading that, because that would have to rapidly scale out, add additional nodes, etc. It might not be fast enough, so you might actually be impacting whatever is running on it yet. But with a combination of the Azure Kubernetes Service and the Azure Container Instance, what you can do is you can give the workload to the container instance, or sorry, to the Kubernetes service, and when it needs to scale out, it will make the decision to see if should I run this particular workload on AKS, or should I run this particular workload on Azure Container Instances. So especially with this event-driven stuff, it will often make the decision to offload that work to the Azure Container Instances, have it eat the queue, and then just destroy all the containers that have been created on the Azure Container Instances. So that's a really powerful combination, because for you as a developer, you only need to talk to one API, to a single endpoint to trigger your workload. And then the two systems combined will make the decision where to actually run the workload. You don't have to do that yourself. That's really cool. All right, so let's dive into a demo there. So since I'm going to show you how to run an Azure function on Kubernetes using, and then scaling that using Kada, we're going to use the Azure function CLI to create a function. And this is how we can do that. Func init in a current folder, and then specify that we want to run that in a Docker container. As you can see, you get the choice to pick a particular workload. Azure functions aren't just about .NET or Microsoft or C#. There's other options as well. So now that I've initialized that, we're going to create our first new function. And then we get to pick how we want to trigger that particular function. And as I mentioned before, in this first demo, we're going to use the Azure queue. So I'm going to pick option 1 here to go with the Azure queue. Let's come up with a very original name here. And it's going to do some templating here to get that function going. And as you can see, there's quite a few other event sources, triggers available for you to use. All right, let's see what it came up with. load it up a bit. All right, so the first thing you will notice is that we actually have a Docker file, since we're going to run this Azure function in a Kubernetes cluster, and it uses the Azure function base image. And second thing is that we now have our Azure function right over here. And for those who've never seen an Azure function before, this is kind of all there's to it. The thing has a name in this attribute. And then here is the trigger defined. So we pick the Q trigger. So you will see that here as well. And this run function is your entry point into this particular function. So all I need to do now is specify what is the name of the queue we want to use, and then specify the connection string to that particular queue. So when we would have done that, you could be deploying your application. Let's quickly look at how we would do that. So the only thing you would really have to do here to get it working is specify your connection string. I'm going to leave that out for now. If we want to deploy this particular application, we could again use the Azure CLI and run this particular command. We have to give it a name. So let's use again the very original one, KDA. And we would have to specify the registry that we want to use and that we want to put this container image into. So here I'm using my own. And if I would now hit enter, what would then happen is that it would in the background start to build the container image in which my Azure function would live. It would then push that out into my registry. And it will then tell my Azure Kubernetes cluster to start deploying and running that application. And that would all happen in the background for you. But if you actually want to get a bit more control over what's happening there, then you can do something like this. We could output whatever's being done there in the background into a YAML file to see what's actually going on there and to be a bit more specific in what we want to do there. So let's move over to another window here, because I've already done that and already created the image, etc. That sometimes takes a bit of time, so we did that beforehand. So when you would have run that command that we saw in the previous window, you would end up with this deployment YAML. And that specifies what should be run on your Kubernetes cluster to get this function running. So if you've ever worked with Kubernetes before, this should be kind of familiar to you, because this over here is just a secret. And this now contains my connection string into my Azure queue. Here's the deployment, which specifies what I want to run on my Kubernetes cluster. So that's actually my container image that contains my Azure function. This again is just default Kubernetes stuff. But down here is where you see a thing that is specific to KDA. And that's the scaled object. That's a KDA specific thing. And this is where you specify how you want to do the scaling of your particular workload. So down here, it specifies, again, the trigger I want to use. So for example, here I'm using the Azure Q trigger. It says triggers, so we could actually have more than one trigger. That's available since version 2 of KDA, which was released just a few weeks ago. So we can now have multiple. And per trigger, you need to specify a few parameters to make it know how to actually do the work. So you would need to specify where does it get its connection string, which queue should it actually be watching, stuff like that. There's also a few additional interesting settings that you can use here as well. So for example, here's the polling info that will specify in how many seconds KDA will reach out to your queue to fetch the particular metric. I set that to a pretty low value here because that's easy in demos. And you also get to specify, for example, the minimum and maximum number of instances you want to run of your, in this case, Azure function. And that's a cool thing because you now also get to limit the scale out. And that comes in handy because if you would let this scale out to 1,000 or 10,000, which could easily happen, you would probably overloading your SQL database if you would need to call into that, or your Azure storage account or whatever. So it comes in handy to be able to limit your scale out here. All right, so that's kind of how this file is being built up and what needs to be put in place to do an actual deployment. So now that we have this YAML file, we can actually be deploying this into our Kubernetes and get that to work. I already did that because it could take a bit of time. So let's have a quick look at what it looks like if we put it into action. So as you can see, it has already been deployed here on my Kubernetes cluster. It's the one over here. All right, so let's have a look at some internals of the particular cluster. If we look at the particular nodes, then we should see that there is an AKS one. So that's the AKS node. I have only one of them. But as you can see, there's also the virtual node. So you can see here that there's actually the combination of AKS and the Azure Container Instance. So what you could also look at is the fact that there should not be any pods running. So as I mentioned before, we can scale down to 0 with Kata. That's something that you cannot do by default. So that's why it says that there's nothing running here, and you also see that here in the background. There's 0 out of 0 running. But if we then look at the horizontal pod autoscaler definition, then you see that it actually has been created for us. It needs to reference the deployment we just saw in the YAML file. And what you see over here is that it does still say that it has a minimum pods of 1. And that's because Kubernetes cannot scale down to 0 by default. It took me a few hours to figure out why that was when I started out with Kata. I hadn't noticed that particular thing. So this is actually what you want to see. That's normal. All right, so let's have a look at how that scaling would actually work then. Let's have a look at a particular deployment. So as you can see, the deployment is there, and there's 0 out of 0 instances ready here. So if I would then give a bit of workload to my particular queue, then we should see that something actually starts going. So what I did here is I created a very simple application that can put a number of messages on the queue. So let's have that running. And it should say somewhere down the line, so it's done. There we go. Yes. All right, so we already see that Kata picked it up and already started scaling our workload. And it will continue to do so till our queue is actually empty. So let's head over to the Azure portal. And then we can see something interesting here, and that's that, as you can see, there's already 4 instances of my Azure function on the cluster. And what you can also see is that one of them was being deployed to AKS, to the AKS pool, and the other 3 were actually deployed to the virtual node. And as you can see here, the one that was deployed onto AKS started pretty quickly. It only needed a few seconds to get an IP and actually do some work. Whereas the ones on the virtual node are still pending to spin up. So they do take a bit of more time to get up there. And if you would refresh, then you see that there's also one on the virtual node now running, but it did take a bit more time to get that done. And let's see, it scales up to 8 right now. And what you probably see quite quick here is that it also starts scaling back to, should be scaling back to 0, because it then processed all the events and should be scaling down rather quickly. There we are. So it already started scaling down again to 0 because there wasn't any work left to be done. All right, So that's the first demo on how to create an Azure function that will read a queue, get it deployed into your Kubernetes cluster, and then use Kada to do the actual scaling. Let's have a quick look at another example. And as I mentioned before, you can actually run Kada on top of any Kubernetes cluster. So you now saw a combination between AKS and the virtual nodes, the Azure Container Instances. But the next demo I'm going to do on my local development machine. And I'm doing that using a combination of K3S and K3D. And K3S is actually a lightweight version of Kubernetes. They replaced some of the main components with smaller ones. And that makes it very lightweight, being able to run on your development machine or even Raspberry Pis, for example. And then you can use K3D to actually run Docker inside of Docker, which allows you to run multi-node Kubernetes clusters on your local machine. And that's really handy because then you can do testing, etc., developing on Kubernetes on your local machine with still having a kind of identical Kubernetes cluster with multiple nodes to test stuff out. So the next thing we're going to look at is a combination of how we can do scaling with Kada based on data, based on metrics that we can find in Prometheus. And Prometheus is a time series database where we can store a lot of metrics. And we can then query that database using Kada and do scaling based on that result. So what I did here is I created a .NET Core API, and that API exposes Prometheus metrics on, for example, the number of requests in the last minute and the duration of those requests, etc., etc. And so Kada then reads those metrics from Prometheus, and when certain thresholds are met, Kada will start to scale the API to start adding more and more instances. So let's have a look at how that would, what that would look like. Let's go down to this one. So the first thing we probably should look at is the startup file of my controller. To let you see that adding Prometheus is actually pretty simple. It's installing a few NuGet packages and then adding some default configuration here. And when you've done that, then it will start exposing some default metrics by default. So the ones I mentioned before on number of requests and execution time, etc., those are exposed by default. But you can also add your own metrics. So I did that here in this particular example, where you can do observes, and you can also do increment particular counters, for example, if you want to. So you could be counting the number of orders, things like that. And the data again will be exposed to Prometheus, and Prometheus will start reading that particular data, and then you can use that to do scaling. So let's have a quick look at the scaled object to see what that looks like. So it's kind of similar to the scaled object we saw in the previous demo. The main difference here is that we have a different scalar type, since there's now Prometheus. And that also means that we have a few different settings that we can use to actually make that work. So let's see that in action quickly. Let's switch clusters. And let's make sure this stuff runs. So this should now be my API. This should be Prometheus. Yes. All right. So this is the default dashboard in Prometheus that you get, and that allows you to query the data in the database if you want to. So we're going to use that today to track the usage of the app. So I have already specified a particular query here, to fetch the data. And this is actually the same query as that Kada uses to do the scaling. So we're going to look at the request duration over the last minute. And if that exceeds a certain threshold, then Kada should start scaling out the application. So let's see if it actually does by looking at the scaling again of the object, the deployment. So as you can see, this is again my, sorry, this one. Again, this is the application, the .NET Core one. As you can see, there is one running this time because for an API, it makes sense, probably makes sense to have it live all the time so that you can actually get a response quickly. And if I would now try to make requests against that, if I would be in the correct directory, let's do it again. So I'm using a Go command line utility called Hey to trigger some load on that API that I've been written. And so if we would now go back here, then we should probably see a bit of data, which we do not. The API is up. Is it? It is, all right. There we are. There is a bit of delay between the metrics that are exposed and how quickly they end up in Prometheus. I guess by default, it tries to fetch metrics every 15 seconds or so. So there's a bit of delay. But what you see here is that the number of requests actually go up. And that should mean that we also see that Kada started scaling our particular application because I think I've set the threshold to 3 or to 5. And we are definitely going over that. So as you can see, Kada started scaling this particular API based on the metrics. And since we can do scaling on Prometheus, and Prometheus is a tool that's very widely used in open source projects, and we can kind of write a lot of metrics into Prometheus, we can also do scaling based on a lot of things. As long as we can write anything into Prometheus, we could actually do scaling based on those metrics. So that makes it a really powerful combination to do your scaling workloads. All right, so the last demo I have for you today is about how we would be able to, or how you can handle long-running tasks on Kubernetes. And that requires a bit of introduction, probably. So imagine the following situation. We have, again, our Kubernetes cluster in Azure, for example, and then we have masters and we have workers. But at a particular point in time, your cloud provider will probably make the decision to update your workers. There is operating system patches that need to be done, things like that. So what happens then is that your cloud provider will decide that it will spin up a new worker for you. And once that has joined your cluster, it will destroy other older workers and you simply remove them. But what happens if you've been running long-running tasks on any of those workers? So imagine you were doing some video decoding and encoding on that particular worker, and that process could take over hours to complete. If then the cloud provider would decide to kill your particular instance, that work would be gone and you would have to restart it. And continuing in such a process is probably pretty hard. So you probably need to start over all the way from the beginning. So how can we handle things like that in Kubernetes? So by default, if you want to, what happens when a node is going to be removed, then a signal will be sent to your container to notify that it's going to be shut down. And by default, you have like a 30 seconds delay between being sent that signal and actually being shut down. So that gives you 30 seconds in which you can close connections to databases, things like that. And that's okay for APIs, etc. Then 30 seconds is probably enough to finish the ongoing work. But if you are doing long running tasks, that's never going to be enough. And there's another problem as well. Somewhere in those 30 seconds, you already lose connection to your container. So you can't reach that container anymore, which means that you can't do monitoring of that container anymore, for example. So that's all not too ideal for long-running stuff. But luckily, there is something on Kubernetes that is called a job or jobs. And it also comes with a job controller, and that will ensure that one or more pods are executed and successfully terminated before that node is being shut down or removed. So a job does kind of give you the guarantee that whatever you run inside of a job, that will finish until the end, even though a node might have to be restarted. That will wait for your job to be completed. And the pods are then, the pods that are being run in a job are only being cleared and cleaned up when the job has been completed. And the beauty is that KDA can actually also do scaling based on jobs. So let's have a quick look at that as well. Let me get back my editor. There we are. All right, so again, I created a very small example for this one. It's even smaller than the other ones. So what I did here is I created a console application in .NET Core. And that console application will reach out to my queue, fetch an item, and then do something, and then die. So this is where you would normally do your long-running task. And this is again a demonstration on that KDA can kind of scale any container. It doesn't really matter what's in there. I mean, this is just a console application. As long as it can run in a container, KDA can kind of scale it. So that's what you see here as well. So what's going to happen here is that I've already deployed this YAML, this deployment YAML, and this time the thing we are going to deploy is a scaled job instead of a scaled object. And in this file, you specify how the scaling should be done. So again, there's some settings on the polling and the fall, etc. There's also settings on how many parallelism do you want to do and how many completions can a particular job do, stuff like that. And then probably the most important stuff is what is the container you want to run inside of the job to do the actual work. And last but not least, of course, there's the trigger section, which again specifies that I want to trigger based on a particular Azure queue. So there's a message on the queue that needs to be handled. And this time it has a different name compared to the other one. So let's see a quick demo on how that works here as well. So let's do a kubectl get jobs. All right, so as you can see, nothing is currently running there. Nothing is currently processing anything. But if I add a message to this particular queue, then it shouldn't take too long before, and there we are already, before KDA saw the message being put in the queue and it started scaling this particular job. And it shouldn't take too long, and there we are, for it to complete and be done with this particular job. So we can actually also go into that particular thing, Kubernetes GTL logs job, there's that one. And you see that it actually put a message in the logs that contains whatever I have been putting in there, which is again, oh, let me find the other one. Here we are. Which is this specific line down here. So it got the message from the queue, processed it, and then died and waited for something else to be put on that particular queue. All right. So that's what I wanted to share with you today on KDA, Azure Functions, and doing auto scaling on Kubernetes. Here's a bit of contact information if you have any questions after the session or want to reach out. There's a blog post on my blog, edwinstyle.nl, which goes through the first demo I did. So it will go through setting up a Kubernetes cluster, creating that Azure function, getting it deployed, etc., etc. So if you want to redo that first demo, then please go there. You can actually find all the demos and the source code that I did today on my GitHub repository. So if you want to do them yourself or want to look into them, feel free to find them there and use them for your own good. So thanks for joining me, and let's see if there are any questions.
Thanks so much for this great session, Erwin. There were a few questions, and one of them you've already answered in the end of your presentation about long-running tasks, so thanks for that. But another one is how fast will a container actually start when you use Kida? Is there like a cold start time or any delays? There isn't any other delay than you would normally have if you would start to run a container on Kubernetes. With the one exception that in the definition, in your scaling definition in Keda, you have this polling interval. Because what Keda does, if you use, for example, an Azure queue, the polling interval will be used to specify how many seconds to wait between each call into your queue to fetch the number of metrics. So if you would set that number to 5 minutes, it could take 5 minutes for Keda to pick up that there's a message on the queue and to start scaling your workload. Yeah, exactly. So what's the minimum time you can set there?
1 second.
Oh, 1 second. Okay. Well, that's great.
I'm not sure if you should do that in production though, but you can.
All right. Okay. Well, thank you for this question. Unfortunately, we're out of time with the next speaker waiting already. So thanks a lot for being here, and hopefully we'll see you next time.
You're welcome. Have fun today. Bye-bye.
Yeah,
thanks.
thanks.
Have a good day.
So I guess this is my cue to remind you all of our VACD challenge. So check out the Cloud Skill Challenge in the link down here. And stay tuned because we have a lot of cool sessions coming up. Especially the next session. That's one that at least I've been looking forward to. So I see Maarten is already with us.
Hey, everybody.
Hi.
Yeah.
So welcome.
Yeah, thank you for having me.
Well, thank you for joining us on this very special day. And I have to admit that even though I am a bit starstruck by having what I call the Sentinel Master Ninja with us, I do have a non-technical question. But that's just from my personal interest. I know you love flying and you actually are a pilot for, small airplanes. So not the big jumbo-sized. But how is that in these time of COVID? Does that mean that the sky is now the limit because there are less flights happening? Or did you have to switch to virtual flying to make your flight hours?
Yeah, no, I've been very privileged to be able to fly this year. And like you said, especially in the beginning of the year when most flights were grounded or not just there was this unique month where we actually could cross Schiphol Airport and on a light airplane, so a one propeller Cessna, we could do a flyby of the tower and try and land on the big airstrips as if we were a big plane. So it's been a lot of fun this year to fly, but certainly the clouds are the limit. And I must admit that with the Flight Simulator 2020 coming out in the fall, I've also spent some time flying virtually, but nothing beats going up in the air in a real airplane.
Okay, so basically I'm now gonna take this opportunity to say that I would love to join you on a flight and then make sure that we're focusing back on the technical coolness that you're going to
consider
present.
it done. What we'll do is we'll go up in the air and visit the Azure Western Europe data center in Middenmeer, which you can see from the air.
Oh.
I love how you built the theme back right into.
You're so lucky.
You can join as well, Jorrit. No problem.
Yeah, great. That's great. Thanks. That was an open invitation. All right. So well, about your session, you're going to do a session about security. Well, I mean, if there's one guy in the Netherlands who knows all about security, it's you. So, well, also you're well known for being a founder of Experts Live, right? Esther's been there last year. I've seen her there. So, yeah, really, we can't wait to see what your session will be about today. So, let's take it away.
Yeah, thank you. And we'll start right away because we have 8 tips to share with you today. And let me get to my presentation. 8 easy steps to improve your security posture in Azure is what I've called it. And we did the introduction already. People might know me. If not, I'm an MVP. Try to specialize on Azure and security. And the thing I wanted to convey today is that we're in this new cloud and hybrid world that we need to defend. So we need to shift away from just on-premise focus with largely network-based protections and detections to something that fits our cloud world. And things are different there. We have potentially endpoints directly to the internet. We have different types of resources like the platform services, but certainly there's a connection back into the hybrid and on-prem world. So we need to figure out how we can defend this new world. And this would mean that we need to adopt a cloud defender mindset. So instead of just a server, we need to figure out what services are running and how are they exposed and how can we protect them. Same goes for an Active Directory forest and domain, largely now subscriptions, tenants, and resource groups and whatnot. The highly privileged users from domain admins, we need to figure out subscription admins or other types of credential access. The credentials themselves are now not just a passkey hash or some kind of credential pivot there, but they're really just other types of things we need to figure out. Private IPs are now public IPs, ACLs, other network types like NSGs or Azure Front Door, and we need to figure out how to protect management APIs. So my first tip would be, let's figure out that we don't expose too much to the internet or other networks. Restrict access to your resources is pretty key to make sure that even though resources could be discovered through some sort of zero-day, they can't pivot away to potentially other types of networks or resources. So whenever you're creating resources in Azure or any other cloud for that matter, don't just accept the default ports. Make sure that you understand which ports you are opening, of course, to any of the networks that it will be connected to. Think if you can use a private link or other types of internet or connectivity and access. And that is a real thing, because I'm not sure if you know, if you've ever spun up a VM that's either Linux or Windows and you had the default ports open like 22 or 3389, you'll instantly see hits coming from massive crawlers that are trying to brute force passwords and figure out if you've tried any of the light passwords to get in. So one of the things you could consider there is just-in-time access. That's a feature from Azure Security Center, where you could say, well, even if I need a default port for a certain app, I won't have it open all the time. I'll only request to open it for a specific endpoint, maybe my company or my home address, and for a specific duration, and potentially with some approval step in between. And that means that we'll have it open for a short period of time to do our administrative access and then automatically have it close again. Now, this is part of Azure Defender and Security Center, and we'll have a look at that in a second. The other thing, of course, is that the Azure networking options are a load. There's lots of options for you to consider, and not just opening ports or closing ports through a network security group. Those are often common and things you need to figure out, but we talked about private links and some of the VNet peering potentially, but also Azure Front Door to expose your applications safely. Of course, the Azure Firewall, and the interesting thing about Azure Firewall is that it can also give indicators of compromise to your Azure Sentinel environment through the Security Graph API, so something that adds some of the indicators and things there. And of course, you could have a look at the third-party virtual appliances and make sure that we do something that makes a lot of sense for networking. Now, if you need access to any of your resources in Azure that are a VM, like a Linux or Windows VM, you're of course probably figuring out how to get SSH or RDP access. And one of the things you might try is to do it on a different port. But again, those massive crawlers on the internet will try a lot of ports and even grab potentially some of the high ports that you're using. So consider Azure Bastion, which is a fully managed platform service in Azure that actually then shields your VMs from direct access, but you go through Azure Bastion to gain access. It provides you with secure SSH and RDP access. Those are the things you can do through your regular programs, but there's also like a web portal. You can use a web URL to get a screen in your browser. Now, Bastion itself is provisioned in your VNet, so you get a Bastion instance in the VNet where your VMs live, and Bastion itself would then be configured to access the outside internet. And it supports connectivity from Bastion to your VMs using SSL, so encrypted traffic, so no snooping in between on the VNet itself. And it just needs one public IP address to the internet. Your resources itself, the VMs, can just have internal IPs and no need to have any public IPs on them, which potentially makes things even easier for you to disclose. So if these are VMs and you need administrative access, do have a look at Azure Bastion before you do other things. This is a great service that's provided out of the box. I would say the second tip is figure out how to secure your identity. And identity is, of course, key. You've seen a lot of people talk the last years that identity is the new control plane. You authenticate yourself and then get authorizations to the resource you need. And in all of these steps, we can have built-in security measures to make sure that no rogue people get access to identities and that only corporate and allowed users are in. Azure AD is key to any good security strategy, I would say. So it's not about networking just, it's not about getting SIMs in there or other protective measures. Make sure you get your Azure AD right and make sure you have a good security strategy. Certainly if you're using, let's say, accounts from other tenants, maybe look at things like Azure Lighthouse to safely make sure that you and from an auditable way get access to all of these resources. It's also very important from the sheer fact that often your Azure AD will be connected to your on-prem AD through AD Connect or some other mechanism. So if those credentials will be grabbed from your Azure AD, then there is potential for those hackers and adversaries to come into your on-prem network through the credentials they've gained and the access it gives them. So Azure AD is key, and it's not something to think of lightly, I would say, because it potentially gives access to other things than just your Azure Cloud or your Office 365 tenant. The other thing we're seeing is that attacks on identity are accelerating, right? We see so much automation, we see scale from the cloud for attackers as well. So they're trying to find, again, brute forcing mechanism, password sprays, all sorts of mechanisms to compromise your identity and get in. So the attacks are accelerating, so certainly make sure you get this right. And a key metric is that 60% of cyber attacks often start with some sort of compromise of an identity through spear phishing, through password sprays, through brute forcing and dictionary attacks. But a lot, and at least more than half, start with an identity attack. So this is not something to just look away from. Now, the identity is under constant attack. A lot of attacks, 2 years already, and it must have been grown over the past years, of course. 350,000 password spray attacks just in 1 month. 4.6 billion attacks in breach replays that year, and 23 million risk events in that same month in 2018. So each day there's just hundreds of millions of logins attempts. and you could be one of them that trying to target and make sure you don't become one of them. So what can you do here? Well, maybe have a look at Azure AD Identity Protection, because that already gives you some automated detection and remediation. It has machine learning in there to find out certain patterns in logins in your tenant, in other tenants combined. And it combines it with insights from Microsoft Threat Intelligence Center, where they have a look at things like nation state actors and so forth. And all of these things combined in AAD-IP will then make sure that accounts get flagged or closed or blocked even before bad things happen. It's part of Azure Active Directory. Now you do need a separate license, but these signals can then be fed into other parts of AAD or your environment as well. So think about conditional access, making sure that if we find risky users or risky logins, that conditional access steps in and prohibits access from that device or from that account before further damage happens. And these same signals can also be fed into your SIEM, so potentially Azure Sentinel, any of the other third parties, and make sure that we use them as indicators of compromise in our bigger use cases. Microsoft analyzes 6.5 trillion signals per day, so they are well equipped to find the things that matter, and their machine learning is top notch. They really find the things that help you prevent attacks. Another thing to consider is the Azure AD Privileged Identity Management, PIM. Just-in-time access for your identity, like we saw on the VM. We can make sure that we control access, that you can only get things like global rights or specific roles in AAD based on the request you're doing, based on things like validating your multi-factor, so your extra factor. But it prevents you from permanently assigning and having rights when you're not needing them. Again, PIM is built into Azure AD. You do need a separate license, which you see here on the screen. But other than that, eligible users could then require MFA, maybe require approval step before they get that role, and or specify a reason why they're actually requesting that role, which then certain management roles can then approve. The great thing about PIM, but also identity protection, also Lighthouse, I would say any Azure identity related service, is that it's auditable and that we can alert on it. They will be logged into things like Azure Activity and some of the other logs. And then we can also, in our investigation or in our hunting, use that as signals or see certain behavior from either bad actors or rogue internal users and make sure that we handle them accordingly. So AAD PIM, highly recommended in any environment, I would say. Of course, the third tip is understand your current status. Look at, again, that Cloud Defender mindset. Do we know how our environment is currently running? Which endpoints are exposed to the internet? Which accounts have a risky flag to them? And that's hard potentially in cloud because there's so much to look at. Things change over and over and again. Without security controls in place, a lot of the breaches take months to discover or even longer. And in 2019, there was a 95% increase in cost of a breach. So the cost that a company has when a breach happens, when they get downtime or certain services go down. So what could help there? Well, I would say have a look at Azure Security Center because for one, it can protect your Azure workloads, prevent certain things from happening like the just-in-time access or more. But more importantly, it gets you insights in the current status of your subscriptions. So how are things configured? Are you doing the right, do you have the right controls in your setup, in your environment? There's a free and pay tiers. So some of these more advanced options might be in a pay tier, but certainly the free tier will give you all of the insights. And I would say there's no reason not just to enable it and get this at a glance overview, because it gives you recommendations. It gives you remediation, the one-click remediation button to say, well, okay, I might not have configured it yet, but if I click this button, it will be configured and I'm protected from that point on. And of course, it's the home of Azure Defender, where we can then have things like workload protection on your VM, like the Windows and Linux EDR, but also on things like your Kubernetes cluster, container scanning, all sorts of things that are very, very interesting to figure out if we have any potential security risks going on. Now, because your environment is changing, machines get added, maybe resources get changed, deployments happen, your cloud environment will be going up and down. Azure Security Center can then help get you insights through some of these dashboards where you see Azure Defender and you see all of the things happening and potentially the insights to work from. Now, let me switch quickly to a demo. Here we are. I'm logged into our demo environment and we're in the Azure portal, as you can see. And the first thing we'll do is we'll have a look at Azure Security Center. In my Azure Security Center, I get launched into an overview page and I see there's one Azure subscription and there's 30 active recommendations as well as 13 security alerts. There's also a button to go into your secure score. Of course, this is arbitrary, but still it gives me an at a glance information about my current status, which says, well, there's potential to improve because only 1/3 of all of the recommendations are applied to the subscription. And when I click on the subscription and go deeper, I find that there's a lot of things I can still do. There are users that don't have NFA enabled. There are vulnerabilities potential that we need to fix. And again, there's the quick big fix, the one-click button to fix things that you can use as you have the rights to make sure that some of these things go away as part of the recommendations that Microsoft gives you. So these are things that happen a lot, that help you a lot, and that you can just have a look at. Now we can also go back to the security alerts. The security alerts are the things we talked about earlier. Things like massive crawlers on the internet trying to do a brute force attack. Here we go. That luckily failed. So again, my password and setup is apparently a bit more secure. But they're trying, and it gives you information on certain things happening in your environment. And these are the two VMs, like VM Linux EDR, that then gets targeted by this crawler. There's also regulatory compliance. So if you are in an industry that you need to adhere to things like PCI for the financial industry, maybe ISO, or maybe just want to make sure that I comply with the Azure CIS standards, you can go into Azure Security Center, and based on the categories, it tells you, well, you're not adhering to the Identity and Access Management Chapter 1.2 and 1.1. But you are adhering to the one in Chapter 2. And again, from here, we can just be very actionable, go into the alerts, maybe quickly fix it, and jump, make sure that we are more protected. If we go into the Azure Defender node, we see that, and again, this is part of more the standard and paid options, that we can do things like a vulnerability assessment. We see 15 VMs unprotected, the just-in-time VM access we talked about, some of the application controls, container image scanning, all sorts of neat things to make ourselves more secure. And here with the just-in-time access, I can click a VM and start enabling it so that we only have ports available for a certain period in time. So these are the things that I would say help a lot, and Azure Security Center is a great option to look at. Going back to the slides. Tip 4 would be, let's dive a bit deeper into that environment, because Azure Security Center gives us at a glance view. You can look at regulatory compliance. But if you remember this quote from John Lambert, the head of Microsoft's Threat Intelligence Center, then he says, defenders think in lists and attackers think in graphs. And as long as this is true, attackers win. Because it's almost undoable to fix every and all resources in your environment. So trying to get to 100% state will be a hard thing to do. often attackers and adversaries are trying to find the shortest way to their goal. What's the minimum steps I need to do to get certain role or data, and how can I compromise these steps like a VM or some other resource to elevate my privileges and grab that data. So they're thinking in graphs, a short way, a route, if you will, to a certain resource. Now, one of the things that people might know from the on-prem AD is a tool called Bloodhound. It's an open source tool, freely available, great stuff from the people at SpectreOps, but they've released an Azure AD version of it a couple of days ago, I would say. It uses the graph theory to reveal hidden and unintended relationships in your Active Directory, forests, and domains, but now, again, also in your Azure AD environment. There's two parts to it, which you can run independently. There's a collector, a PowerShell script that you run with your privileges to get all of the resources, all of the potential connections between them, and it saves them in a big zip file. And then there's a visualizer, a front end, the UI that you import the zip file into, which is backed by a Neo4j database that then allows you to understand and pivot through those graphs. Now, the Azure Hound is the name of the PowerShell module for the collection. It collects it from all of the tenants and subscriptions that your user can read that you run it with, and again, outputs a zip file. If you combine it with SharpHound, which is the name of the on-prem AD tool, you get a full view. So on-prem to Azure attack paths. And from what we've seen, about 100K user environment takes about 60 minutes to collect, which is a reasonable number. You can run it every now and then, I would say, or at least once to get the data in. And it discovers things like tenants, Azure users, security groups, apps, service principals, all of the things that might interest you. Here's a quick screenshot. So you can look at an environment, take a specific resource and say, give me the shortest path to here. Cool. Let's jump back into the demo. I did the discovery and the collection ahead of time for this demo environment. So I've already collected the zip file to save a couple of minutes. The Neo4j database is running, and I can go into the app Bloodhound. There's a Windows and Mac version, and log into the database. And I could start looking at a certain resource. Let's take that VM again. And I can say, well, give me the shortest path to here. And what you quickly see now is that this gives the information on how to compromise this VM. What roles would I need? What user has what access where? And so the shortest path would be any of those 4 or 5 routes. This is what an attacker cares about. So these are the things that might be high priority for you. Priority 1 to start fixing, make sure it's hardened or protected before you might take on any of the other things in your environment. So pivoting through these graphs and making sure that you understand these resources and the path to them helps. And again, if you combine them with your on-prem AD, you could figure out how to get from a regular user to domain admin, enterprise admin, and global admin all the way, and what steps to undertake to protect them. So Bloodhound, really, really great tool and something for you to consider. Tip 5, implement endpoint detection and response, EDR, on your workloads. We talked about Azure Defender before. We'll talk about Microsoft Defender now. EDR is not antivirus, just. Antivirus is often signature-based, heuristics-based, the things we know already, and it helps. We need to make sure that we have the low-hanging fruit and cover them. But EDR is really also looking at patterns and things happening in your environment and starting to learn from there. So it's focused on patterns and behavior, I would say the known unknowns that we can start to block. And Microsoft Defender now has EDR block mode, so you could really prevent them as they start happening potentially in your environment and before anything else happens. This will be part of Azure Defender if you roll that out to VM. So if you're applying Azure Defender to a Linux or Windows VM, Microsoft Defender under the hood gets enabled, and you could start using all of this technology. Of course, it then reports back into your centralized console, Azure Security Center, or maybe the Microsoft Defender console if you're using that as well for your clients, let's say the Windows 10 clients on your network. And the great thing is it uses KQL, so you could do some advanced hunting and use that raw data to get a bigger picture if you're doing some investigation or hunting. Now, these are the things you get with Microsoft Defender, not just EDR, but there's also threat and vulnerability management. So understanding the current version and all of the other things in your environment, and maybe you need to patch some of these. ASR rules to make sure that we don't get any, let's say, child processes from your Office applications that spawn macros, PowerShell, and anything worse from there. The next generation protection, the EDR, and some auto investigation and remediation, which is neat because you might want to collect some evidence or maybe start shutting down some processes that get spawned. And this is something you can do from the console. So the Microsoft Defender really helps, and with the new Microsoft Defender 365, you could also get information from Cloud App Security, Defender for Identity, again, Defender for Endpoints to make sure you get the bigger picture. Now let's log back into the demo environment. I'll go back to my browser and go into Microsoft Defender here and open up some of these alerts. Now, in my environment, it says we have possible Cobalt Strike detected, which is a problem in and by itself because it is often used by adversaries as a framework for automation and command and control. And it comes to that conclusion based on 4 alerts that are happening. So this is something to look at. Looking at the machines in my environment, I see, okay, this is coming from a certain computer. And if we log into that computer, it gives us information on the risk level, the exposure level from our threat and vulnerability management. We see the logon user, Tyrell apparently is using this one. And we can go to the alerts tab, go, for instance, to the suspicious process injection and get some more information on what's happening. And when we have a look, that's interesting because that tells us that some Explorer exe was spawned that then started excel.exe that then had some execution host run DLL and then got blocked by MC, the macro inspection, and it started launching scripts. So this is certainly something that is worth looking in, and that will, if you have EDR in block mode, would have prevented from happening altogether. And it gives us also information that it's happening to Tyrell, which is apparently a senior vice president. So I would say a VIP user to start worrying about quite a bit. If we go into the alert details, and really nice things like mapping it back to the MITRE attack framework, getting some information on what is process injection, which actor groups are using it, how can we do further investigation and so forth. So mapping it back to MITRE is really a big thing. If you're worried about information altogether, like what actor groups and how do they operate, well, the great thing is there's a threat analytics page in Microsoft Defender. So if I say Cobalt Strike, I actually get information on, let me hit enter, information on Cobalt Strike. So Cobalt Strike hiding in the red, there's information, there's links, one device that now is potentially hit by Cobalt Strike. But the threat analytics I've seen is very spot on. You want to know things about WannaCrypt, about zero logon, new Emotet spikes, everything happening, PowerShell Empire. This is the place to go, and certainly a great strength of the Microsoft Defender suite. And it all to give you information on how things work. Let me dive into this. Here you see it before, the T numbers from MITRE, the steps that PowerShell Empire takes, and the protections you could apply. So these are really, really neat things to look at. Okay, that was tip 5. Tip 6, set up security monitoring. Yeah, why not? Make sure that we have some sort of tripwire, that we're understanding what's happening. And of course, this is my intro into Azure Sentinel. You're having Azure Defender in your environment. You're having Microsoft 365 Defender in your environment. Really, really good. Couple of consoles to work with. How about combining it and getting it into a bigger picture? enter stage Azure Sentinel. So Azure Sentinel has been Microsoft's cloud native SIEM, launched last year, has been received with great success is what we're seeing. Limitless cloud speed and scale, it lives in Azure, that matters a bit. There's machine learning built in, easy integration with some of the connectors, and you only pay for what you use. Now, these connectors are not only Microsoft-based, it's for connecting AWS, your network environment. The good thing is there are also free connectors for which you don't pay for your data ingestion or storage. Things like the Office 365 connector or the Azure Activities, again, already very worthwhile in your environment to understand the identity attacks potentially occurring. So one SIEM for all your clouds, AWS, Azure-based workloads, no problem at all. And really neat investigation UI to dive deeper and not just stare at a bulk of text, but really use your cognitive skills to dive deeper and get a bit of more information. Again, diving back into our Azure environment, we have a Azure Sentinel workspace set up. And what we'll do is I'll set it back to the last, 60 or 90 days. So we have a bit more of information in our screens. And we see that things are happening and things get collected. I've got a couple of data connectors configured. There's 61 in total available and more coming almost weekly. 12 of them connected, of course, the Azure Activity and Office 365. Again, they're free, but also Azure Security Center. I've connected Cloud App Security. Pretty much all the things in my environment are reporting back into Azure Sentinel. You get analytic rules out of the box. Here we go. I only have a few really enabled at this point, but you'll see already the power of those. But there's a ton of rule templates here. If I search for PowerShell Empire again, here's one where it's fully configured. Again, with all of the tactics from Mitra, the security event table it will be using that's ingesting data. So it's turning green that I can use it. Just create rule and you'll be all good to go. Now going back to the incidents, taking a sample incident, maybe going back to that suspicious process injection we just saw, there's actually a button for us to click on investigate, and we get at a glance view of the things happening we just saw. We see suspicious process injection, we see the same desktop, we see Excel and all of the things we need to worry about, but clicking on entities gives us all of the things, the hashes of the files, the people involved. But we also can click on things like timeline and see, oh, there's some sort of malware that was prevented. But after that, we saw a suspicious process injection. So might need to look a bit further on the things happening. So this is really, really powerful and something to consider. Okay, tip 7, think use cases, not just alerts. And this is important to me because if you'll just be going after alerts one by one, you'll be chasing your tail. There's a ton of unusual sign-in activities, people working from home, maybe from another IP address, maybe they go out and about, and nowadays working from the office is seen as an anomaly, I would say. So there's so much things and so many alerts that come at you, and what are the real things that you need to figure out that have a high priority like we just saw? Well, let's take an example. Let's say at 9:13, we saw an unusual login from Indonesia, maybe from a user that's normally not in Asia and specifically there. So maybe a VPN, maybe something else happening. But at 9:13, we also saw an anonymous IP, maybe a Tor exit node or some VPN anonymizer was found, and they're combined. And we're now starting to think, whoa, this is not good. And a couple of minutes later, half an hour later, we see a suspicious PowerShell script getting executed on that endpoint. Bad things, something we need to look at. And then the last thing that we discover is an inbox forwarding rule just after, potentially for data exfiltration. And by now your MDR or SOC would probably have called you, and bad things are happening. So the use cases where you're combining 2 or more alerts together to really get a good number of true positives, I would say. Here's an example, compromised account leading to Office 365 mailbox exfiltration. Again, you can build them yourselves, but they also are built into the product. There's a great tool from Puyan, Kapazi, and our colleagues from Wortel that can get you things to do automated, which is called the AZ Sentinel PowerShell module. Get some of the analytics in, some of those use cases, really easy to do with the PowerShell module. Going back to the demo environment, going back into Sentinel quickly, there's a new tab called Entity Behavior. If I say VM Linux EDR, the machine we were looking at in this session, it gives us at a glance information of the things happening. I need to set last 90 days, of course. Not sure why it's flipping back in certain parts of the UI. And now click on it, we'll see the same timeline again. Reverse shell was found. Ooh, whoops, that's bad. And we can click a bit further. So this is really something that helps. Those are KQL based, as you see. If I go into Visual Studio, here are some of the use cases we've recently built. Impossible travel, CI/CD bypass, all of these things you could put in a JSON file. And again, with the AZ Sentinel module, make sure that you get those in your environment in an automated way. Last tip, apply security anywhere with Azure Arc. Azure Arc, one of the new services that spans the ARM control plane into places it's not been before. So you can use Azure Arc to attach to existing Windows, Linux, and Kubernetes resources wherever they live. Manage them as any other Azure-based resource. Brings the ARM into any environment it's not been in before. Let's think AWS, let's think on-prem, let's think the hosting data center you have some stuff in. One control plane for you to rule over your clouds for management, but certainly also for security. There's Azure Arc for servers, Azure Arc for Kubernetes, Azure Data Services that you can use. Azure Defender spans through Azure Arc and uses Azure Arc. So you can enforce compliance and auditing on any of the resources, even if they don't live in Azure. Still manage them from a unified portal, view and remediate them as you would in Azure, and really gives you multi-cloud security protections. Conclusion, Azure has a lot of built-in controls that you can use for identity, network, data security, threat protection, and security management. I would say that's the reason Forrester said, make no mistake, Microsoft is a security company now. Great quote. Want to know more about Azure Sentinel? We've released an ebook, so go ahead and download for free. I'll post a link to Twitter again, or stay up to date through my blog, maartengoed.org, or my podcast, securityinsiders.io. And this was what I actually had prepared, so thank you for tuning in.
Well, thank you for giving us this session, Maarten.
My pleasure.
I hope there's not a lot of background noise, but it became a bit chilly in the studio, so we have an extra heater on right now. So yeah. I hope that's not interfering with the stream, and you can still hear us loud and clear.
Exactly. Hopefully.
Yes.
So, yeah, we have some questions for you, if that's okay.
Yeah, go ahead.
The first one that came in through the Twitch was if there will be any MAC identifying possibilities for filtering on MAC addresses, your security rules in Azure.
In which product they meant? Did you get more information on?
Yeah, I would assume
want to apply it?
On network firewalling, network connectivity, probably around that area.
Okay, well, I need to understand more about the question. Feel free to do a follow-up question on Twitter, and I'll help answer. But I'm not sure where you would want to apply MAC filtering at this point.
Okay, well, we will take it to you personally then. Thanks. The other one is if there are any certifications that you would recommend if you are learning from the beginning around Azure security.
I think there's a ton of stuff. Of course, the AZ 500 certification is good. There's a ton of things they ask from all of the security products that are great. If you want to dive into things like identity security, we've seen great courses from other providers like the pentestacademy.com. If you want to get more on the offensive side, of course, there's a ton of things there. I would say some of the SANS courses are really, really good. So ton of things. I'll do some suggestions on Twitter. If you have your own suggestions, feel free to add to them.
Okay, so next one is about your slide deck. If you're willing to share it after this session somewhere.
Absolutely. We'll figure out how to get them to the audience.
Okay.
Yes, please, because you already made me aware of some of the rookie mistakes that I'm making, connecting to my Azure environment and forgetting to use Azure Bastion. And I hope nobody heard that and is gonna hack my demo environment now.
Well, we can all help each other get more secure. So I'll be sure be posting my deck. Yeah.
Thank you. That will definitely help me.
Sure. Okay. So final question for you, and this might be an interesting one. You mentioned Azure Arc for managing your on-premise or your hybrid servers, but there's also Azure Lighthouse where you can manage multiple Azure subscriptions from one and the same tenant. How do they play together? I mean, can you even combine these? Like if you have Azure Arc enabled servers running in a subscription somewhere, can you still manage them through Azure Lighthouse?
I've not tried it personally, but what you see with Azure Arc is that it extends all of the capabilities you have in the public cloud into other places. I would foresee that if not now, then in the near future, that would be a possibility because all of these resources show up as Azure resources through ARM. And Azure Lighthouse is utilizing all of the things we have in ARM. So certainly something to look at, but I would say they play really well together.
All right. Thank you for your info.
Cool. Well, thank you for having me again.
Yeah. Well, I guess this is it for Maarten. Thank you very much.
Thank you, Maarten.
And hopefully we will see you next time.
Definitely.
Cheers. Thank you, guys.
All right.
So this is probably the moment for us to once again remind you of this awesome Cloud Skill Challenge that we have. So check out the link down there and still sign up and try to become our new Cloud Skill Master or Ninja or Hero. Badger, of course, Badger. Our Cloud Skill Badger.
Yeah, and there's prizes to win as well, right? So
that's what I heard. So that should definitely be a good motivator. Exactly. And I'm looking in my eye, in the corner of my eye, to see if our next presenter is already eagerly waiting to be introduced. Hi, Mark.
Hi, Mark.
Welcome to the show, so to speak. So we had a very quick and brief introduction through LinkedIn to make sure that we weren't complete strangers to each other.
We're never strangers in the community.
That is true. Thanks for that, Savior. That's a very nice one. So you are not just an MVP and Azure enthusiasm, but you're also a great advocate for STEM. That's what I heard.
Yes, I do a fair bit. Basically, I started off doing, if you've heard of Coder Dojo, I started off teaching kids how to code in Coder Dojo clubs. And then I joined the STEM Ambassador program, which means that I'm going around, well, in the before times, I would go around to schools and talk to children about getting careers in STEM and sort of how wonderful it is to be a computer programmer or to work in tech in general. And these days, what I also do is to go around and teach the teachers about how to do the computer science and the computational thinking, as they call it, areas of the curriculum, all the way up from 5 years old up to 18. So yes, I've certainly got me got business going on there.
Well, that's awesome, because I think we can always use more advocates and enthusiasm about any of the STEM science related activities and learning skills. So kudos for that.
I mean, I'm an Azure MVP, but I do just like to go out there and tell people about tech in general. So I'm over in Ireland, in Northern Ireland to be precise, and I manage. I'm one of the founders of the Northern Ireland Developer Conference, and that's a completely agnostic conference. So we get people talking about all sorts of things, from product management to Java to TypeScript to DevOps to Kubernetes, all sorts of stuff, and it just brings everybody together. So I'm very much not a person who lives on one side of the fence.
Well, thank you for that, because that I think we can use a lot of those sponsors in the community to not just look inwards and find our peers within the Azure community, but also to look outwards and see how we can get new people interested, and just show us that, or show the world that we're not just a bunch of geeks, but we also know how to be socially interactive, even in these times.
Exactly.
Geeks with social skills. What will the world think of next?
Well, it's a special breed, I have to admit.
I must say, by the way, your studio is looking very splendid. You've got a lot of work into that.
Well, thank you very much. But there's a whole crew here behind the scenes working on this studio as well, so we would like to thank them, obviously, as well, for this great day. But it looks awesome. I agree. So you are going to do a session about static website hosting, WordPress. That was kind of the buzzwords that I took from your session.
The Azure slant on it is the new Azure static web apps, but I'll be talking about the whole static Jamstack thing, and WordPress as an example of how you might want to move from something old and clunky to something a little more modern and slick. So.
Yeah, well, I'm really looking forward to it. So if you're ready, then let's go.
See if I can find the right button. Right. Okay. So yes. So that's me. I am a freelancer basically on Azure. And can you see my screen? I suppose I should say. And Mark XA there is me on all the things. So if anybody wants to come on and heckle me or ask me questions afterwards, then just come and find me on Twitter. So we'll just start with a little bit of history here. So I've done a lot of things. I've worked as a developer in lots of different ways, but one of the things I've certainly done my time in is agency work and websites and stuff. And I've worked with my fair quota of CMS-based websites in particular. And what always seems to happen with a CMS-based website is everybody comes in and says, the agency comes in and says, yeah, this will be great. You can look after your own content and, you can manage it yourself and it'll be brilliant. But what also always used to happen was that you would also have a hosting package built into that, which would involve, a dedicated server costing you, sort of $100, $200 a month just to run this one, potentially quite small and, lightweight website. And when you're running a CMS site, not only does it generally cost a fair bit to run, but it's also quite slow. You've got your server churning away there. It's really generally not terribly optimized. So you lose a lot of Google juice in terms of your page speed rankings and stuff. And more seriously, and the reason we got the dumpster fire there is that CMSs have a habit of being hacked. So I have more than once had to recover a website that somebody, some hacker came along and found a vulnerability in a slightly out of date and as yet unpatched CMS or even server. And I mean, this is fresh off the press, but just 2 weeks ago, somebody who I used to work with on a website, they still had their old CMS still running on their old dedicated server, and their entire hosting provider got hacked. The whole hosting provider went down. So, I'm not a great fan of that model. Even if it's a managed platform, it's never that fast, it's never that cheap, and it's never that secure. And another thing worth bearing in mind, again, sort of, hot of the press from last week is just an example. I'm over in Ireland on Irish TV. There's a fairly popular TV show that did an appeal for children at Christmas, and usual sort of thing. They opened up the appeal. Everybody piled onto the website, and the website keeled under the pressure. Couldn't keep up with all the people wanting to make the donations, and that was a fairly professionally set up website. That wasn't a CMS. That was actually somebody who was sitting there, had made a donation website, and was expecting people in, but it still couldn't scale fast enough. So really, what we want to look at here is something that's fast, cheap, secure, and scalable. So what I'm going to be talking about here today is what I refer to as serverless websites. So I'll talk about what I mean by a serverless website. Then I'll talk about how you can put one together. Then I'll talk about the Azure side of things, how Azure Static Web Apps fits into the picture, and then I'll do a very simple demo of moving from a WordPress site over to a serverless website. No, I'm afraid if you were coming here for the magic wand that turns your WordPress site into a serverless website in one button press, I'm afraid you're going to be disappointed. But it hopefully will show the principles. So serverless websites, like I say, so that's my term for what you might also have heard of as Jamstack. Jamstack stands for JavaScript APIs and Markup. And it's a bit of a paradigm shift from the standard server-based model. So, we're not going to be talking about a PHP site here or an ASP.NET site or, a Django site or anything like that. What you have when you're setting up a serverless website is, the first thing you've got is static content. So the core of your site, so your homepage, for instance, will be just sitting there purely as HTML and CSS. And the rest of your site, all the rest of your posts and your site areas and all that sort of stuff will be based on static HTML pages, which get served directly from something like blob storage or from a CDN or something like that. Now, obviously, that can work for a lot of things, but every so often you're going to actually want it to be able to do something interactive. So what you then do is you add some JavaScript to it, or I guess Blazor if you're feeling brave, but you add some client-side scripting to that. And then to make sure that it's properly serverless, you're then going to have functions as a service behind that with an API to provide the server-side things that you need to actually provide the functionality on your website. So like I say, it's a bit weird. It feels a bit weird if you're just used to writing an ASP.NET site or something like that, that everything is static and everything goes through JavaScript. But it does have a lot of advantages. Now, let's say the first advantage is speed. If you're serving everything from just a content store, then that's really, really fast. There's no server in the way. You're literally just fetching resources. And if you've got a CDN behind that, you can have all the content that you need to serve pretty much the whole site right next to the person who's browsing it. The scalability, you're getting true serverless. Basically, if nobody's using your site, you're not getting any bandwidth costs. You're not getting any functions as a service costs, from the serverless functions. Literally, the only thing you're paying for is the storage of your content, which, generally speaking, is going to be the order of cents a month. But on the other hand, obviously, storage, there's no limit to how much you can access, cloud storage, and serverless API can scale up extremely quickly to the scale of whatever you're going to throw at it. So you've got you've got scalability all the way from 0 up to practically infinity. So you can do your massive donations when they turn in, and the cost is really low. As I mentioned, if nobody's coming in, you're not paying, and when you are running, all you're paying for is the bandwidth you're using and the standard per millisecond billing of your functions as a service, which is going to be a lot less than your $200 a month for your dedicated server, or even your $20 a month for a hosted WordPress site or something like that. Security-wise, obviously, when you're talking about just the content side of things, the static side of things, unless somebody can hack your Azure Active Directory, get into your Azure subscription and get into your storage, then you're safe. And there's nobody going around trying to break into, well, there probably is some, the Chinese government is probably going around trying to break into Azure, but people, generally speaking, don't break into Azure unless you've, put a really stupidly insecure password on it. And the functions as a service, similarly, although they're open, you can wrap authentication around those. So, and the code is, generally speaking, your own small bits of code which are nice and easy to make secure. There's it's relatively easy to secure a serverless API. Stability wise, it's a platform and there's no server there to go up or down or to be patched. So in theory, your site will never go down. It's portable. Because it's just files and a serverless API, you can lift your files anywhere. So you can dump them on any cloud provider, you can run it locally, you can stick it in a sort of a storage bucket, you can stick it in your local ISP. But it's really easy just to zip up your files, move them somewhere else, and run from wherever. And you get a lot of flexibility. So from the developer point of view, you're not tied to a PHP or tied to an ASP.NET website. You've got just your APIs behind it, which can, as long as they run, as long as they're an API that you can access, you can have anything sitting behind that. So there's no there's no necessity to have all your code in the same place, all in the same language. So if you've got a plugin that you want to use, an API plugin, a third-party one, then you can do that. And I should point out that the other thing that's worth mentioning is that you can do pretty much anything with one of these serverless websites that you can with a traditional website. There are companies out there running their entire web stack, including their back-end stuff, all on this style of hosting and website, with no server-side code apart from a serverless API. So putting this together, what are we going to have in there? Now, I mean, we don't need any of these. These are all optional. In theory, a serverless site could just be a couple of HTML files and a bit of CSS that you've stuffed out there, a completely static site. But generally speaking, you're going to want some sort of static site generator. So that's something that takes content, so your blog posts or your image gallery entries or the comments, and takes that raw content and turns it into a pure HTML site. Then, if that's not enough to deal with what you've got, then you will take a JavaScript library or framework and put that on top of it. You will then have a serverless API, which you need to have behind that. And in terms of actually managing that content I was talking about, you'll want some sort probably of headless CMS. Now, you can, in most static sites, edit the content directly in Markdown or something, but if you're used to a CMS model, then you'll want something that can edit those. So you'll either be looking at something like Contentful or Netlify CMS, which are designed for this situation, or what people do, the people who have migrated from WordPress to a serverless model, they actually still use WordPress as the content management system. It's just that they never let the public see it. So that's hidden somewhere safely behind the firewall that they use to edit the content. And then, as we'll see later on, you can pull that content out of WordPress through the API, push that in, convert that into the content the static site generator is expecting, and then generate that. So that's, the moving parts. And then to actually turn that into a site that somebody can browse, you need to have it hosted up somewhere. So if, the bits you need to do that, you need, generally speaking, some sort of CI/CD workflow. So when you create new content, then something needs to go off and rebuild your whole website and push that out to wherever it's hosted. You'll need your storage now, so for instance, Azure Storage for a while has had this thing called static website hosting, where basically you can dump storage into blobs, and then Azure wraps just a tiny bit of ceremony around that to allow you to access it as if it were a normal website. And then you'll need your functions as a service platform, so your Lambda or your Azure Functions or your Google Cloud Functions or whatever you've got hosted on Kubernetes. So there's essentially three elements there that you'll need to get everything hosted and deployed. Oops, excuse me. And that's where Azure Static Web Apps comes in. So Static Web Apps is a new preview service that's come out of the largely pushed by the Azure Functions side of things. But that pulls it all together into one coherent service. So you've got GitHub Actions for your CI/CD workflow. You've got Static Web Apps provides you with its own content storage, and it also integrates Azure Functions in there. And it's still in preview, so yes, they are aware that Azure DevOps is a thing, and that you might not want to use GitHub. There's more, so plenty more to come. But they pulled all those things together so that you've now got one service which can do this serverless website thing for you. You could call it a static website. I don't like static web apps because it implies that nothing happens on it and they can't do anything. It's just sitting there being boring. So that's why I prefer serverless websites. But marketing says static, so static it is. And this is the basic workflow. So as I said, at the moment it's GitHub only, but they're working on other things for that. But you have a repository, so a GitHub repo, and that contains your source content. So whatever you're going to feed to your static site generator. And every time you make a change to that through a push or through a PR, then that will trigger, obviously, a GitHub action. The GitHub action looks at what's in your repository, builds that out to static content and to Azure Functions, and then it pushes that content and those functions out to the static web app side in Azure for the actual hosting. And then as soon as that's deployed, then your users can come along and see the new version of the site. So we'll walk through what exactly is going on there. So, and the first bit there in the CI/CD, when you create a static web app, what it will do is you always tell it where your repository is, and it will automatically provision into that repository the GitHub actions, the workflows that are necessary to work with whatever you've chosen to build your serverless website with, or your static web app with. So Hugo, Gatsby, ViewPress there are sort of popular static site generators, and it will use a project called Oryx, which is used in Azure App Service, to build those for you. It will also understand the main JavaScript and front-end frameworks, so it'll be able to build you an Angular site or a React site, so it'll do all the web packing and stuff for you. It will even build you a Blazor site, and if there's nothing there that it actually recognizes immediately, then it allows you to do custom build steps. So you can either just do a plain one where you've already built it yourself, or it will allow you to say, okay, this is my build command. This is where my build is going to end up. The deployable part of my build will end up, and it will then allow you to do that for whatever. So for instance, if you're using Jekyll or something which isn't on that list, and it's not supported, then you can just put in the Jekyll build command. The other really nice thing here is that it automatically builds a preview for you when somebody submits a PR. So when somebody wants to make an update to the site, and if they don't have the permissions to push directly to master or to main, then they will put that in with a pull request. And as soon as a pull request comes in, GitHub will wake up, it will fire off some actions, and it will actually provision a second site for you where you can see that PR privately. So you, as the person who's approving the stuff that's going into your website, can actually go and see exactly what the website's going to look like with this PR in, go and check everything, and then approve it. And when it's approved, then that's exactly what you'll get as soon as it's deployed it to public. So it means you don't have to do these horrible sort of workflows where you've got an update on a public site and you have to log in to see the changes, and you have all these complex workflows. You can just see exactly what the public are going to see as soon as it comes in, and approve on that basis. Another nice thing that's built into static web apps is authentication. So what they've added in is they've added in some OAuth login endpoints that you can use. So essentially, you've got a path called .auth/Facebook, for instance, and if you direct somebody to that endpoint, then it will go through the Facebook workflow. You can also use Azure AD, you can use GitHub, you can use Google, and you can use Twitter. I'm imagining they might even support Microsoft logins one day, but there's always that hope. But that's all handled for you. So so when you log in, those credentials are handled. You get a JWT, a JWT token. You get a few claims on that, so you get to know what the identity of that person is, which provider they use to log in, and obviously it's got a log out endpoint as well. But you get all that built in, and you can then go and use that in your API. So the nice thing about static web apps is you don't have to build a separate API project. You just have an API folder in your web app, and you can put in there essentially a standard Azure Functions project in either C#, JavaScript or TypeScript or Python. Again, I assume that other languages will be coming along as well. They actually launched with only JavaScript, so they brought in C# and Python since then. But those functions are then part of your project, so they get built and deployed at the same time. They run within your site, so you don't have to bother about cross-origin things. And as long as you've used the standard OAuth authentication there, then they also, as well as being barred at the routing stage, which I'll talk about in a minute, they also have access to the information about the user that you're logged in as. So that can be used for whatever whatever you need behind the scenes to provide the information for the person who's logged in. Routing, as I was just mentioning there, you can configure a fair number of things in this special routes.json file. So you've got the standard routing, which is path rewriting, so you can take stuff that's coming, take paths that are coming in and send them to different paths. So for instance, if you want /login to go to /.auth/Facebook, so you always have a Facebook login at the /login thing, you can do that. And also at that level, you can add role-based access control. So in static web apps, you can define user roles, and then you can invite your Facebook users or your AD users to specific roles, And then you can, in the routes.json file, say that, for instance, /customers is only going to be visible to people with the customers role, or /admin is only going to be visible to people with the /admin role. It also allows you to do proper redirects. So if you want a path to go off to somewhere else with a 301 or 302 redirect, you can add that in. It's where you define your custom error pages. So you're pretty not found, or you're pretty sort of oops, something went wrong page. You can pop in MIME types if you really need them, and also, again, useful mostly from a security point of view, you can stick custom headers in there. So if you want to add the I mustn't be in an iframe header or something like that, or if you want to remove headers that you think might be insecure, then you can do that through the routes.json file as well. So that's where you essentially do all that configuration to make your site look like you want it to. And if you're moving from a WordPress site, you might want to be, to throw a load of routes in there for your old URLs to, sort of the URLs that you've actually got in your in your generated content. Some other useful things. It supports custom domains. So if you've got your own vanity domain, so if you want to bring along markxa.com, then you can do that. Well, when I say that, that's not strictly true at the moment. In preview, you can only bring www.markxa.com. So they're not supporting Apex domains in preview. I assume from the way they phrase that it will, once it goes GA, be able to do Apex domains, but you can't do that right now. So if that's important to you and you can't do a redirect to www, then you might have to step back for a minute. But that's basically in there, and obviously SSL certificates and stuff as well. There's a Visual Studio Code extension that you can use to develop and deploy all this sort of stuff. And there's just a list there of some of the frameworks that they say will work with it. So as long as you put the right build command that we were talking about, you can run on any of those frameworks and many more. Just essentially out of the box. So this is normally where I would ask for questions, but I'm guessing we're not going to do that in the virtual one. So I will move over to a brief demo here with a bit of luck. So what I'm going to do here, I'm going to be building a Hugo-based website. So Hugo is a static site generator that's based, the reason it's called Hugo is it's based on the Go language templating engine. So I'm going to take a dummy WordPress site, pull that over, turn it into a Hugo site, and have just a tiny bit of JavaScript and Azure functions going on as well, just so you can see how that hangs together. So, all right. So this isn't the one I'm going to do. This is just an example, just so you can see how Hugo works and how how a static site generator works. So here I have the sort of the Hugo site for the developer conference I was talking about before we started the session. And you can see in here essentially, we've got a content folder, static folder which contains fav icons and stuff, and then there's a theme there which contains the layouts and things and static files for the particular skin or theme or whatever you want to call it that our site is going to use, and then there's a basic configuration file there. In the content here you can see files like this, so that's basically markdown with some front matter. So this is the content for a specific session that's going to be delivered by a couple of different speakers. Day 2, track 2 at 4:15, and this is some markdown text that gets generated. And this is how Hugo does it. So everything is basically templated off content. So this is a Hugo template where I'm pulling in all the sessions, and then I'm picking out day 1, track 1, day 2, track 1, sorting them by time, and then doing some simple templating down here, pulling in some partials. So very simply, that's what one of these sites is going to look like, from, sort of before it's built. And then once it's built, so it goes into, when you build it, it goes into this public folder, which isn't in source control. And you can see that turns out with an index.html file, which pulls in all the CSS and stuff we want. So, that just gets generated into this purely static site here in the public folder. And, so that's what that looks like at the end of the day. So you can see here, those testimonials that are going through there, they are, so in the testimonials content there. Further down, we've got sponsors, platinum sponsors, we've got gold sponsors, we've got a list of speakers, and that page I was showing you earlier with the agenda. So, that's how we've drawn that all together, is, sort of through just basic content and templating. So that's the sort of thing I'm going to build. So the next thing I've got here is just a little WordPress site. So, all I've done here is I've just fired up a couple of Docker containers with the standard WordPress Docker stuff in it on my local machine, and thrown in a bit of random content there. So there's a few pages, and if we go to the top level there, we can see there's a few, just four dummy posts in there. And what we then need to do is to go and create a static, we're going to create a Hugo website and create a static web app for that. So first thing I'll do, I've got an empty-ish repository here, my virtual Azure Community Day demo repository there. And what I will do is I shall go to the portal, Azure portal, and create a static web app. Those, I'm going to create a new one. So I'm going to pull up one I made earlier. I'll call it virtual Azure Community Day demo. I'll stick it in Europe because we like Europe. I will sign in, whoops, with GitHub here. If I can find it. Second, I'm just going to do this on the other screen. Right, so I'm logged into GitHub. This is all live, by the way, I'm not recorded. Mark XA is me. That was the VACD demo repo, and it's going to be on the main branch. And then you can see here, it's got some presets here. So you can see the standard JavaScript and front-end frameworks there, and then static site generators you might want to use, or if it's none of those, then we can go for custom and fill our own thing in here. We'll go for Hugo there. We could configure those if we wanted to, but as you can see, public was where we were going to dump our actual output, and the actual Hugo site is just at the root level. So that will then create, we can see here, that's going to create a GitHub action workflow that does what we need there to push it out to static web apps. So I will create that. We'll deploy. Doesn't usually take very long. There we are. And here we are in our thing. And so if I hit that there, we'll see that we have an empty static web app waiting for us. So next thing I'm going to do, I am going to bring up. So this is Visual Studio. Don't worry too much about this code. This is stuff that I've mostly nicked off other places. But just to show you what's going on here, that is essentially some code that understands the WordPress API and understands Hugo, and can pull the content and pages out of WordPress and turn them into Hugo content. So, and this is where I cross my fingers very hard. If I run that. I'll just go through, pull the stuff out. And it ran. So now what we should have here is a Hugo website into which we now have posts generated there. So that one's just been created there, as you can see just now. And you can see here's the content that we've created. So if I now go into the console here, I will add all my content. And I will push that up to, oh, of course, what I forgot to do there was to pull the changes when it went and pushed its GitHub Actions into my repo here. So if I refresh that, you can see here in GitHub Workflows, that's where that YAML that it created has ended up. And if I go to GitHub Actions here, you can see that it's now running that build and deploy for us. That will potentially take a minute or two, so I will just go quickly back over here and just show you what I've got in here. As well as all these folders, which are just the standard Hugo stuff, and the GitHub folder, which is our actions, we've also got this API folder. And within that, we've got some Azure functions. So here we have a very simple Azure function in JavaScript, which just pulls in essentially the contact form that we're submitting and returns it back as a response. In the real world, we'd have a contact form that would actually do an output here to some sort of email service, but in this case we're just returning it straight back. But that's an example of an API. And if we go back, that's nearly done there. And deploying. Didn't take very long. These always run faster when when you're not live. There we go. So if we go back here and to refresh there, we have now, this is now a Hugo site with all the same content in it. Now here, obviously, we've got an off-the-shelf Hugo theme rather than an off-the-shelf WordPress theme. Now there are actually some WordPress themes which have a WordPress equivalent, but you can see here, this is a different site, but with all the same content in. It's not that difficult to turn something into a Hugo theme because at the end of the day, it's just the same HTML and the same content placeholders just in Go format. But you can see we've got a list here to all our blog posts. We've also got here that page there that we saw earlier, and we also have. Oops. We don't have. Okay, well, it's just proving it's a live demo. The API, the contact form didn't end up in there for whatever reason. But I suppose I'll just generally talk here about if you are moving from a WordPress site, you can get all the content over like this. If you've got a gallery, for instance, you'll need to pull in some sort of JavaScript gallery, even an old jQuery one would do, but something that can take those those images and turn them into a gallery. And any of your other WordPress plugins, if they're not the SEO ones and stuff that you don't really need with a static website, then you'll need to replace those with something that either you've written yourself or some sort of plugin. So for instance, WordPress comments, so if you want people to be able to actually comment on your blog posts, Hugo by default has Disqus built in, but it's that sort of thing where you'll want to drop in somebody else's third-party JavaScript or write your own API and call out to that API depending on exactly how custom you want it. Right, I think that's everything for the demo. So we'll get back to So did somebody say something there?
Yep, we're back in the studio. So, yeah, thanks, Mark. This was a great session. I don't think you were quite finished yet, but because we are running out of time.
That's the summary slide. That's the end.
That's the end. Okay, sorry then.
We killed the final slide. We do apologize for that, Mark.
But there was this question if you are willing to share the slides. So.
Yes, absolutely. What I'm hoping to do is to get all that code tidied up, and actually, I'm going to be hopefully turning this into a workshop that you can step through as well properly. So
that would be great.
Something on GitHub as well.
That would be great. So I have one question for you. So the PR preview that you showed us, it looks really great. Is that like comparable to staging slot in app service?
It's the same sort of thing. You don't swap the same way as you would with slots in app service. It's just a completely new site that's been created and it lives by itself. So as long as the PR is there, then that will be deployed. And as soon as the PR gets closed, then it will get deleted. But so it's a completely separate website. But yeah, you can think of it as very similar to slots. It's just you're not swapping. You're doing a separate deploy then to the main public one.
Exactly. Okay, thanks.
Yeah, so the only remark I basically had, well, maybe it's more a confession because I am one of those WordPress dinos out there. And it felt a bit scary to see that I could easily transition into a modern website this way. But you totally convinced me when I saw GitHub Actions. So I'm gonna change my website.
You don't have to leave WordPress behind entirely. If you like the WordPress authoring experience, you can still use that. But say it's the public experience that you're looking at here. So the really fast sites, the really fast load times, and the high security because your WordPress site is now behind a firewall and nobody can hack it. Hopefully.
Okay, that's good to know. So thank you very much for the presentation. And hopefully we'll be able to meet again soon, maybe even in a live setting.
Let's hope so. Vaccines ahoy, apparently. So.
True.
All right.
So thank you,
very much,
Jorrit, as well for hosting with me today,
too, Esther.
because I really had a great time. But I guess all good things must come to an end.
Yep. The next hosts are
eagerly waiting.
Eagerly waiting. So that's it for us. So thank you very much for having us, and hopefully we will see you next time.
Enjoy the rest of the event. Bye.
And welcome back, everybody. Thanks to Esther and Jorrit for that last session. Welcome back to the VACD from us, a full day of amazing content from the Azure community across 6 different tracks. I'm Stacey Cashmore. I've been a developer for since the mid-90s. The last couple of years, I've started sharing some of the things I've learned at meetups and conferences, and I'm going to be here with you for the next 3 hours with...
Nick. So I'm Nick Droch. I'm a developer audience PMM at Microsoft. What I do there is pretty much I try to do fun stuff with developer community, so really having a blast. I've been in development for 35 years, if I count my early years with my TRS-80. And so, yeah, if you're joining us, make sure to join us also on chat. We want to hear from you, your questions, all of your experiences. Share those crazy pictures with us. And also, don't forget and check the link at the bottom of the screen there. Join our challenge as well. And so, who do we have next?
Well, next up, we have Rickman Bosch talking about handling Azure configuration correctly. And I'm sure we've all been through that stage of getting started with Azure, seeing just how easy it is to get a load of stuff deployed and working, and you can see it online. But that's not real life, is it? And Rick says there's a simple and quick way of doing it and a right way. And that's what Nick's going to take us through today. Rick is a coder, although officially I believe he's a principal cloud architect. He's been working with Azure since it was first introduced. And he creates stuff hands-on in the cloud and helps people migrate with migration strategies. And that wealth of experience he's going to share with us today. Welcome, Rick. Thanks for joining us.
Oh, thanks for having me, and welcome from Eindhoven.
And, well, when you're ready, take it away.
Okay, cool. Well, I think we did have a small glitch with me trying to share my slide deck and my video. So I'm going to switch over to my screen, and probably there my video might stop working. But at least you guys will get the content, and you guys and girls will get the content and audio, right?
Okay, we've got audio, but I'm not sure we're seeing it yet.
Now we got the slides.
Okay, that's a good thing. So configuration in Azure done right, as you said. There's a simple way of doing it, and then there's the right way of doing it. So I'm Rick. You introduced me quite well. Thanks for that one. So let me take you through what we're going to do during this session. We will do a short introduction. I will tell you something about application settings, app configuration, Key Vault, which is for managing secrets in the cloud. Then I will talk about managed identities for Azure resources. And lastly, we will do a closing and look at what we saw today and how we can use it. So let's start with a short introduction by actually saying, so that configuration, right? What is it actually? So in the end, configuration or configuration files are files used to configure the parameters and initial settings for some computer programs. This is what you get when you look up configuration file. And in the end, things like settings and how application works, like email addresses to send email from, or connection strings, or resources like databases, that's stuff that typically goes into a configuration or configuration file. Now, if we look at a long time ago, maybe some of you still know this one. These were ini files or initialization files. A long time ago, this was how you configured an application. And you had the settings in this .ini file that actually held the settings for you. And then after a while, Microsoft started with registry and having registry as the place for your application settings. That didn't go down too well. So, for instance, webconfig came along, which was the way of configuring ASP.NET applications. And currently, we're using a lot of app settings.json files, for instance, to have settings for your applications be available for your application. So this is kind of the road that configuration has taken throughout the years. But now that we're going into the cloud and into a more cloud native application structure, these might not be the best ways to go about it. Of course, registry isn't available on PaaS offerings like App Service or Azure Functions, but also having stuff in a web config or in an app settings.json file means that it's tied to that specific application, which might also mean that if you have, for instance, one database that's being used by a lot of different services, you might have that setting for that one database in a lot of locations. So tied to all of the applications that you're actually using that database in. So there's a better way to do this. If you would like to share your configuration throughout different types of applications. First of all, let's see how we tie an application setting to an application if we are using Azure. So that's something that's called application settings. And if we take this example of the Azure portal, we will see that on the left-hand side, we get all of the blades that we can choose under, in this case, an app service. And there you can see the selected blade at this point is configuration. So configuration enables you to have application-specific settings and application-specific connection strings. And there's also some general settings about the app service that you're actually running, like the version of .NET that you would like to target, and all that kind of stuff. Now, this is how application settings are available in the portal since early app services. These application settings are being made available to the application through environment variables. So if you, for instance, take an ASP.NET or ASP.NET Core application and you host it on an app service, then the settings that you put in configuration settings are actually available as environment variables. It's like the app settings element in the web config of older ASP.NET projects or the new app settings.json file. And values that you put in application settings configuration actually override the ones that are in web config or app settings.json, which means that you can have a value specified in application settings in the cloud. And when you push, your web config or app settings.json file will travel with the application into the cloud. However, the setting that you have specified in application settings will always overrule. This enables you to have, for instance, development settings in your local web config or in your app settings.local.json file, and then specify production values in the app settings of the Azure App Service. These application settings are encrypted at rest, and they are hidden by default, which means they will not be available if you click on configuration in, let's say, a demo during a session that's being broadcast on the internet. And they enable bulk edit, which is actually quite cool. Now, as I said, especially with the fact that microservices are here to stay probably, and the fact that we have all types of serverless applications like functions targeting our resources as well, having these settings be available in a central location would be awesome. So then you have one location where you can handle the dials. And for instance, if your database is migrated into a different type of database or to a different location, so your connection string should change, you can do so on one location, and that will propagate through all of your applications. Now, that would be awesome, and that's where app configuration comes in. So app configuration is a service in Azure that actually enables you to have a universal, fully managed configuration store in the cloud available. It enables fast retrieval of configurations for any Azure application, and you have complete data encryption, both at rest and in transit. And then the cool thing is, Microsoft is targeting open source more and more. I think that's an awesome thing that's happening to Microsoft and its ecosystem. And it also means that app configuration will tie in natively with a lot of popular frameworks. So not only .NET, but also, for instance, Java Spring. What having a central location for your application configuration enables you to do is to reduce the configuration complexity complexity across multiple environments. So as I said, with microservices or maybe even micro frontends being front and center lately, and all types of serverless applications that we have as addition to our applications to actually form some sort of a ecosystem of applications that work with our data, it's really cool to have one central location to have that configuration so that it reduces complexity. It also improves security because it separates out configuration from code. So for instance, if you have a connection to a database, it's really better to not have that configuration anywhere in your application or in the configuration of your application that's committed to Git. I am going to tell you a little bit extra information later on, because storing your secrets straight in app configuration might also not be the best solution, but we will dive into that later. First of all, I would like to address something about pricing, because Azure App Configuration is out of preview for quite some time now, and pricing has been made available quite some time ago. And as you can see, you can have one free Azure App Configuration resource within a subscription. So each subscription can have one free tier of app configuration available. Otherwise, you'll get the standard. So with free, you get 10 megabytes of storage. Per resource, you get a 7-day revision history, and you can do 1,000 requests per day. And after those 1,000 requests, you'll get 429 results. You don't get an SLA since it's the free version, but also you don't pay money. Now, the priced version is better. Actually, it's been GA since February 19th of this year. It gives you 20,000 requests per hour within the build quota, and it gets you all the free tier functionality plus encryption with your own managed keys and private link support. Now, private link is something that I could go on and talk for another hour probably, but unfortunately we don't have time for that one, so I'll keep it to this for now. The cost at this point is just over €1 a day, plus an overage charge with 5.1 cents for each 10,000 requests that you do, and the first 200,000 requests are included in your daily charge or your daily coverage. So going to a pricing example, just to get this out of the way, if you have an average of 400,000 requests a day, which I think are a lot of requests, your daily costs for having this app configuration up and running would be €1 and 1.2 cents, because that's the base charge per day. And then you pay an extra of 200,000 divided by 10,000 times 5 cents is another €1 and 2 cents for the overage of your requests. So with an average of 400,000 requests per day, your daily cost would be a total of €2 and 3 cents for that day. Now, as far as I'm concerned, that's a relatively small price to pay, given all the benefits that you get from it. But you shouldn't take my word for it. We should have a look at a demo and see if we can get that stuff running and see why it's so awesome to have it running. So I'm going to go into, yeah, I can see that my screen is still shared, so that's a good thing. I'm going to go into Visual Studio right away. And the reason I'm doing this, and I think I will bump it up just a little bit to make sure that it's legible also on somewhat smaller screens. The reason I'm doing this is here we have app settings.development.json, right? These are my local settings, and then I have a setting with the awesome name setting1, and it has the value, here's a local value for setting 1. That's my development version. My app settings version, I'm really happy that the secret is now out of reach. You can see here that this value is from app settings.json, and I actually added some HTML markup there, which you would never do normally. But right now I do this to make it cleaner on the display later on. Now, this is the value that we have locally, but it is the value for our production environment, right? So if I now jump into my Azure environment, and I'll go and take this one. You can see that I have a few types of resources available. Can I really not make this any? There we go. Just a little bit smaller, and at least it fits the screen. So one of the cool things that we have here is the application itself. This is actually a deployed version of the application that we just saw. And if we go in there, we can see that this is a website running .NET Core. It had some requests earlier today. And if we go into configuration, we're not going to see anything that looks like setting 1. So looking in this right here, we don't have a setting 1 anywhere, which means it should take the version that's in app-settings.json. Now, first of all, let's have a look at the app-settings.json. And maybe some of you knew this already, but if you go to the kudu location of your app service, and then you add /dev, you get something that looks a lot like Visual Studio Code that enables you to do some editing online. So right here, this is the app-settings.json in the application. And to make sure that we see this, here's the actual result of the website. It says configuration in Azure done right. Here's the value for setting 1. This value is from app-settings.json. Now, if I refresh this, I probably get a small a cold start thing, but I will get again, this value is from app-settings.json. And just so you know, I'm going to create this or change this and make it VACD for Virtual Azure Community Day. And then if I refresh it here, we can see straight away this value is from VACD. So we're actually taking the app settings version right here. Now, what I actually wanted to show is that if we go into configuration again, and I add a new application setting, and I call it setting 1, and then I will say this value is from config settings. Wow. Just typing in front of an audience, right? So, or actually I should say application settings, because then we can distinct it better from the other one. So I'm going to save this down, and then of course this is going to have that small slow start again here. If I get a refresh on the application, there it goes. As you can see on the top now, it's loading. And then as soon as this runs, we will see this value is from application settings. That's something that we put there, right? So the code didn't change. The only thing I changed was in application settings, I now entered this setting, and as you can see, it overrides my app-settings.json. So that's the first level of getting configuration in a manageable structure, because you can now change this in the portal. But we want more. We don't want this to be in each application. We want this to be in app configuration. So we only need to do a small thing for this. So if I go back to the resource group and I go to the app configuration that I have right here, let's have a look at what we have in an app configuration, because we don't only have access keys that enables you to connect to app configuration. We also have Configuration Explorer, where we can actually see some of the settings that we have in Azure App Configuration available. And now I think I have the same version available there as I have in my head. So if I put a setting 1 over here, and I say this is from app config external, just to make sure that we have something that's really explicit, and it's created, and I refresh it just to make sure. Then we go to the application, and while I click around, I'm going to tell you that Azure App Configuration does support auto refreshing when keys change. For now, I chose not to implement this, but you can have your application automatically re-get all of the information that it gets from Azure App Configuration as soon as a specific value or any value changes. So if we refresh this one right now once again, I hope that we will get that this value is from app config external, or at least that's what I expect it to be. So just a little bit of slow start or cold start, that's not an issue. And here we go. This is from app config external. Now still, as you can see, the application hasn't changed, but the values that it picks up have. Now, let me show you how that's done, because it's actually really simple. Right here, there's this one thing that we added. And let me get rid of this one so that we have a full view of what's actually happening. And I only need to show it up, up until here, and then just a little. Dude, why do you do this? Okay, last chance. Here we go. So what we actually did is in our startup of our create host builder of our application, we get iConfiguration, right? And iConfiguration is the standard for getting configuration in an ASP.NET application. And what happened actually is that we get the iConfiguration builder right here, and we get it passed into configure app configuration, the method that you can see right here. And this one is one that you get when you install the correct NuGet package for actually working with Azure App Configuration. Now, what we do is we build the configuration builder because we're going to want to get a setting from our settings environment, so from the iConfiguration. And then we are going to configure Azure App Configuration, and we're going to say, I would like to connect to this app configuration connection string. And this app configuration connection string is actually sort of a connection string that you have for, let's say, SQL or storage or something else external. But that's also straight up the issue that we have with this approach. We now have an app configuration connection string that's actually a gateway into the storage of all of our secrets, right? Because the app configuration will hold the connection strings to storage, to SQL, to anything, but there will also be some secrets in there because those are in connection strings. That's not what we want to do. We want to get those out completely. That's something that we will touch on in a little bit. The only thing I would like to say is this is the only thing that we do to add app configuration to our ASP.NET application. Now, to show you how this, or what this looks like in the actual index page where we get the value, this is where things get interesting. This field only holds the normal iConfiguration that we know in ASP.NET. And then there's a property that's actually a setting1 string, which we use to output our information. And in the constructor, we get the normal, let's say, iConfiguration in our constructor, and we put that in the field that we defined over here. And then for my code, it's completely transparent that I need to get a configuration value. And in this case, I'm going to get a value of type string with the name setting1, and I will put that in the setting1 property, and then that's output on the page. So for me as a page developer, let's say, in this case, this looks like just getting a normal version of a setting from configuration. In the end, it takes the one from app configuration. If that's not available, it takes the one from the app settings from the app service. If those are not available, it will take the one from app settings.json or web.config. And if that's not available, you'll get an error. But you can stack the different types of configuration providers that you have. This is also something that we see as far as filtering goes, but in the interest of time, I'm going to not dive into that a lot, except for what we say here is that we stack the filters while connecting this app configuration, where we say take the one that's labeled prod if it's available, and if that's not available, take the one that's labeled acceptance. And if that's not available, take test. And if that's not available, then default to not having it's not having a label at all. This will enable you to do some setting stacking. However, this will get the exact same result as we have what we have deployed right now. Let's go back and see what Key Vault has to offer us. Because Key Vault is actually what it says it is. It's a vault for your keys. It stores secrets, certificates in a vault that you cannot just simply access. You will have to make sure that you are authorized to get access to the Key Vault, and only then you can look inside and you can see tokens, passwords, certificates, like, for instance, API keys or encryption keys, and those are available in the Key Vault. It also enables you to store secrets that are backed by hardware security models. So you can choose to do it either by software or FIPS 142 level 2 validated hardware security modules. So why would you like to use Key Vault? Well, as I said earlier, you don't want app configuration to hold all of your secrets, but then still have a secret that enables somebody to get into application of app configuration. So you would like to securely store your secrets and keys somewhere external, and it would be awesome if those integrate with Azure services. Now, Key Vault is a tool for securing, storing, and accessing secrets, and a vault in this case is a logical group of secrets. So authentication to get there is needed. You can either use a service principal and a secret, or a service principal and a certificate, or you can use managed identity. And let's just have a look at how we do that. So this extra line that I added earlier, and that you might have seen in the previous demo, actually already gives away a little bit how we are going to access Key Vault. But first, let me show you that we have two pages. One is Key Vault 01, and one is Key Vault 02. And Key Vault 01 is the first version of how we are going to connect to Key Vault. Let me give me an enter right there so that we have a little bit clearer view on what's happening. So on the get of this page, we're going to create a new secret client that uses configuration in Azure done right, cother-key vault2.vault.azure.net. That's the location of the Key Vault that we created. And then we get the secret from there. And this actually looks a little bit strange because we have a double value at the end. But the first value is the value of the get secret action, which actually returns a Key Vault secret. And a Key Vault secret actually holds quite a few types of information about the secret itself. And one of those things it holds is the value of the secret. So that's the reason we're going to go with value.value. And what this actually does, and then this line is particularly interesting, is it says, I will use a default Azure credential. What this means, and I'm now guessing why did I implement this here, because this should be in Key Vault 02 probably. Did I switch the two around? Let me check real quick. No, this is correct. So what I did here is I'm going to create a secret client, which is actually a class that's been added to a NuGet package that enables us to talk to Key Vault. And I'm going to use a managed identity to connect to this Key Vault. And then a managed identity, and I will dive into this a little bit into more detail later, but a managed identity is actually a service principal that an application or another resource inside of Azure can get, that's actually stored in Azure Active Directory, that you can then use to give role-based access to different types of resources. So what we did here is we created a secret client to talk to our cother KV2 Key Vault and get secret 1 from that Key Vault using that managed identity. Now, going back to the application that we had up and running, you can see here that we have this Key Vault 1 page. So that's the page that's actually going to create the secret client and talk to Key Vault for us. And it says, hey, this secret is from Key Vault. Now, what this looks like in the backend in the Azure portal is under this resource group that we have this Key Vault available right here. And this Key Vault is actually the storage of all of the secrets that we would like to have in this Key Vault. And as you can see, let me check real quick. We have some keys here. So for instance, encryption keys that you could add here. Some secrets. So here's the secret one that we're actually getting. And we have certificates. And then there's something really important that I need to tell you, because we used to have the Azure policies, the access policies, sorry. And access policies used Vault access policies. And then you actually had to give identities of Azure Active Directory specific rights, like listing secrets or getting keys. And that was the authentication mechanism. But with the rollout of role-based access control based on managed identities throughout the Azure portal, we now also have access control through Azure role-based access control in preview, as it says right here on the selected bullet. Access control is in preview. So what you do here is you can have role assignments that enable specific applications or specific users to do specific things. Now, as you can see, the website and, well, myself are Key Vault Secrets users, which actually means that these are service principals that can read secret contents. This is the central location where I actually manage who can do what inside of this Key Vault. And because I gave this website access to this Key Vault, I don't need a access token or, sorry, a specific access token or a connection string with a secret to connect, but the Azure platform validates the application itself as being or as having rights to actually connect to this Key Vault. So just a short round trip to the website again, where you can actually, with most resources right now, say, hey, I have an identity, or you have an identity. I put that to be on. And as soon as I add this system assigned identity as on this website, I can go to other resources and give this application access to that resource. I will show you why that's important. So first of all, I'm going to go back once more to the app configuration. And I'm going to show you that right here under Configuration Explorer, we have this one here, which actually has a specific type of icon in front. And it says that this is secret one. And thinking about this is actually the same name that I gave that thing in Key Vault. What I actually did was I added, so when you choose create, you can choose between Key Vault or key value or Key Vault reference. What you can do with app configuration is you can give something a name, like very secret, much hidden, and you can select a Key Vault that you would like to access, and then select a secret inside of that Key Vault. So you can have app configuration be the middleman between your application and Key Vault for secrets. The cool thing is your application doesn't need to know, because as with the index or the index page that we saw earlier, here we just said, hey, configuration, get me a value of type string with this name. Because we now have secret one available in app configuration that uses Key Vault to actually store the secret, we can just as well go into our different Key Vault page and say, hey, configuration, get a value of type string, but this time do secret one. And of course, if we go back to the application and we open up the page with Key Vault 2, here is the same secret. So even if I now would change this in the Key Vault, we would get the same secret. I'm going to go straight back into the presentation because I have one very important thing to add. And looking at the time, we are a little bit close. So as I said, managed identities or managed identities for Azure resources are a way of actually creating an identity for your application that provides Azure services with a managed identity in an Active Directory. that you can actually use to identify and authenticate to any service. There's a lot of services supporting it right now, and both on the compute end, like functions and logic apps and app services, as well as and the resource end, like Key Vault and Data Lake and storage for blobs and queues. But let me show you the real power of actually having a managed identity in place. Because I added this extra page right here today that's called storage. And we're first going to dive into code and have a look at what that storage page actually does. So we're going to the storage page, and then we're going here. And then this might seem a bit complex, but it's actually not as much. So I'm going to show you what's actually happening here. We're going to create a container client. And this is a blob container client. So we're going to talk to a container in a blob storage. To know where we would like to have or where that blob storage is located, we're going to get a value from configuration that's called session container. Here again, we'll use the new default Azure credential that enables us to use managed identity to talk to storage. And actually, all of the other things are actually getting a reference to a blob client for a specific file. And in this case, that's called nextsession.txt, getting a memory stream, downloading that blob into that stream, putting the position of the stream back at the position 0, reading it, and then we will have the read to async of that reader. So what this piece of code does is it connects to a storage account, gets the next-session.txt file from the session container, and it outputs the content of that file into the next session property. And then if we look at the page itself, of course, the next session is actually shown in a div right here. Now, what we have available as the next session parameter, which is how we're going to connect to our storage account, is actually this one. And whoops, that was a small document, but that's not big of a deal. Here we have the session container. So this is the setting that I'm actually getting, right? So I'm saying I would like to connect to the container sessions, which is right here, under, wow, I even mistyped Ciara, under this storage account, blob core Windows net. So I'm not specifying any secrets right here. The only thing I'm specifying is the location of a blob container where I would like to get a file from. And then again, if we go into the portal and we look here into our session container value right here, close this one down, okay. If we look at the session container right here, it actually also says, so guide of storage.blob@core.windows.net/session. And just to make sure that you guys and girls know that I'm not having any smoke and mirrors, right here is the storage explorer for the storage account. And under blob containers, there's a session. And under session, there's a next session.txt. And this is the file that I would like to display in the page. So once again, I don't have any secrets available anywhere in configuration or in my source code. But because I have a managed identity available, and if I now go to storage, it will use its managed identity to actually go out and go to the blob storage. And then the platform will say, okay, so this is the Ciara website. It has an Azure Active Directory service principal in Active Directory. And under the storage account, this same service principal has gained access to read blobs in this storage account. I don't have connection strings. I don't have secrets. I only have the description for the next session by Tomasz that will be about exploring capabilities of different Azure services for automation on simple and daily tasks. So closing up real quick, configuration, I think, should go into app configuration as soon as more than one application is talking to that configuration, because you would like to minimize the chances of actually human error, because you might update one setting but not the other one. And then if you would like to make sure that you don't even have any secrets anywhere as far as accessing Azure resources goes, have a look if the resource that you are trying to talk to enables you to use managed identities, and please have a look at using those. If you go to theurls.com/configuration in Azure done right, but then abbreviated, so theurls.com/Sjadder, there's a lot of links right there about all of the content that was in this session. And of course, you can email me or find me on Twitter and see if you can get me from there if you have any questions left.
Well, thank you very much for that, Rick. That was a really cool session. There was a lot of really deep stuff in the configuration there. There's a lot of stuff there that I need to take a look at too. I also really want to say thank you for that blast from the past with those INI files. I remember fighting those back in the 90s, and I remember salespeople in our office playing with them when they shouldn't, and then really having to fight with them in the office. That was really cool.
Somehow there was never a backup of the right INI file, right?
No, it was never backup of the right INI file, and everybody always comes out with, I never changed anything, which eventually changes over time to, I changed it, but I changed it back.
Yeah, or I made it better.
Yeah, exactly. We've got one question for you from YouTube, and that is, can automation accounts also get their variables from the app configuration?
Yes. For instance, automation accounts. Wow, that's a good one. I wanted to say yes because I have Power Automate and Logic Apps on top of mind as well. Let's see if Azure Automate, I'm not sure if it's supporting managed identities. The last time I checked, it didn't yet, but that's something that I do need to talk about. Microsoft has actually explicitly said we are going to support managed identities throughout the Azure portal. So they're actually actively working on getting it everywhere. And if I look into Azure Auto Manage, Azure Blueprints, no, currently it's not in the list of, doesn't seem to be in the list of services that support managed identities for resources.
Okay. But hopefully it might come in the future if they're committed to getting this across.
They are committed to getting it across the entirety of Azure, so I would expect it to come in eventually. Because, for instance, blob storage and queue storage both support managed identity at this point. However, table storage in storage accounts doesn't yet. So they're actively working on it.
Okay. Did you have any other questions?
Well, actually, Rick, I had one question for myself, actually. How do you go about, maybe any advice about how do you integrate configuration and your application together in your CI/CD pipeline? Because, well, you don't want your configuration to be out of sync with the changes that you've made in your application. Any advice on that one?
Yeah, that's a good question, by the way. Yes, because Azure App Configuration enables you to use different types of infrastructure as code solutions to update the settings in App Configuration. So what we do right now is we use the Azure CLI, which can be used in the Azure pipelines as well. And we use Azure CLI to keep the settings up to date. As far as it's not secrets, of course, because secrets are going into Key Vault. But there's several infrastructure as code solutions that provide support for setting values in App Configuration.
Yeah, so it becomes actually an integrated part of your CI/CD pipeline as any other thing would be.
Yeah, and I think that's the place where you would like it to be, because then everything is repeatable. And if somebody said, I changed it, but I changed it back, then we can just, with a push of the button, know for sure that the values are there that we would expect there to be.
Indeed. I say automate everything.
Automate all the things.
Okay, well, thank you very much again for joining us today. And Nick, who do we have up next?
So up next, and a warm welcome to Thomas Castren, who is a data platform MVP with a passion for SQL Server for about 20 years already, and also data science. And actually, data science is a a bit of a passion for myself. And so one thing I really liked in researching a bit the work from Thomas is he's actually a maintainer of the useless R functions. So you might wonder, useless, why would that be interesting for me? One such function that is in there is basically a job title generator. Which is kind of nice and kind of fun. And so I'm hoping Thomas can also share a bit on his roadmap, what other functions are coming, which may be more or less useless for the people. So in the upcoming session, we talked about automation. Thomas will be talking about automating your social life, and we've got dinner time coming up, and the smell of food is entering the room here. So it might be an ideal time to get everything automated, so we can spend some time, grab some food,
get some energy.
Get some energy, indeed. Without further ado, I want to hand it over to Thomas. Thomas, are you there?
Hello. Good evening. I hope you can hear me.
Definitely, we can hear you fine.
Oh, beautiful, beautiful. That's a lovely intro you made, especially with those useless functions. Now, it's going to be hard from there. Yeah, there's a lot of useless functions coming up. So yeah, but if you have any useless idea, it's more than welcome. Yeah, especially it's a beautiful, how to see people collaborate in GitHub and send me ideas or say, okay, this is a bug or there's a improvement of the function and stuff like that. So it's I just love it. So and the job title there, that's I used to run a website also in Azure that was actually Transact SQL job titles. So. But then I decided to put it down. So, okay.
Okay. Well, thanks a lot, and keep them coming. So you have the floor, and take it away.
Beautiful. I'm gonna share my screen, and let me know if you can see my slides.
Yes.
Okay. Beautiful. Okay. So is that 40 minutes or so?
Yeah, roughly so.
Okay, beautiful. Thank you. So, good evening, everybody. It's evening in Slovenia, and we just had a probably like 15 to 20 inches of, centimeters of snow today. So it's a beautiful winter day. Today, I'm going to talk about how to automate your life, especially online. With Microsoft Azure, I am a huge fan of automation. So everything that can be automated, it's my flavor. Couple of words about me. If you want to get in contact, go to GitHub or follow me on Instagram, LinkedIn, or Twitter. It was a beautiful intro, so I'm not gonna lose any time here. So the agenda for today, I'm going to go through what is social life and its features, especially in this time, in this unprecedented times of beautiful lockdowns and stuff like that. So, and I'm going to talk about some Azure features, especially Azure Functions, Logic Apps, and virtual machines with Python. And the whole idea of this talk is just to go through a couple of recipes. So ideally, just to give you a glimpse of how you can go along, how you can get started with Azure. I've seen a lot of people have developed some sort of fear or something. So this was more like getting people on board and saying, okay, it's not that scary. You can do a lot of interesting stuff. So recipes for today, the way I've envisioned it, are how to get the best prices with your particular local retailer, how to prove a Twitter account and tweet some useless stuff again no one really wants or no one really wants to read, how you can create an Instagram profile and share some photos of your cats, dogs, or wine, which are three of, from what I've seen, the most favorable topics people like to share. Hiring people, just to give you an idea, how you can go along with that. Getting some real estates. There's a lot of people, wanting to be the first to get, a better deal when renting an apartment or buying a particular land, etc., etc. The last one, sending text, SMS, short messages to all of your contacts when they have birthdays. So it's also something, of course, you need to do. And as of those social things like Tinder and stuff like that, I'm not gonna discuss that. But there's a huge potential also. I've sort of marked them in red and green. So the green means that can be fully automated. Red sometimes need your attention. So what is social life? Well, in this Corona time, I think the best way to go is to get some Azure credentials and credits and get on board. Otherwise, digital social life, what would that be? It's, social networks, chat portals, work-related networks, shops, sport engagements, video, online games portals, video portals, news libraries. And again, I'm not gonna discuss and talk about soul searching and dating. But, I've seen a lot of people from different community events that they are definitely interested in that part. Okay, so as you can see, today's topic is going to be more, fun orientated and not really into detailed codes and stuff like that. So, but first of all, I just want to give you a glimpse, an overview. What you really need is an Azure subscription. There's a free trial if you want to get on board. A computer, of course, some scripting programming languages, some social identities like GitHub, Instagram, Amazon, Twitter. Of course, you need a Corona lockdown. Hopefully, we'll get over soon. And disclaimer, all the recipes are small like exemplaries, just to get, learning people on board and stuff like that. Examples are created to bring closer cloud service to everyday life. No GDPR or data had been exposed. Definitely following code of conduct, and everything shown today is available also at the GitHub. Okay, so a couple of words about which services I've used. I've used Function Apps. Function App provides basically endless computing resources. It's serverless and also stateless, integrates with many cloud services like HTTP triggers, code for blob storage, serverless workflows, database response, changes with, different types of databases like Cosmos DB and stuff like that. You can run some scheduled tasks, queue systems, IoT, and of course, those near real-time or real-time data processing. Also supports .NET, Java, JavaScript, PowerShell, Python, in order to create also some custom handlers for Azure services, for Function Apps. And also automated deployment is absolutely great, but this is more like next level in terms of the talk today. I've created also automated deployment using PowerShell and all the scripts that you can basically get down when you're creating the services in Azure. And of course, one great thing about services like Function App is the flexible pricing. The second one is Logic Apps. It's specially service used for scheduling, automating, and orchestration of more like business-oriented tasks. And of course, in my case, also some useless tasks, business processes integration, workflows, especially those enterprise integration, application integration, and stuff like that. Again, serverless. It goes beautifully together with Azure Event Grid and Azure Functions. If you sometimes you need some part of Logic Apps where you can also integrate Azure Functions in order to do some of those little tweaking in order to get the Logic App up and running. It's especially fast for starting. There's a lot of pre-built templates and of course the gallery that can get you on board. And of course, virtual machines, sometimes, you get lazy. It's much easier to just, get a virtual machine instead of writing Function App. But, Functions App are pretty cheap in terms of, in comparison to virtual machines, the blob storage. Of course, all types of databases, my favorite, and not to forget about, continuous integration, DevOps, GitHub, also that. The languages, .NET Core, Python, PowerShell, of course, the Windows machines. If you decide to go with the Linux machines, there are some additional functionalities that you need to install. If you're running it on Linux or Mac, you would definitely need to have the package management and some additional nuggets, of course, Visual Studio and some other stuff. But you can do, regardless of the operating system, you can go with Windows, Linux, Mac OS, no problems at all. So the first recipe for today was, since the Corona lockdown, I wanted to get a Apple tablet. I'm not endorsing this particular brand or this particular retailer, but the idea was that, since the stock was running out extremely fast, I wanted to be the last one to grab this tablet from this particular provider, the vendor. And since it was, only once per day updated, I didn't know when it was updated. I was more annoyed of waiting and stuff like that, and refreshing and hitting F5 every couple of minutes. I've decided to do something about it. So of course I wanted to get not the best price, but I just wanted to get the last stock, and this can be applied to getting the best price or anything. So in this case, what I did was I've created a virtual machine. It can also be Azure function app, anything that can be serverless. I've basically created a Python environment, and of course what I needed in this case was a product, or you can go with a web shop or anything of your desire. Of course, when I started coding this, I was coding on my machine, and then once I turned off the machine, it was the problem because I couldn't have it running up and running. So I decided to that's why I decided to go with a virtual machine. So the couple of steps for the automation: examine the product you want to observe, script the code to get the section of the website that you are interested in, and store or report the results. And this is the third one, was particularly interesting. Okay, so once I went and examined the website, I found the particular CSS or HTML tags that I want to observe. And sorry, everything is in Slovenian language, but it's just a placeholder for this particular tablet. I wanted to examine whether it's going to be on stock soon or not. So basically, I went into that, started writing a Python code. Of course, Beautiful Soup was my favorite, just to get a quick examining. And then once I had that, I could see, okay, they're still not stock, and I could be, hitting refresh every minute on my computer. I was thinking about, okay, so how do I get this reporting back to my, either to my mobile phone or to my computer, to my email, to SMS, whatever. So I was thinking, okay, I can go with Azure Database and then start, refreshing website, exposing it through the API or something. I can write a serverless function. But then I decided, okay, let's try Telegram. Telegram has an open API that you can basically just code. It's available also on Python. The only thing that you need basically is your mobile number, and you register, and that's it. So it's very similar to Viber, WhatsApp, stuff like that. So again, the automation process, the first two parts were checked, and I was stuck with the last one. So I decided to go with the Telegram. So the Telegram itself, basically you don't need to run literally anything. You just register and that's it. And of course, there was also a Python script, Python package available for Telegram for your, doing the nerdy stuff and doing the coding. Okay, so as I said, in this case, it was late in the evening, and I was quite agitated because I couldn't get my hands on that tablet. So I decided the fastest way was just to get a virtual machine up and running. in this case, the cheapest version with Windows, because I'm more into Windows than Linux, but I still love Linux. It was much faster. So I basically just set up the virtual machine. And then the question was, should I expose it and use also SQL Server database, where I would basically just scrape the web and put the stock for this particular product or some prices in the database. But then I said, no, I'd rather go with the Telegram. So setting up Telegram was pretty straightforward. What I did was I basically just downloaded Telegram for Windows and just hooked Telegram with my phone, get the bot up and running, and some additional Python coding. So there is this telegram.ext that you basically need to pip install, and using beautiful soup, I was up and running in no time. Once that was fixed, I just ran this scheduled job. Basically, it was running on my virtual machine, and it still is running literally on my virtual machine. And it was, scheduled to go to that particular website every minute or so, and then start returning me the results on my mobile phone. So this is my mobile phone, print screen from my iPhone actually, and again, everything is in Slovene, but nevertheless, you can see I was setting up timers for 60 seconds, 120 seconds, and at the beginning, I was quite thrilled, that the product is still not available, it's not on stock, but then it turned out that, getting a message every minute, especially when it's not successful in terms of, being on stock or not. So then later I decided to set it for every hour. And then I decided, well, should I basically just reverse the logic and go ping me the first moment when you get it on stock. So literally I recoded everything and started, the other way around. So basically the system was pinging that website every minute in order to see if it's on stock or not. And once it was on stock, I basically got a message. Just side note, disclaimer, this was running for like 2 or 3 weeks. And I thought literally that, the service wasn't working. And then, after 2 or so weeks, I basically logged on to my virtual machine and the thing was still running. The problem was that my local retailer still hadn't got the tablet on stock. So literally in like 3 weeks or so, the thing actually responded and I was back to shop and order it. So I got my tablet. So this was more like, an experience, not how to get the best prices, but literally how to get this communication from the website or from, it can be a web shop, it can be anything else, back to your phone. And this was amazing because, sometimes you just want to, close a computer, but your phone, basically, you go everywhere with your phone. So the recipe number 2 was, let's create a Twitter profile and tweet again tweets that nobody really wants, or useless tweets. So in this case, idea was, okay, let's try something new. Let's try word of the day, quote of the day, maybe the current weather for my hometown or current time. I was still pondering this idea, what would be the best way. And in this case, of course, you need a Azure subscription, some engine, like Logic Apps would be, the fastest, but, you can go also with Azure Functions. And also some database, some persistent storage where you can, if you in case want to store, some results, that would be also possible. So what I did, I've created a Twitter account. With this particular Twitter account, I had to have also development account authorized, which means that you can then access to some APIs to get hold of the tweets read the tweets, search for particular hashtags or stuff like that, or even post the tweets. I've created logic apps. Logic apps are, in this case, relatively straightforward, and of course, access to SQL database or Azure storage for storing some extra content. So the idea of my automation was, given a period, I want to do a tweet, or I want to tweet something, or following that condition, a particular condition, do something, tweet something, and then of course repeat, and after some time, basically forget about the account, which really happened to me. I forgot the password, which I can sure get it back, but still. And I've created logic apps. The logic app itself is set to basically do the recurrence and then get the current time. So for those who don't understand, the name of that logic app is called, literally translated in English would be accurate time. So the idea was to basically mimic the church bells in my hometown, Ljubljana, Slovenia, how many times they do dong at a full hour. So literally this is where all the idea came. So I said, okay, let's go with logic apps. I've created recurrence and then get the current time. And based on the current time, if it's not the full time, don't do anything. At the full time, count what time it is. If it's 5 p.m., then do 5 dongs. If it's midnight, then don't do anything. And then the condition, of course, based on the condition, because the church bells don't basically dong during the night. They start around 6 or 7 in the morning and they go all the way until 8 in the evening, and that's it. So basically the idea was to create a condition that would basically do just that. In the meantime, I also wanted to pimp up my logic app in terms of, if it's a public holiday, also give, some sort of greeting, or if it's a, an important date, do also something. So in this case, you can see that there is also execute SQL query that basically goes to SQL database and get all the public holidays. And also the idea was to get some, some extra weather events, if it's going like today, going to be full snow, or if it's going to be, full of rain, do something like that. At the end, I've decided also, I've basically created this. I've also then decided just to go with the dongs. But, the, again, useless idea is to, to learn and to connect those services. And this is basically how the logic app then was working, and the trigger. And you can see that when I was preparing this session, it was 24th of November, and apparently I wanted to go into my logic apps, of course not knowing my password, and apparently it failed a couple of times. Again, this is my Twitter account. I wanted to be sneaky and just, have it running. It was basically in the first Corona wave. I basically created this again, probably out of, boredom or something. And in meantime, I've managed to get 0 followers. So yeah, hooray. Anyways, the idea was, to have it, up and running. And you can see there was like more than 2,300 tweets, a couple of days ago. And the picture is the central church in my hometown. So, there's no fake to that. But the problem was, when I was digging into each of the tweets, there is, every time something is tweeted, you can see that there is Microsoft Azure logic apps in the background. So this was then something that I didn't know how to remove, and I just left it there. I'm going to quickly switch to this account, and you can see that again this is up and running. And if I click on a particular tweet, you can see it still says, it's running Microsoft Azure, or it's rocking Microsoft Azure Logic Apps. Anyways, this was quite fun. It's still there, up and running, and I still haven't. I actually had one follower. I'm quite proud of that, but ever since. The third one was, let's go and try something with Instagram. I've seen a lot of people, as I said, doing some cats, dogs, wine, stuff like that, and it's getting extremely popular. And since I'm a avid coffee drinker and coffee lover, I said, okay, let's go and do a coffee lover, SI stands for Slovenia, account, and let's try to, automate it. So basically, I've created a coffee lover account, and from there on, I decided whether I want to go with virtual machine or if I want to go with the function app. I definitely needed a blob storage to store my photos. Then some functions, either to connect to virtual machine or to connect to this blob storage. At that time, I didn't know how to do it. And then, of course, some Python, because I was, also exploring Python with Instagram years ago. And then I said, okay, let's do Python, of course. Back then, I used Selenium, which is a Python package. But I've seen just recently it's InstaPy package, basically a package particular for Instagram, and it basically does the same as it did Selenium. Of course, you need Instagram account and phone. So the idea behind this automation process was, okay, let's make some photos. So on a daily basis, I'm making quite a lot of photos, but in this case, coffee-related photos. And have those photos synced with my Azure Blob Storage. And then periodically, I said, okay, let's do it on a daily basis, select a particular photo, and that basically you store on your phone that goes directly to the Blob Storage, and then push it to the Instagram account and post it with some hashtags. I managed to find the hashtag generator. It's called, if you Google Instagram hashtag AI as a artificial intelligence, you can basically get there and find the best hashtags for your particular idea. So what I did was, and this is the print screen from my Azure storage, where you can see that the photos actually, I've somehow managed to get those photos. I was thinking, how to name the photos that I can basically script. And I've seen there's a timestamp, which then I basically converted to just date time, because I'm posting photos on a daily basis. So I'm not doing it on hourly or so basis. Daily, I said it's fine. So the idea, and probably the hardest part was to get my phone connected to my blob storage. And again, Azure Functions and some .NET scripting to get my SQL Server base connected to my phone, and then it stores the photo itself on the blob storage. The function was then basically, again, this is just a test script that does basically that. You can see there is a lot of namespaces involved in this, from Xamarin to Poly, stuff like that. Everything automated. And again, this was the hardest part in this case. Everything else was more like, piece of cake. And in this case, some .NET coding was quite thrilling. And then the last part I needed was just to have a lot of materials, a lot of photos. I have, before the lockdown, I've calculated the amount of coffee I need in worst case scenario if we are in Slovenia lockdown until March or April, because I'm drinking a particular brand of coffee that is not available in Slovenia, and I usually drive to Italy to get it. So this was, my calculation, and so you can imagine, I have a lot of coffee, a lot of photos, and that's it. So once I have this, The only thing I need to do then is so make a photo with my phone, store it, and then the Azure function basically connects to my phone, gets the data and put it there. And then on the other hand is I have the Python that basically access the blob storage and put it on my Instagram account. How then at the end does this look? I have basically the coffee here. As you can see, this has been up and running for like 10 days or so, and I've managed to get 4 followers, but I'm literally just following, you know, those high-end brands of coffee makers. And for each, basically, I am getting the hashtags from this site. I was also thinking maybe I can do in next step, maybe I can do some image recognition in order to say, okay, this is the portafilter, get some portafilters hashtags from that website and posted it here. So again, I'm still thinking, pondering how to do that, but this is, you know, the next step, how to improve that. And this turned out quite interesting, I have to say. The fourth recipe is, again, how to get or how to be the first at buying the real estate or getting the best deals. This is, again, something from a Slovenian website that basically states all the infrastructure, all the real estates, from the apartments to houses to lands where you can buy something. In particular, in this case, I was just, you know, pondering how to get things done. And immediately, once you go to this website, you can see there's this URL that has a particular names where you can easily access, and then using some script, you know, decode it, and that's it. So in this case, Azure Logic Apps, again, both are stateless. It's stateless and serverless, which means that you need to get the idea how to, you know, manage not to send if there is a new ad and you've already seen it, or the Logic Apps has already seen it. You need to know, you know, when was the last time you've accessed it. And then, of course, the return information. So in this case, this was, you know, back. What I did was I actually was just sending SMS. If I would be redoing this today, I would definitely use the Telegram. So the idea for the automation, given an interval, check for the content and send alert if something is available. So back then, again, Logic Apps, as I said, it's a beautiful HTTP trigger executing some JavaScript code. So again, you can use Python. And then this was the Plivo. Plivo was back then relatively cheap in order to, you know, get some, you know, quota of short messages, and that's it. So I've basically connected, and every time something has happened, you know, this is pretty much straightforward. Again, JavaScript is stateless and serverless. So the only thing I had to figure out how to run this continuous enumeration through time was, you know, given a period of time, you know, check how many times have basically passed since the last run, and then do something with it. Okay, the last recipe, sending text when your contact has birthdays. So again, never forget and always send. So it's just, you know, not to forget about your friends. So again, Logic Apps tended to be the best way. Again, with Plivo, but this was, again, a couple of years back. The idea basically has slightly changed now that, you know, mobile phones had basically become quite powerful. I've since ever then used Scriptable, which has nothing to do with Azure, and I'm not, you know, endorsing the product itself. But the idea with the first process was I wasn't really checking on the language if a person or if my contact was from Austria or from from let's say England, that you would know how to switch the language, or if somebody was from the other side of the world, to get the right time zone. So with this JavaScript scriptable, which is an app available on iPhone, you can basically automate that as well. So check for the language, check for the time zone, and send some quote unquote personalized short messages. So the idea is also that you can get a widget where you can see, how many how many days until a person has a birthday. And again, sending, SMS with happy birthday wishes, it always sort of like gives you a warming feeling when you get it. To conclude, the cost per recipe and estimates. So the first virtual machine, so the first recipe, it costs around roughly 30 euros per month to run. Again, you can, recode everything or reverse everything and get it done much cheaper. The second recipe, it basically, because it's running 8 times per day, so this is the tweeter with the current time for 31 days. That's approximately 31 days per month. It costs around $50 basically per month. The third recipe, again, if I'm taking virtual machine, it's again 30 euros per month. Or I can recode everything using function apps and the storage. The storage is relatively cheap, but there is a beautiful part about Azure is that you get up to 1 million executions for free. So it really is no-brainer. And recipe 4 was, again, logic apps, 100 times per day. Again, extremely cheap. Plus using all those Telegram messengers, which is for free for now, and also Twitter and Instagram, which is free unless you're either using business profiles. All in all, for startups, small to medium or big businesses or enterprises, something of this small can definitely give you a better digital recognition and, for extremely low costs. How to save on costs, especially if you are, running a lot of virtual machines, stuff like that, go serverless, use function apps, and apply the rules. Of course, virtual machines are more comfortable, especially if you're lazy or if you're programming at, midnight and then you don't really feel like coding too much. Virtual machine is quite there, easy to use. But, it comes with additional costs. Work in progress or further ideas. Definitely, entering competition, winning swag or winning prizes. This is definitely something worth doing. Usually in December, it's time of, a lot of companies are doing, a lot of competitions. Yeah, you can easily do, Azure function app or something, and then, do the reporting back. The one that I find most interesting and thrilling is, of course, if you're coming from a big enterprise, hiring people is always a problem. How to do it, either go, there's, applications like Meetup or GitHub. GitHub Archive is extremely powerful and beautiful. LinkedIn endorsements, stuff like that. So what you can do is actually, get all the interesting information, especially if you're searching for people that, on LinkedIn, through endorsements, you can find a particular programming language or particular skill that you are interested in and get people basically in contact and then start engaging in conversation. On the other hand, GitHub Archive is also a powerful search engine that basically goes through the whole GitHub, goes through location, goes through all these tags for the languages or repositories, and you can definitely find interesting people there. And also Meetup, I also use Meetup for, community events, stuff like that. So sometimes, you just, maybe you've met somebody, maybe you haven't, but, you can also expose that and go that in sort of like a semi-automated style. We've covered short messages. The first one, turning on coffee machine after alarm goes off on your mobile phone, definitely doable. Just requires a Raspberry Pi or some, tiny machine computer, and then you're off to go. The key takeaways, it's absolutely easy to learn Azure services. Of course, love to learn the coding. Spend some time with different services definitely will give you a much better overview of what can be done. Simplify, boost your digital social life or online social life. I'm not really into the gaming or, those chat bots, Discord, Twitch, but, definitely doable also there. Have Azure basically to help you with your daily tasks. Don't forget to go outside, explore the nature as well. I am definitely fond of scripting everything. Don't forget to store username, passwords in software or key vaults that are specially designed for that. I am very famous for forgetting the username or the passwords. And that's about it. And the last funny part was I've managed over 2 years to get a Twitter account up and running and having 500 followers, which was quite interesting, with hundreds of tweets or so. And I've decided to sell it just to see if there is a area in Slovenia to sell a Twitter account. And after posting an ad on a Slovenian website where you can sell literally anything, I failed to sell a Twitter account. I don't even know if this is there's an area or a market for that, but I'm curious. Thanks. And if you want to get in touch, please do so.
Wow, Thomas, what a wild tour of technologies and how you've applied them to basically automate your social life. So a question I have from my side. You've kind of shown some recipes in doing this with your personal life, how you can automate things. What are kind of the things that people can take away from this and maybe in automating some professional services or tasks?
I would definitely go if you're into programming or scripting, any type of, let's say, websites or developing software, stuff like that. You can script a lot of stuff like that as well. So RPA, robot processing automation, is something that, for instance, when you are, let's say, writing a let's say you're coding a web shop and you have a couple of those unit tests that you want to run through and see, what happens if when I'm coding, if I put a product in my basket, what happens? Those type of processes can be easily automated. So instead of you writing every time, putting a product in the basket every time, you can basically script that. You can use Selenium, you can use Python, you can use PowerShell, it's also extremely powerful for that. You can go online, you can use Azure Function as well. So, this would definitely for enterprises be a typical, case. Another one would be, finding the best prices. This is what I've covered in the first place. So. Yeah. But there are many cases where you can, not to mention if I go to, let's say, Google APIs, there's huge variety of APIs available that you can use for automating a particular business process. So yeah, the list goes on and on.
Yeah, indeed. Well, I think this is a huge call out to automate whatever you can. As much as possible. So once again, thanks a lot for your great session, Thomas, and hope to see you again next time.
Thank you.
So Stacey, what's coming up next?
Coming up next, we've got Glenn Colbert. If I've said his name right, I'm so sorry, Glenn, if I didn't. Who's going to be talking about Azure Digital Twins. And we live in a world of IoT these days. I can't remember the last time I bought a gadget which wasn't connected. And with more and more devices being connected in some kind of way, it's interesting to see what you can get out of them. And Azure Digital Twins is the new kid on the block and allowing customers to create rich models of the real world inside their digital world. Sounds awesome. Glenn's going to talk to us about that today. Glenn is a co-founder and CTO of Azure in Belgium, Microsoft MVP since 2012, and currently focused on designing and building secure, scalable, cloud-based solutions. I also happen to know that Glenn really loves Lego and is possibly the reason why I've got a couple of models in my collection. So Glenn, are you there? How are you?
Good evening. Yeah, I plead guilty on the Lego part. So I have to admit I've took up playing with Lego again during the entire lockdown. So yeah, I plead guilty on that one.
It's a fantastic hobby to have.
And it's perfect excuse to buy Legos for the kids, right?
Absolutely. It's all for my son. None of it's for me. It's all for him. Okay, so Glenn, take it away.
All right. Thank you. Let me... So, as already said, I'm going to guide you today through the magical world of Azure Digital Twins. Due to the time, let's go over the intro slides a bit quicker. As I said, I'm Glenn. I'm an Azure MVP, also Microsoft certified trainer. You can find me on Twitter where I tweet about IoT and Lego. And the code I will be demonstrating today, or the code that used today during the demos, are available on my GitHub account. So definitely take a look out there to see what's happening. Azure has been something quick about Azure. Azure is focusing on everything platform as a service. We have 4 Azure MVPs in total. And since this year, we have an office in Ghent, Belgium. And also our main headquarters are in Helsinki, Finland. So, but let's quickly jump into the main topic of this evening. Yes, let's talk a bit on IoT. So IoT, if you follow or seen the presentations, it's about getting those things connected, creating insights and actions upon that. But we've seen today that the focus on connecting things, connecting your assets is that focus on that area is a bit of moving away. So there's a new trend within IoT solutions and the IoT landscape emerging, where customers really are moving beyond just connecting their assets. They really want to connect their entire environments. They want to connect their offices. In some cases, people are doing quite some interesting things with getting their home office connected. So we're really starting to move from a connected assets environment to a more connected environment and a connected environment area. And we can see that things will definitely start to move towards a more connected ecosystem where environments start to interconnect and so on. So what we're seeing is that customers and IoT solutions are starting. Customers want to model their environment first. So they want to model out their home office, want to model out their factory floor, and then take that model, take a digital copy of it, and keep that model up to date with IoT data, use that model to do some simulations on it, and some other automated processes on those models. And this is where Azure Digital Twins comes into play. So if I'm not mistaken, the service is still in preview. It should be GA anytime right now. I think it was announced at Ignite that it would go GA somewhere end of November, beginning of December. So we're anxiously waiting about that. And Azure Digital Twins is about creating the next generation of IoT solutions. So it's focusing on modeling your environment by providing you a open modeling language. But I will come back definitely more on that later. It gives you a live execution environment to basically see the model alive, keep that model alive with some live data. You can input data onto the digital twins from different IoT systems, from business systems, and you can connect output systems. You can connect to time series insights. You can output data to storage or to an analytics layer, allowing you to further process or analyze that data that has been living inside your digital twin. So for people that already, so the digital twin currently in preview is actually a second generation. For people that already played with the first version, you will see some significant changes. First of all, in scaling capabilities, also the more flexible way of ingesting data or extracting data from it, and it's, as already said, it's based more upon open standards than the first version. So let's take a peek at each of those different topics and to set the scene for the demo later on. So it all starts. Your digital twin or creating your digital twin all starts with the open modeling language. And the open modeling language, the digital twin definition language, that's a whole mouthful. It's completely aligned with already existing services onto the Azure IoT platform. It's aligned with IoT plug and play and aligned with the time series insight data model. So the digital twin definition language is based on JSON LD, and it describes your twin, or you can describe your twin via different properties. So a property is a data field that is living on the twin. It has storage. So it's basically a state of your digital twin. Then you have the telemetry. The telemetry is measurements. Those can be events from sensor readings or any other event happening inside your digital twin. The main difference with properties here is that the telemetry is not stored on the digital twin itself. It is just a series of data that is flowing through your system. The next part you can use to describe your twin is a component. And a component allows you to build, let us say, you can see that as a sort of interface. For example, if you're describing a smartphone with your open modeling language, you could define a camera as a component, and then use that camera component to model out your front camera or your back camera. And that's the way how you should see the component. And then maybe the most important thing is the relationships. And relationships allow you to define how your digital twin is interacting with another twin. I will definitely come back to that later, because that is really a key component of of digital twins. So to come back to the mobile phone example, you would have a mobile phone digital twin, and you have a front and a back camera as a component, and then you could say in the relationship that your mobile phone has a relationship with those two cameras. So that's a bit on how that works. Once you have described your digital twin, you can create a graph via those relationships and really show a visualizations of your digital twin and how that twin is working together. So once you model that out, everything basically goes through the live execution environment. So inside your live execution environment, you can create twin instances based on the models you defined. Those twins instances are connected via through relationships and form a graph of your environment. Currently, it is not possible through the Azure portal to visualize your digital twin, but Microsoft has open sourced a tool called the Azure Digital Twin Explorer, the Azure Digital Twin Explorer. And with that tool, you have the possibility to visualize basically everything what is happening within your digital twin. The live execution environment allows you to work with events or process additional data through external compute. So for people that were working with the original version of digital twins, you notice that the compute was inside the digital twin environment. So with V2, the compute has been extracted from the digital twin environment, and you can basically bring your own compute. For example, you can use functions to do some data processing or to process the events from the digital twin. So it's really more based on eventing and data processing through external compute than really doing all the internal processing on the twin itself. To communicate or to interact with the digital twin environment, you have to communicate through an API. So everything you do with the digital twin environment is done through an API. So if you want to query data, you need to call the API. If you want to create twin instances or upload a model towards the environment, you need to do that through the API. There is, of course, an SDK available that allows you to, that basically is a wrapper around that API. But in a very basic statement, the digital twin service is just a set of APIs made available for you to model out your environment. Inputting data is done through IoT Hub, or it can come from any other data sources that you would like to update your digital twin with. Again, updating data or putting data inside digital twins is done through the API or with the SDK, and it's just a matter of taking some compute and then hooking it up, and there is data flowing inside your system. Then there's the whole storage and analytics. So it's basically now we have defined our twin, we have modeled it out, we have some data being ingested and some data flowing through the system. So that's an important one. And then you can output data to other sources. You can route that via event hubs, event grid, or service bus. And those routes and endpoints basically open up a whole range of new scenarios, allowing you to store your digital twin data in a data lake. You can connect it to logic apps to automate some stuff. In the previous sessions, we saw that to automate your social media, if you want to have some data from your digital twin, output it to your social media, you can use the logic apps from the previous session, and then put some data from your digital twins out there in your logic apps. You can connect digital twins with time series insights, and to have that historical view of your data. So that was a very quick walkthrough on all the capabilities of digital twins. And I think it would be best to just show you an end-to-end demo on how digital twin works, how you can create your digital twins, so you can really have a good understanding, or you have a basic understanding on how you can create those digital twins and what the use cases are. So this is the setup that I will be showing you tonight. So it is always tricky with live demos, but I'm pretty confident this thing will work out. So what we first, let's give a high-level overview here. So first of all, what we will do is we model out our digital twins. We will upload those models in Azure Digital Twin itself. And once we have our models there, we will start creating our digital twins and create our relationships, but more on that later. So once we have that model running, we have created our relationships. What we will do is I will use a set of simulated devices that are connected through IoT Hub, and through the external compute through functions, I will update the digital twin and basically update all the running instances of my digital twin. As a last one, what I will show you is how you can extract data that is flowing through digital twins. And I will show you how you can create a route that is connected to time series insights, where you will be able to see data flowing through the entire system. So what we will do is, let me open up Visual Studio, and I hope this is visible. So what, as already said, what we will do is we will start, before you can create any digital twin or any relationship inside the live environment, you need a model. Sorry for that. You need a model. In this case, for my demo, I've modeled out my house. So in the end of the demo, you should see a visual demo of my house. So how does this twin definition language, how does this modeling language work? So this is an example of how this is constructed. So let's take let's take a quick peek on how that looks like. The first important thing that you need to specify is the ID. So the ID consists of DTMI. It has to contain a domain, a model identifier, and then a version. So this is just to give your model a certain ID. Then you give it a friendly name, and both this type and this context are fixed values for digital twins and just have to be there for the digital twin API to understand what you're doing. All remaining interface data or data to describe your twin is found within the content array. Here, to define my house, I've added two properties, one with the construction year and one with the owner name, with the owner. Both are string types. So remember, properties are fixed values. These are stored on the twin itself and remain there. And then the important thing here is the relationship. And with defining that relationship, you basically define on your model that this interface has or can have a relationship with a target, which is the again, just specifying another ID. I will in a minute show you all this ID. It has to have a target and a name. We will come back to that name later. So my house has a target or a relationships with floor. So let's open up the floor. Here again, same approach. You have to give it an ID, give it a friendly name, and then the remaining interface data is within the contents array. On my floor, I did not specify any additional values. I just said my floor has a relationship with rooms. So if you can visualize a bit what we're doing, so I have a house. My house has different floors, and on my floors there is a relationship with rooms. So let's take a look on how a room looks like. So again, here it has an ID, it has a display name. Again, I've specified two properties. As you can see here, you will probably wondering, okay, Glenn, those look like measurements to me because they're temperature and humidity. Yes, absolutely correct. But what I wanted to do in this demo is with eventing, what I will do is I will update my digital twin with data coming from IoT Hub and store that value onto the digital twin in these properties. So my room, again, has those two properties that I will update through external events and has a relationships with my sensors that I will deploy in my room. If I take a look here, if I go to the sensors, you will see here the sensors. My sensors have a firmware version and then has the two telemetry values coming in. So what I will do in the demo here is I will upload those models. I think those already uploaded. Let me take a quick look. So yes, let me first show you the Azure Digital Twin inside the Azure portal. So when you provision Azure Digital Twin, you basically get a service like that. And the most important thing for you is the host name. And the host name is where your APIs will be hosted, allowing you to interact with. So we've created our models, and to gain some time during this demo, I already pre-uploaded those models to my digital twins. What you're seeing here is the Azure Digital Twin Explorer. And as already mentioned, this is the open source tool from Microsoft. It's available on GitHub. You can just download it, build it on your local machine and run it, connect it with your instance, and it allows you to really have some good visualization. So as you can see here, these models are available. I've uploaded them. If I click here, those should come up. You see here, these models are here. My house model is there. My room model is there, and so on and so on. So you can see that these models are available here. So I will just run this query to show you that currently we don't have anything within our digital twin. We only have the models defined. So how do you now create your digital twin? Create your digital twins based on the models. So as already said, how you interact with the digital twin environment is through APIs or through the SDK. So what I will show you is how to interact with the SDK and how that works. So where are we in our demo? So we have our digital twin definition language, and we've uploaded them to digital twins. So now what we will do is we will create our graph within our digital twin and through the SDK. Let's jump back to Visual Studio. Let's close this one up. So let's open this one. So how you interact with digital twins through the SDK by using the azure.digitaltwins.core NuGet package. And what you can do there is create a digital twin client. And the digital twin client is just an endpoint that you need to provide. That endpoint is your digital twin instance, and you need to provide an Azure Active Directory token. With those two combined, you have a digital twin client allowing you to interact with the Azure Digital Twin. So, and here comes the way on how you can build up those digital twins. So first of all, you need to specify some metadata. So what are you creating? So what model are you using? So in our case, I am using my house, and the kind here is digital twin. That's again a fixed value that is needed for the underlying API to know what's going on. So you take that metadata and add it to a new dictionary or a new JSON object. But together with that metadata, you add the properties that you defined on your model. So if we take a quick peek on our house, remember here we have construction year and owner in our while creating an instance of our model. You can see here that we have construction year and owner. And what you then do is you use the digital twin client and you say create digital twin async. You give your digital twin a certain ID, and you pass in the twin data you have created here. So in that way, what we will have in our graph, we will have a digital twin called house based on the house model with the two properties we have provided here. And basically, this is the same you can do, for example, let me show you the floors. Again, you need to specify the metadata. So let's not do that. So this is using the floor model, again, digital twin. Remember on our floor, what we had, we didn't have any properties there. We only had a relationship. So we are not specifying any other value than our metadata. Based on that, we basically create 3 different digital twins, 1 floor, 2 floors, and 3 floors. Each of those twins will represent an instance based on the floor model, but with a different ID. So now we have our house with 3 floors. And this is basically how you model out the entire structure. Here I've created a kitchen, a living room, some bedrooms, and so on. Then I've also created the sensors. In this case, we have 5 sensors and so on. But then the most important or the most interesting part starts. So we now have created digital twins based on our models. So we have our house, our different floors, our rooms, and our sensors. What we will now do is create relationships between those digital twins, allowing you to create that graph of your house, of a house or of your environment. Again, how you do that is you create a dictionary with some metadata in there. So you need to specify a target ID. Remember, this is the target ID of the digital twin you created. And relationship name is the relationship name of the relationship you defined in your model. Remember, on our house, we had a relationship floors, allowing you to target a certain floor. And you see that coming back in the code. So our relationship name is floor, and we're targeting, in this case, floor 1. So what we're doing then is create a relationship async. We give it the digital twin ID, give the relationship a certain ID, and then pass in the value. And this is how you create the relationships between those digital twins. So let me close that up. Let's not save that and hit the run button. And let's see what comes out of this creation. So what we will do is I will call here the setup digital twin. And what it will do, it will just call the code I've just walked you through. And it will create the digital twins and create the relationships. So as said during the start of this session, this code is available on GitHub if you want to take a peek. Go ahead, take a look at it. If you want to improve, or if you notice that some things have been horribly coded, I'm very happy to accept some pull requests. So let's hit setup digital twins. It's going. Important, I need to authorize first. Let's click this. Let's close this down. And if all goes well, you should see some things being created. I see that there's some error over there. Let's take a look on what happened. Let's okay, this an expected error where I'm trying to re-upload my model again, but the models, I already prepared those. So that should be an expected error. As you can see, we have a log file here saying our house was created, our different floors, our different rooms, our different sensors have been added. Those relationships have been mapped out, and my digital twin has been signed off. So let's close this window down. And go back to our digital twin explorer. If all goes well, let's take a look and hit run query. And as you can see here, this is now the digital model that's available in digital twins based on the things we've created. you will probably notice here that I've connected this sensor to both my kitchen and my living room. This is just a way of demonstrating you there is no need to have just one-on-one mappings, but you can definitely map that digital twin out as you wish. So now that we have everything available here, let's start shooting in some data inside our digital twins. And as already said, digital twin is a set of APIs, and how you interact with it is through those APIs or through the SDKs. Therefore, you need to hook up external compute to ingest the data inside digital twins. In our case, we will be using Azure Functions. So let's jump to IoT Hub, if all goes well. We have IoT Hub. What I've created is a set of devices. You noticed here that I've deliberately named the devices after the device of the idea of my digital twins, just for the ease of having a more easier setup on this demo. So how do you now extract data that is entering IoT Hub? How you ingest this into to digital twins? You can use this by leveraging the event grid capabilities of IoT Hub. In this case, I've created an event grid subscription that filters on device telemetry. So every time there is a device telemetry available on our IoT Hub, an event will be raised. Excuse me. An event will be raised, and that event will flow onto event grid and will be picked up by my Azure Function endpoint and will process the IoT Hub messages. So you can ingest data from IoT Hub through digital twins by using this event capabilities. Unfortunately, there is no direct route from IoT Hub towards digital twins for the moment. So, yeah, it would be nice to see that better together story here showing up, but leveraging this through event grids with Azure Functions is also a perfect solution. But it would be nice to have that route to digital twin here as a first-class citizen. But with this, works perfectly fine. So we have our event grid subscription here, and we have our Azure Function, and that Azure Function is just a basic setup. What it will do, it will listen on event grid, and then it will filter out the data. And here with, let me jump in this code. What it will do here, it will use, again, the digital twin client, update the digital twin async, passing the twin ID. In our case, it will update the sensors. Therefore, I've used it with the same name, and it will pass the value of the measurements here. So let's hook up, or let's start the simulator. So this simulator is now starting to transmit data into IoT Hub. Remember, IoT Hub, when there's device telemetry popping up, we will process the message and the Azure Functions will use the SDK to update the digital twin. If we go to digital twin and take a look at our sensors, you see here that the temperature and humidity has been updated. You can see here that we now see live data flowing through the system. So now we're using the live data to keep that twin up to date and to process data within the digital twin. Another capabilities of digital twins is, as already mentioned, let's go back to the overview so that we don't lose the overview here. So we have our simulated devices through IoT Hub with functions updating the data in digital twins. What we now want to do is we have our live execution environment being updated by our Azure Functions. So what we want to do is now hook up some external processing tool or an external compute or something else. In this demo, I've hooked up time series insights. How we will do that is by defining a route on the digital twin towards event hubs and then connect time series insight with event hubs. But let's take a peek on how that works. I'm just looking at the time, so let's go a bit quicker. So you can create an endpoint on your digital twins. So for people that are familiar with IoT Hub, it's the same principle. Here you can create an endpoint to Event Grid, Event Hub of Service Bus, and then give it a name. Then you can use event routes that will use the endpoint. In our case, we will here use this one. So every time a twin gets an update, so remember we're updating the twin through functions, updating the telemetry of it. So every time that twin gets updated, event is raised onto event hubs and a message will be available there. So, and if all goes well, that event hub should already have some data of my simulator. And if I go to time series insights, come on. If I look at time series insights, you would see here that I will see some data flowing through the system right now. So this is live data coming from my digital twins being shown in time series insights. So this is an end-to-end functionality on how you can use digital twins and how you can leverage the different capabilities of extending your digital twins with external compute, bringing your data inside digital twins, and so on. So let's jump to the conclusion. So digital twins is there to build those next generation IoT solutions, moving away from just having your assets connected. It's built around the ability to model your environment, and it's really an event-driven approach. Remember, the most important way on how to interact with the platform is through APIs or through the SDK. So at the moment, there is no real tangible things inside the Azure portal, but if you want to visualize your digital twins, you can use the Digital Twin Explorer, which is available on GitHub as open source. So with that said, I see I've ran a bit over time. Excuse me for that. If you have questions, do not hesitate to reach out or through Twitter or through any other social media channel. Thanks for attending. You can find the source code on my GitHub account. So thanks everyone for attending. Enjoy the rest of the community day. Thank you.
Thank you very much for that awesome session. That was, again, there was a whole lot of stuff that you managed to get through in that time there. Unfortunately, we don't have time for the question that we do have. But as Glenn said, if you need to get in contact with him, go via Twitter. And yeah, thank you very much for joining us this evening.
Thank you. See you.
Bye-bye.
Thanks, Glenn.
So, our last session as hosts. Sniff, sniff.
Yes, indeed, Stacey.
Who do we have coming up?
Well, coming up next is Ebru Kuchen, and she's a principal consultant at Contino. And next to being also a trainer, a book reviewer, lots of other things, she's also the co-organizer of PowerShell London, which is great to see. So in your session, you'll be talking about policies. BDD, so behavior-driven development on policies. For me, policies as a developer, that's typically something that comes in when stuff goes wrong. When you notice I should have had a policy to kind of control myself. And I think that's the case for many people, many developers don't only see policies as a need when things go wrong. So yeah, hopefully you can shed some light and make policies more palatable, more digestible for other people. And so looking very much forward to your session on applying BDD on policies. I think we can't hear you. Ebru, can you check if you're still on mute? Yeah.
Nope.
All right. Ebru, you should be fine. Could you speak up again? Hello, Ebru, can you hear us?
Always a fun with technology when you're doing a live session.
So we'll be sitting here until everything works. So that gives us a couple more minutes together, Stacey.
Absolutely.
Can you hear me now?
Yes.
Yes.
Hello.
Welcome.
Microphone doesn't work. I'm not sure how the laptop's microphone will work, but
We can hear you fine. So you have the floor.
perfect. Thank you very much. Let's see how the screen share will go. Can you see my screen?
Yes.
Yes.
And now, as well?
Yes, you're good.
Perfect. Thank you. And I'll start with who likes rules and regulations. Where we don't have any input, we can't contribute, we don't understand why they're there in the first place. I started my career about 2 decades ago as a software development department where we had to follow specific processes and controls. I knew it was all good intent and to keep our code base and effort safe. Fast forwarding to today, I'm at the heart of IT department, working with security, networking, and finance teams to put these regulations into place. I'm working at Contino as a consultant where we do the right best practices for the right outcome from the cloud journey and implement the right operational model to allow the engagement from all departments in the business. And today I will tell the story how we changed the mindset of the central IT team of a top investment bank to enable collaboration with application teams. I'm a developer at heart. I'm a lead principal consultant at Contino. I'm vegan for the last 5 years, enjoying the ethical and the environmental impact I have done so far, selfishly. And I have 8-year-old son who enjoys Roblox and PlayStation. And with the COVID, he has more time to enjoy screen time. As a parent, I don't have any comments. So my agenda today is talking about the problems with the security guardrails. with an insight on what happens when a team onboards to cloud and these guardrails, how they are set up. I'll explain how we enable the collaboration between the application teams and the central IT team, which sometimes the blocker bottleneck. It wasn't an easy path, so I will mention the trade-offs we had to make, and maybe it will help you if you are in the process of implementing or revisiting the existing ones. After 15 minutes, I would like you to remember 3 things. First, application teams should also play a role in those controls, as it's not just one team's responsibility. Secondly, BDD is great. If you haven't checked out, it allows the human readable tests to increase the collaboration across multiple teams. And lastly, try small iterations. Don't be afraid and innovate. It's okay not to get it right at the first attempt. So what happens when, on the first day, in the central IT teams, I'll call it control teams, such as networking, security, and finance. They should provide guardrails for the new cloud platform. They need to secure each service, such as storage accounts, key vaults, event hubs. Sorry. The list is endless. A good flow product manager would enable the priority of the items and ask for what features they offer and how these will be enabled, utilized. And the control functions, teams will question the baselining standards if they have any similar services in-house. Classic example is the crypto keys. Sometimes there is no policy, sometimes there are some regulations, either not clear guidance, or for the symmetric keys, for example, or asymmetric ones, they may lack technical consistency or procedural consistency. Sometimes it's worse. There is no guidance of the definition of what's a key or a secret. The definitions can be misleading as well with the cloud's new terminology. It doesn't help the big picture. Another one is the regulations for the non-human actors or service accounts, where their secrets will be stored if they have to have certificates, and what their certificate expiry policy will look like. It may end up in long discussions. There's also naming standards, another example, with the new mindset can be tricky. If you have a cloud already, this is the second cloud, then can you implement the same naming conventions? Should the environment name 3 characters or 2 characters? Does it matter? If you don't get the right or agreed decision, you may be just redeploying the whole infrastructure after a couple of months in the line, and everything becomes immutable. It's okay to redeploy. It's just another iteration of the policies, not in the place, not agreed or contributed from multiple teams. And the next logical thing some organizations do is their desire to lift and shift the existing standards to the cloud. We didn't let them, application teams, to modify their secrets for years. They shouldn't renew their certificates. So some of the regulations could continue without a notice. With the number of the features the cloud provides increasing, the cloud journey becomes journey to Everest, if not to the moon. And when the teams admit the traditional controls do not fit, the response we get from senior leader management is sad someone. Then following weeks that are usually spent reading the online documentation, training for fundamentals. Now we have more questions on bringing our key policies, sign URLs, retention policies. Either they are called SDDs, the service definition documents, or TechEvals, technical evaluations with hundreds of pages of documentation to be prepared, reviewed, to create a holistic view of the products of the cloud. A good approach here is to execute well-organized workshops. I'm hoping also there are people with good cat-herding skills to keep the focus on these meetings. Otherwise, you may find yourself in circular conversations. With the SMEs or technical advisory boards, the tactical and the strategic decisions, they need to be prepared, documented, ready to be implemented. Are they the right ones? When all the hard work goes in, the core platform engineering team submits their last PR, publish it, and the product teams can be surprised, if not frustrated, with what cloud they will consume. Rather than enabling the innovation and the freedom, it may give them limited area to publish their applications to. If the decisions are on behalf of the users who will consume the platform, the ship left never happens. And it's a recipe for disaster, disappointment, or should I say, to get the right outcome, application teams should be part of these discussions. And I believe this is where the cloud journey derails or gets success. So to get it right, what we should be doing and how we get it right, how we enable the collaboration between the central IT team and the application teams. First, we invited the application teams to these workshops. Make sure that they are part of the journey from day one. Then we created policy pyramids, where we share the responsibility across the whole platform with clear roles. The baseline policies are the ones for everyone on board to the platform. They are global and applied at the root management level. So they provide assurance to everyone. Second layer is about the shared policies for the services that can be consumed by multiple teams. And at the top level, we have application-specific policies, which enables rules and regulations. By organizing policies like this, gives the control teams to focus on what they care about and not to be the bottleneck for others. A good example is regions that they are going to be used. What type of tagging policies are going to be consumed or integrated with other systems? And maybe which resources are going to be allowed across the platform. And application teams can have a voice and freedom in their use case on shared policies and application policies. The key vault implementation, for example, can be customized according to the use case, where the client wants to purge the keys, list the keys. When these policies are all code, application teams can submit their pull requests, and the security team can review, and if they are happy with the policy and the test, they can approve, and they can just go live. So let's look at how we did it and what BDD looks like in our case. This is a sample of feature file. And BDD is behavior-driven development. It was invented by Dan North as a combination of TDD and BDD. He figured out that it doesn't work for a tester, a developer, and a business person to look at the test and understand what it does to get the right outcome. The tests are human readable. It's a live documentation of the test. It has features at the top, levels to categorize the tests, and it's split into scenarios to group the related tests, such as test suites that we can run together. Gherkin is the common DSL, which is the human readable to specify the behaviors given when then statements identify what allow us to write the tests and execute them step by step. To run a group of features together, we can use tags. They are they allow us to group write either for the specific resources or specific people or specific timing when we want to execute them. As the framework, we use the Cucumber.js. And here is how that feature file is executed in the test. We have chosen TypeScript. How this is the test implemented. We have annotations after and before to set up and tear down the test. We have Gherkin annotations given when then statements. It's a simple regex to match the step definitions defined in the feature file. So what type of challenges we had? The first one was about the Azure policy. It's not real time. The engine runs up to 24 hours to get the compiled compliance report. And we assume that it may take the worst case the 24 hours. So we categorize our tests to allow which ones are going to be the first ones to get results or the last one. The second one is each effect has a different wait time. They don't happen at the same time. So we favored the deny policy, which is kind of the quicker response time compared to the audit policy, which was a misconception. And the last challenge was the Azure policy, which is a public repo, doesn't support versioning as much as we would like to. So we favored our custom policies over the built-in policies to track the versioning and to run them reliably. This is a kind of nice graph. Which effect has time. The x-axis has the time, so it does disabled append deploy if net exists, modify happens, then deny, and audit happens last. Whereas the most restrictive ones has a different order, disabled, and then audit, append, and deny. So it's just we had to take all of them into consideration when we write the test and agree on the effects. And in terms of the VDD, we had to do some trade-offs. The decision of the language, which one are we going to pick? As the Terraform was the infrastructure code that we have implemented all, Golang would be the default language choice, but we went with the strength of the team, which was TypeScript, and the learning curve is so low that we could onboard multiple teams picking up tests easily. Second is when to run the tests and where to run the tests. We executed all the policy assignments together with the tests, together with the deployment as well, so that a dedicated integration environment, which is the management group, can enable us to provide that real validity of the test. Here are some books. Actually, John Smart was part of our team when we implemented, so we are so lucky to have him. Specification by example, Goiko Ethics, a good book to read, and also the DDD, implementing DDD is a good book to check out. I also included 3 references. Dan Norris' first BDD blog post. Lee's Cow has lots of good insights on how should be implemented, and Goiko Ethics blog posts on the spec flow, and could be also interesting if you want to check out. Thank you very much.
Thank you. Thank you. Thank you, Ebru, for a great session. I think in the interest of time, if people have questions for you, they can reach out through social media and also post their questions here in the chat. So once again, thanks a lot.
And that's it for our time hosting the event. It's time to go for us, I'm afraid. I hope that you've enjoyed the last few hours as much as we have. It's been fantastic being able to be here and guiding you through these sessions. Don't forget the challenges that we have, the Cloud Skills Challenges, aka.ms/VACD-challenge. Trying to remember to do that in English when I've been speaking Dutch all day is so hard. Thanks for spending this time with us. Coming up, we have Barbara and we have Roland, and they're going to guide you through the next sessions. Hope you have a fantastic evening coming up. Goodbye.
Goodbye.
Hi, and welcome back. We've seen some excellent sessions today. And together with Barbara, I'm going to host the last couple of sessions. We're here till, I think, 10:15, maybe some time after it because we're running a bit late, but that will be okay, I think. I'm very excited to be here. I'm Roeland. I've been a developer for about 20 years. I'm very passionate about cloud, and I'm very excited to host these sessions with you with Barbara.
Yes. Hi. My name is Barbara Forbes, and I'm an IT consultant and a Microsoft Azure MVP. And I'm very excited as well.
Great.
There's some great sessions coming up.
Yeah, and I'm really looking forward to the next session because I'm a developer, and the next one is about Dapper, distributed application runtime, from some amazing speakers. It's actually the one only session with 2 speakers today, so let's try if that works as well. You can post your questions in the chat. We still have the skills challenge, so the link is down below. So definitely check that one out. And are Edwin and Sander in the call already?
Yes, we are.
Hi, welcome.
Thank you so much for having us.
Most definitely, yeah. Thanks.
It's so great you could be here. And I always have a knack for ruining people's intro slides, so I'm trying not to do that this time. But you're both principal architect, you both work at InfoSupport, and you're both Microsoft MVP. How can we tell you apart?
Well, I'm an Azure MVP, and I'm not sure whatever kind of MVP Edwin is, but
I'm just developer technologies, but you know, I also do a lot of Azure, but I'm not the Azure MVP. That's Sander. So yeah, there's a little distinction between us.
So that's what we can't tell which MVP you are, right? So, well, you have to see tonight, I think, for your session. So if you're ready, just take it away.
Yes, I shall share my screen. Let me see, and please let me know if you can see that.
Yep.
Yes.
Screen up. Pretty cool. Okay, so yeah, we're going to talk about Dapper today, and we're also going to look a little bit at eShop on Dapper, which is a reference implementation, and that's basically the eShop on containers that you might know. That's a Microsoft reference application, and we've basically ported that to Dapper, and we're going to use that as we talk about a couple of examples that we're going to show today. So without further ado, let's first look at what is Dapper. Well, Dapper stands for Distributed Application Runtime. And that's exactly what it is. It's a runtime that you can use as a developer to build distributed applications. And that's a very broad concept, of course. And what we see when we see people building these kinds of cloud native distributed applications or microservices applications, we often see a lot of infrastructure being used. So you have message brokers for pops-up messaging, you have, you know, state stores, you have maybe some discovery servers for finding services, all these kinds of infrastructural components. And this is exactly what Dapper can help you with, because basically Dapper is there to hide all these complexities of all these infrastructural components, so you can focus on building your application and not focus on all the infrastructure goo, so to speak, that you have to maintain. So that's where Dapper comes in. So let's look at how Dapper does that. So the Dapper runtime offers a quite extensive set of building blocks. And here you see a couple of them. And most of them we're going to look into a little bit more detail later on in the session, but I will walk through them quite briefly now. First of all, you have service-to-service invocation or service invocation. And this is basically for calling other services in your microservices application without knowing where they live. That's basically what it's all about. Then there's state management, and this is for storing some key value pairs or some contextual information in an outside store, so you can basically build stateful services, so you can rehydrate this state when you later on need it. Then there's a publish and subscribe building block. This is for pops-up asynchronous messaging, quite well known, I think. And there's also some resource bindings and triggers. And these resource bindings and triggers can be used to integrate with all kinds of different external systems. And we will also go a little bit into more detail later on. Next to that, there's also a virtual actor model that Dapper offers. So you can build also actor model-based applications. And Dapper offers you built-in observability, which is very cool. So you can see what goes on within your system and you can monitor your services. Finally, there's also a secrets building block, and this is for handling, stuff that you don't want to publish, things like passwords or connection strings or certificates. And there's a whole suite of tools around that, and Dapper can abstract that for you. And then there's the last block. It says extensible, because the whole Dapper ecosystem is basically completely open source. And we think that more building blocks will come as time progresses. So that we will see multiple building blocks be added in the future. Well, the cool thing about Dapper is that all these building blocks can be called using standard HTTP or gRPC communication. So that also means that you can leverage Dapper from basically any platform or language in which you can do HTTP or gRPC communication, which is probably from everywhere. Of course, there's also a more convenient way of working with Dapper, because there are several SDKs available for different languages. So there's one for Go, for Java, for .NET, for Node.js. And this offers a more intuitive way for you as a developer to use these building blocks instead of through the raw HTTP or gRPC API. And then there are a couple of other frameworks that Dapper also nicely integrates with. For instance, ASP.NET Core, or Azure Functions, or Azure Logic apps. Well, there's a lot to tell about Dapper. That's all not in this presentation. So we're going to focus on a couple of the building blocks and tell how these work. And then finally, what's also very important is that you can basically anywhere. So you can run it on your own laptop or your desktop when you're developing, but you can also run it in the cloud, in Azure, in AWS, well, basically anywhere on a cloud or edge infrastructure. So that's pretty cool. So how does Dapper do that? Well, Dapper leverages sidecar architecture, and this is a well-known pattern because the Dapper building blocks are offered by a sidecar that's basically running alongside your application code. So in this case, there's several ways of running Dapper. In this case, we're running in a standalone mode. You just have your application code in a separate, OS process, and then the Dapper sidecar is run alongside that. And your application communicates with the Dapper sidecar to leverage all the building blocks. Pretty straightforward. Another way of running Dapper is in a Kubernetes cluster. And then the Dapper sidecar is basically deployed as a separate container within the pod of your application code. And it runs alongside your application. And because in a pod, these containers can talk to each other, it is very easy for them to talk to each other and communicate between each other. So that is how this works when you run in Kubernetes. Like I said, we have used Dapper in eShop on Dapper, and Sander is now going to tell us all about how we did this to port eShop on containers and work with Dapper. So Sander, maybe you can share your screen.
Yes, I will share my screen. I just got a note from the production that my video isn't showing. I hope that at least my window is showing, because that's actually the important part. So
I can see it, but I don't know if it's in the live stream.
Okay, well, if you can see my window, I will assume it's also in the live stream.
Yep.
So yeah, we are going to look in the remainder of this session into some of the details of these building blocks, see how they work, how they can improve an existing application. And as Edwin already told you at the beginning of the session, for that existing application, we are using eShop on containers. So eShop on containers is a sample .NET Core reference application created by Microsoft, and it's basically implementation of a web shop that lets you buy some cool .NET merchandise, and now also some cool Dapper merchandise. And it uses a simplified microservices architecture with Docker containers. So let's have a look at the architecture. So we've got a front end here, which consists of a single page application, which is written in Angular. And backend requests from that front end are handled by an API gateway. And this gateway is implemented using Envoy, which is an open source edge and service proxy. And Envoy will forward the requests to a number of backend services. And there are many different backend services in eShop, and they are the services that really provide the core functionality, such as the catalog of items, the tracking of the items in your baskets, the entire ordering process, etc. Now, most of the calls from the eShop frontend can be directly routed to a single backend service by the API gateway. However, there are some scenarios which require multiple backend services to work together to complete a more complex request from the frontend. And in these cases, eShop uses an aggregator service, which is called a web shopping aggregator, to mediate that work across those different services. And then finally, backend services can also communicate with each other, and that is done using messaging to keep them nicely independent and loosely coupled. So this is the original eShop on container solution. And then we started to add Dapper to it. Now for the Dapperized version of eShop, each service now has a Dapper sidecar. And that makes it possible to use all those nice Dapper building blocks. And what you can see here is that we not only added a sidecar to each .NET service, but we also added a sidecar to the Envoy API gateway. And that enables us to use the Dapper service invocation building block to call the backend services from the Envoy proxy so that everything is Dapperized. So now let's look at some of those building blocks in more detail and see how we've actually applied them to eShop. And we will start with service invocation. So service invocation enables services to communicate with each other using either HTTP REST or gRPC protocols. And I'll also talk a little bit about observability because that's one of the benefits that you get from using the service invocation building block. So I've shown you the overall architecture of the eShop solution, but let's zoom in a bit and look at an interaction between the web shopping aggregator service and the basket API. So in the original solution, when a user adds or changes an item in the basket, the aggregator service calls the basket API to store the updated basket. And this is a direct service call to that service. So now let's see how we change this to work with Dapper service invocation. So first of all, if you use Dapper, Dapper takes care of service discovery for you. So instead of calling the endpoint of the basket API directly, you now make a call to your Dapper sidecar. And here's an example of making such a call using HTTP REST, but you could also use gRPC to communicate with a sidecar. So that URL they see right there, it contains the application ID of the service to call, which is basket API, as well as the method to invoke, which is API v1 basket. Now, using the application ID, the Dapper sidecar does all the service discovery for you and then forwards the request to the sidecar of the basket API service. And that sidecar, in turn, will make the final request on the actual service. And then the response will flow back the same way. Now, because these calls now flow through sidecars, Dapper can inject some very useful cross-cutting behaviors. So, for example, Dapper can automatically retry calls when they fail, when there are transient failures involved. Dapper can also make calls between services more secure using MTLS authentication, and it also includes automatic certificate rollover. You can add access control policies to control exactly what operations clients can do on services. And Dapper can automatically capture traces and metrics for all those calls between services to provide you with some insights and diagnostics. So I think it's time to look at some code. So let me switch over to Visual Studio. So as you can see here, I've got this complete solution open up here in Visual Studio Code. This solution is completely open source. It's available on GitHub, so we'll share the link with you after the session so that you can play with it yourself. You can see here we've got some Docker Compose files. So I'm using Docker Compose here to run eShop locally, which is called self-hosted mode in Dapper terms. But we also added some scripts to the repository to run in Kubernetes. And Kubernetes is actually the preferred way to run Dapperized applications in production. So if I go over to the container step right here, you see a lot of containers are running. So my application already up and running. So I should be able to go to my web browser and show you the shopping front end. So welcome to our store. We've got some great products in here. As you can see, we just received some new Dapper swag. So for example, let's say I want to buy this nice cap, and let's throw in a Dapper hoodie as well. And if I scroll back to the top, you can see my basket here, which now has 2 items in it. And if I click on that, you can see the items. Maybe I want to buy even some more caps, buy some for my friends. And then you can check out the basket. All fairly basic web shop stuff. You enter your shipping address, you enter a payment method, and then you can place your order. And then you will see this pop-up notification because now there's an ordering process that has been started, and you will be kept up to date on the progress of that through Signal or notifications. So that is basically the whole eShop functionality in a nutshell. Now let's go back to the code. So in the previous slide, I talked about an aggregator service making a call to the basket API to save the updated basket. And if we look at the code of the aggregator, so the aggregator code is here in this aggregators web shopping HTTP aggregator folder. And here we find this basket service class, which is responsible for communicating with that basket API. Now, this call uses depth service invocation, and because eShop on containers is completely written in C#, we really wanted to use the Dapper.NET SDK to make that call to have a more natural .NET experience. So using the SDK, we get this nice Dapper client object, which is injected into our constructor. And we can use that Dapper client to basically call all the different Dapper APIs on the sidecar. Now for this specific call, all the magic happens here in this update async method. So this will get the updated basket. And here we use the Dapper client invoke method async method to make the call to the basket API and give it that current basket. And that method takes a couple of parameters. So first I need to give it the logical name, the application ID of the service I want to call, which is stored in this constant here. So the actual value is basket API. I give it the name of the method or route, if you will, to call. I give it the payload to send, which is the updated basket. And lastly, because the basket API is protected, I need to send along an authorization header containing an access token. So note here how we use this HTTP extension object to pass along that HTTP header. And you can also use this object to specify other HTTP details whenever you are calling a service that has an HTTP REST endpoint. So things like query string or the HTTP verb, which is post by default, by the way, so I don't need to specify it here for this post call. Now let's have a quick look at the other side of notation, because this is the caller side and we're calling the basket API. So let's see what that looks like. So let's go to services basket. And there's actually not much to tell you because this is just a plain old ASP.NET controller. So this receiving end of the equation doesn't need to know anything about that, but it just gets called. So the call will go to this update basket, and that will take the updated basket and use this repository pattern to store it in the database. And we actually use the Dapper state management block for that as well, but I will show you that later on in the session. So now that eShop uses Dapper service invocation, one of the benefits is that Dapper will automatically collect those traces and methods I talked about. And we've configured Zipkin, or we configured Dapper to export all that telemetry data to Zipkin. So if I now go back to my browser and show you the Zipkin dashboard and run this query, you can see all kinds of tracing information for the stuff I just did in the eShop web frontend. So this is very nice. It's basically we are getting this for free just because we are using service invocation, and we get a lot of observability by that. And Zipkin also has this very nice dependencies page where you can get a very nice service map of all your services, because it can get that information from the traces, because yet again, everything is running through sidecars. And this is Zipkin, but there are other things you can use, such as Jaeger application, Insights, Prometheus. The dev team is currently adopting OpenTelemetry. So basically everything that works with OpenTelemetry, you can send your tracing information to. And with that, let's move to the next building block and look at some asynchronous messaging. So take it away, Edwin.
Yes. Let's look at publish and subscribe. If you look at eShop on containers, then all the services that are in there, we're communicating asynchronously using an event bus abstraction. And this event bus abstraction, there were 2 implementations for that created for eShop on Containers, one for RabbitMQ and one for Azure Service Bus. And this is, of course, pretty handy because you could use RabbitMQ for your local development and test workload, and then use Azure Service Bus once you go to production, for instance. So you can switch between them. But because this is an abstraction, there were also 2 implementations, and there were several classes created for creating a connection to the message broker and also the behavior of the message broker, like sending and receiving messages. And this is quite an elaborate set of code that was created by the creators of the eShop on Containers. Besides that being quite a lot of code, which is all infrastructural stuff that we basically don't want to be bothered with. We want to, build business code and add business value. Also, when using these building blocks, if you look in the startup class of one of the services, this is also quite an elaborate piece of code. So first of all, you have to figure out whether you're running with Azure Service Bus or RabbitMQ, and then also use the particular implementations of these 2 implementations. So it is, quite a bit of code, and there's also quite a lot of knowledge that you must have around these 2 message brokers in order to use them. And this is quite cumbersome. Well, this is exactly where the PubSub building block from Dapper can help you. So let's look at how that works. First of all, what you can do is the Dapper sidecar, it offers an API for you to publish messages. So in this case, we are looking at the ordering API, which is one of the services within eShop on Dapper. And it can just call the Dapper sidecar using a well-known endpoint. And in this case, it's the publish endpoint. And there are several things that you can do. First of all, this is a post because you're sending a message and you need some sort of payload. And in this case, it's sent as a piece of JSON. So that's just basically the event or the message that you want to send. In the URL, you also see several things back. One is the component, and we will talk about components a little bit later, how you can configure this, because a component basically implements the building block. So in this case, we use a component that we call PubSub, and that is the one that we want to use for sending this message. Now, next to this components, we also have to specify the topic that we want to send the message to. And a topic is basically like a mailbox that you can send messages to. And then other services can subscribe to these messages on a certain topic. So this is how I can send these messages. And when I call this API, and like we said before, you can do this using HTTP or gRPC or using one of the SDKs. And in eShop on Dapper, we use the .NET SDK. Once we have called this API, the Dapper sidecar will eventually call the actual service broker and deliver the message to the service broker. So this is why there are several choices here. So I could be using Redis, I could be using Nets or Azure Service Bus. Dapper abstracts that for me. On the subscribe side, there are also Dapper sidecars for the receiving end. And these Dapper sidecars will create subscriptions for the topics that you're interested in as an application. So let's, here we see 2 sidecars. So we have 2 services. In this case, that's the catalog API and the payment API. They are both interested in these order status changed messages. So a subscription was created on this topic. And then once the message is sent to the message broker, the Dapper sidecar will pick up this message because it has a subscription on it, and it will call a certain endpoint on your application and deliver the payload. So this is how this works if you look on an API level. So how can you configure this? Well, if you're using .NET, and eShop on Containers uses .NET, obviously, there's a really convenient way of doing some ASP.NET Core integration of Dapper. What you see here is the 2 web API methods. So these are 2 different controllers with a method on it, status change and status update. And these are just plain web API calls. And what I can do to make sure that I have a subscription on a certain topic and that this certain API is called when a message comes in on that topic, I can add a topic attribute to it. So this is something that comes from the .NET SDK, from the ASP.NET integration package. And you can just put the topic on top of it. And then you specify, again, which component you want to use, in this case, PubSub, and what the name of the topic is that you want to subscribe to. And when you do this, the Dapper sidecar will pick up all these topics and will create subscriptions accordingly. So that's pretty easy to do. Also, there's some other stuff that you need to do in the startup of your application or your service. And there are also some convenience method to add Dapper to the application. In this case, you can call add Dapper on the services.add controllers that you already have there for your ASP.NET Core MVC pipeline. And this will add the services to dependency injection that are needed to use Dapper. Also in the configure method of the startup class, you see two calls. One is use cloud events. And this is because Dapper uses the cloud events format. This is a standardized format for sending messages. So when the message is received, it can be, unpacked and it can be read by the application and by the sidecar. And also the map subscribe handlers that you do in the endpoints part. This will make sure that all the subscriptions for all the topics that you have added will be created when the application starts. So this is all you need to do, and then you automatically start, reacting on messages that come into the certain topic that you have configured. So that's pretty easy. So how do you configure a component? In this case, a PubSub component. Well, you create kind of like these resemble, Kubernetes manifest files. So you can create Dapper configuration files, and there are several parts in there. So first of all, you name the component. And as we saw in the sample before, the name was PubSub, but this is something that you can provide. And you can also have multiple configurations, each with their own name. And this way you can switch between different configurations. There's also always a type in there. So in this case, it is a PubSub building block, and the component it uses is Nets Streaming, which is one of the message brokers that is supported out of the box. And then finally, each type of message broker has some specific metadata that you can add to it. So this will differ per message broker. And by adding this configuration file and giving that to your Dapper sidecar, it knows how to interact with the PubSub building block. So this is how that works. So let's quickly look at an example in eShop on Container. Just as Sander just showed the application, this is eShop. I already have some orders in here. Let me see, I have a message in Teams. Let me see what goes on here. Oh, that someone wants to get in, that's not for me. So what I can do now is look at all the topics that were created when the application was started. So what you see here are all kinds of topics, and these are in a Redis cache. So I'm using my Redis cache as my PubSub component. And when the application starts and all these services start up, they will create certain topics that are used for sending messages. And as you can see now, there are no messages in these topics now. But when I, for instance, order a cool Dapper sticker and a Dapper cap, for instance, and I check this out, so I buy this, then what you just saw in the demo that Sander showed, in the background, some ordering process is being simulated. So there are all kinds of events flying around between the services. And if I now go back to the Redis commander and look inside the Redis and refresh this, then we can see that all kinds of events come in. So this is a user checkout accepted event or an order started integration event. And as you can see here on the right, these are just plain JSON files or JSON payloads that contain all kinds of IDs and stuff like that. And this is also according to the cloud events format. So that is how that works. So with that, let's go on to the next topic, and that is state management. So take it away, Sander.
Yes, I'm going to switch screens again. Be on mine now. So yeah, state management. So state management in Dapper provides a key value based API for persisting state. You can use it to create stateful services, and it's really meant to store some contextual data, not to store your entire relational database in it. So if you look at the original eShop on Container solution that uses a variety of data stores, many of the services use SQL Server, and they use Entity Framework to access the database. And that's perfectly fine because Entity Framework is very good for that. And the Entity Framework already provides support for many different databases, such as SQL Server, MySQL, Cosmos DB. So that already gives us a level of portability for relational data. Now, there are also some services in eShop that use other data stores. An example of that is the Basket API. So the Basket API stores its data in Redis. And to make that work, it has a dependency on Stack Exchange.Redis, which is a third-party SDK, which you would need to learn to be able to use it. And we changed that implementation to actually use the Dapper state management building block. And as a result of that, we've now got many more different backing stores to choose from without having to learn any other SDKs. So let's see how this works. With Dapper state management, you can store and load the state in the key value store by simply, yet again, making calls to your sidecar. So if the basket API wants to update the basket, it could simply do a post request like this with the data it wants to store. And then the Dapper sidecar will persist that state to the configured backing state store, whether that's a Cosmos DB, a Redis cache, or some other store. And then to read that value back from the store, you can do a GET request. And in that request, you specify the key you want to query. The Dapper sidecar will look it up for you from the backing store and return it. So let's see what that looks like in code. Now, eShop already used this repository pattern to access the data store. So for example, if I go to the basket API, then in infrastructure repositories, we've got this Dapper basket repository. Now, of course, in the original solution, this wasn't called Dapper basket repository, it was called Redis basket repository. And we changed that name and that implementation to use the Dapper state management. And let's start at the top. So as you can see, we again use that Dapper client, we get it injected in the constructor, and that allows us access to all those nice state APIs. And as you can see here, those state APIs are pretty simple. So if we want to delete something, we can simply call delete state. We can retrieve state by calling cat state. Here we use cat state entry, which makes it possible to get something from the state store, change the value, and save that back to the store. So in this way, we can do an update. Now, the state store that actually does the persistence is configured in a component file. So let me go over to the component file. And as Edwin already showed you, that's just a YAML file, looks very similar to Kubernetes manifest files. And here you can see that we are currently storing our basket state in table storage. And this file also makes use of another Dapper building block, which is a secrets building block, because I don't really want to store my storage account key in this file, because this file will get sent up to GitHub in source control. So instead, I'm storing secrets in Azure Key Vault, and I'm telling Dapper using this secret key ref and this configured secret store to get that account key from Azure Key Vault. Now, let me quickly show you that this also actually works. So let me go back to the shop. You can see right now we just placed that order, so my basket is empty. So now if I go to Storage Explorer and I go to the storage account, my table should be empty because there's nothing in my basket, and I'm currently the only user of this instance of the application. So as you can see, there's no data in the backend store yet. Now let's add something. So let's say I want a .NET Path Black hoodie. Now we've got something in the basket. If I switch back to Storage Explorer and refresh, then now you can see if I click this open, look at the details just to prove it to you, you can see that there's now a .NET Path Black hoodie in my backing store. So that's a very easy example just to show you how it really works, but realize that you can now very easily change or switch backend stores just by changing that configuration. You do have to be aware, though, of subtle differences between implementations. So for example, with table storage, a single value you can store in a table storage column has a maximum of 32,000 characters. So if you're switching between a store that has such a limit and a store that lets you basically store unlimited sizes of blobs, then maybe you run into some problems with your applications where one store cannot store all the data that you want. So you gain a lot of portability with this layer of abstraction, but you still need to pay a little bit of attention to the actual implementations. And then I do think we still have got some time to talk about bindings, Edwin.
Yes. So let me share my screen. Thanks. Resource bindings are basically a way to integrate with different external systems. And this is a very broad aspect, of course. And you could argue that also pops up, for instance, as a way of integrating with different external systems. But there's quite a small difference there, because this does not only focus on message brokers and sending events and doing asynchronous messaging, but it also has all kinds of bindings, for instance, for Twitter and Twilio SendGrid and Azure Storage. So it is basically a way of getting events from certain systems, for instance, when a file is dropped into an Azure Blob storage or whatever, and then get an event into your application. Or if you want to do something, you want to call you want to send an email or whatever, there's also a way of integrating then, for instance, with Twilio SendGrid to send this email without knowing how Twilio SendGrid works. So you do it through the Dapper building block, the resource binding. There are two types of bindings. There are input bindings, or they're also called triggers, and they react to events. And you have also external or output bindings that you can use to do outbound communication, like the Twilio SendGrid thing. Also, I have to stress that because these are just Dapper building blocks, you can use them through HTTP or gRPC for calling them, or to the SDK. So how does this work? Well, here I have an example of an input binding, and I'm going to use a Twitter example. So I have my service running, and I have my Dapper sidecar running, and this Dapper sidecar has a configuration file it interprets when it starts up. And in this case, it's a binding, an input binding for Twitter specifically. And as you can see in the configuration file, I give this thing a name, tweet, and this is very important. I will show you in a minute why that is. And also, you see the type, bindings.twitter, and you see some specific metadata. In this case, it's some credentials to connect to some Twitter feed. And there's also a query in there. That's one of the functionalities of the Twitter binding. You can specify a search term, and when a tweet is sent that has this term in the text, it will be picked up by the binding. So once Dapper has read this configuration file, it will connect to Twitter, and it will start looking for tweets with Dapper in the text. And once a tweet is detected, it will pick that up, and it will call your service on a certain endpoint. And here you see that the name is again really important, because this name is used as the endpoint that is being called on your application. So in this case, the service is running on port 5000, and you have to have an endpoint that listens to /tweet, and it will get the payload with all the information around of the tweet. And then you can handle that, whichever you want to do with this tweet, and then you can send back a 200 OK to tell Dapper that this message was handled successfully. So this is how you can use an input binding. The output binding is quite similar. So again, I have a service with a Dapper sidecar, and now I have configured an output binding. In this case, it's a Twilio SendGrid binding, and I call it send mail. And now what I can do from my application, and this is what we actually use in eShop when we start sending emails, for instance, when an order has been completed, from our service, we can call a binding endpoint, and we use the same name as we have used in the configuration for this output binding. We give it a payload, and then the Dapper sidecar will actually invoke SendGrid and send the payload over there, so the email will be sent. So this way, I only need to know the Dapper API, and I can send emails from my applications without knowing how SendGrid actually works. I only have to provide some API key or something in the metadata, so Dapper can connect to this service. So that's pretty cool. As I stressed before, Dapper is completely open source. So all these components, you can write them yourself. And you could also, of course, write bindings for all kinds of different systems that are not already out there. You have to do it in Go, because Dapper is built in Go, but there is a possibility for you to build your own bindings, input as well as output bindings for your system or some other service that you want to use from your application. So that's pretty cool. So, and with that, yes, of course, Dapper will send you a 200 OK when the message has been sent. With that, we are through the stuff that we wanted to show you. So thank you for listening. Thank you for having us. It was great being part of the Virtual Azure Community Day. There are some resources up here. There's some links to the documentation and to the eShop on Dapper. project on GitHub. And if you want to see more of us, you can watch our .Netflix video channel. And I don't know if there are any questions in the chat. I think we have a little bit time for questions.
Well, I have a question myself. Can we expect to see this in the wild at the moment?
Well, we're still in. There is now a release candidate version, and we're working closely with the team. And I think that somewhere, well, first quarter next year, there will be a 1.0 release that is actually generally available.
So 2021, we can expect to see this out there.
Yeah.
So exactly. Cool. It was such a great, clear explanation of Dapper. Even I understand, so that's usually a good sign. Thank you so much for this amazing session.
Yeah, thanks for having us.
Yeah, it's great. Thanks.
Thank you.
Have a great rest of the conference, everyone.
Thank you.
Thank you. Yeah, awesome. So without further ado, let's move on to the next speakers. Next speaker, I should say, which is Loxley, I hope I say it correctly. Are you there?
Yes, I am there.
Hi, welcome. So you are a senior at the University of Washington. You do a major in informatics, and your focus is on academic developer advocacy. Pretty cool. And you have a talk about quantum computing, which sounds really awesome, and a great subscription of that talk. How did you get the idea for this talk?
Well, I first heard about quantum computing 2 years ago when I read Hit Refresh by Satya Nadella, where he said it was literally one of the top 3 things he said was going to change the world, and especially in Azure. And so after that, I've been following learning modules. I've talked to a couple quantum experts, and I created a very good talk just for beginners to kind of understand the beginning parts of what is quantum computing, how does it work, and how to connect it to Azure. So I'm very excited. This is a topic that I'm super passionate about.
Okay, that sounds awesome. Well, I can't wait for you to start. So I'm not gonna ask any more questions. Really, I love to hear the talk. So the floor is yours.
Awesome. Let's be. Okay. So welcome so much to my tech talk. I'm so excited to be here this year. And so we've already gone through a little bit about who I am. And so here I'll just quickly dive into our agenda for this talk. So we'll first cover what quantum computing is and dive into how specifically it works. We'll then discuss why it matters and some really important problems that it has the potential to solve. And finally, we'll tie this all back into how it specifically relates to Azure and how you can learn to implement it right now. And so first things first, what is quantum computing? And to understand the fundamentals of quantum computing, we have to go back to 1935 when Erwin Schrödinger first shared his thought experiment with Albert Einstein. And Schrödinger asked, what if we placed a cat in a box? Or specifically a box with a poisonous substance inside that had an equal chance of releasing or not releasing within an hour. And he said, before we opened the box, we would have no idea whether the cat was alive or dead. It could be alive and dead at the same time. And so the concept of existing in 2 different states at the same time is at the core to understanding quantum mechanics. And this thought experiment was first applied to the concept of quantum computing 50 years afterwards in the 1980s. And so quantum computing is a new computational paradigm. This means that it runs differently than your phone, your laptop, a server, or any other piece of technology you currently own. And what sets quantum computing apart from a classical computer is speed. It has the potential to solve specific problems exponentially faster. And what could take a classical computer billions of years to solve could be solved with a quantum computer in a matter of hours. And so how specifically does quantum computing work? And so let's go back to our Schrödinger's cat example. When we think about a cat being alive and dead, that is fundamentally different from how classical computers work. Right now, our computers run on bits, either ones or zeros that are strung together and sequentially processed. This is known as binary code. Just like how a cat can't really be alive and dead at the same time, a bit can never be a 1 and 0 at the same time. And in addition to being discrete, bits are deterministic. This means that when we repeat the same computation, it will always produce the same output. So for example, if we told a computer to run 5 + 5, it would always send back 10. And whether you ran it once or a million times, a classical computer would still only return 10. But quantum computing, in comparison, has quantum bits, or that are more commonly known as qubits. And unlike a classical computer that can only be a 0 or a 1, quantum computers can be an infinite or continuous number of possibilities. And unlike a bit, qubits are what's called probabilistic. And so this means that if you told it to add 5 + 5 together, it wouldn't always return 10. And what makes a quantum computer useful in this way is that if we told it to run 5 + 5 once, it may return like a different number, like 8 or 11. But if we told it to run 5 + 5 like a million times, it would increasingly get closer to the number 10, which means through repeated computations, like our confidence in the answer increases. And so in addition to that, qubits have 2 superpowers that bits do not have. And so here we have a visual example of a bit and a qubit. As we can see, a bit can only be a 0 or a 1 at any given time. But let's say you have a single qubit. The qubit can be a 1, a 0, or both at the same time. And when a qubit is both a 1 and a 0, this is known as superposition. Now, let's say you have 2 bits and 2 qubits. A bit can only be one of these orders at any given time, either 0, 0, 0, 1, 1, 0, or 1, 1. But let's compare that to having 2 qubits. When combined, they can simultaneously be all of these values at the same time. And this grows exponentially. For every qubit you add, the number of combinations doubles. And so, for example, if we added an additional qubit to this to bring it to a total of 3, there would be 8 potential outputs. And this superpower is known as entanglement. So what are the benefits of superposition and entanglement? So an exponential number of potential outputs decreases the time it takes for a program to run compared to a classical computer that has to run linearly. And so the following is a really good representation of how a classical computer would solve a maze compared to a quantum computer. So with such a speedier runtime, like why haven't we started learning and implementing quantum computers more in like our day-to-day lives? And there are 2 main reasons for this that we're going to cover. And so number 1 is it is debatable on whether we have achieved quantum supremacy. So quantum supremacy can be defined as when a quantum computer can perform a task faster and better than a classical computer. And this is commonly tested by giving the best quantum computer in the world and the same classical computer in the world the same question to solve. And so currently, a classical computer can simulate a quantum computer up to a certain number of qubits. And a quantum computer would need to surpass a classical computer in ability before it could be considered having attained quantum supremacy. And so, but as investment in quantum technology and research improves, this will hopefully soon be achieved. Some sources think that some types of quantum computers can become mainstream in the next 2 to 5 years. And so next up is running a quantum computer is incredibly expensive, or in other words, just very high maintenance. So let me explain. Running a quantum computer can cost over 1,000 times what the same query would cost to run in a classical computer. And this is due to the environment a quantum computer needs to run in. So do you remember in Ant-Man when he had to shrink down into the quantum realm, which was so unstable that he almost didn't make it back out of it alive? And this is kind of how quantum computing works in real life. Like when they are incredibly sensitive to that, so that if any interference affects it at this scale, it'll pretty much disrupt the computer's calculations. And so a couple things are used to control the environment, which is temperature and noise. quantum computers currently need to run at a temperature of nearly minus 460 degrees Fahrenheit, which also equals about minus 273 degrees Celsius, which, to put that in perspective, outer space is minus 455 degrees. So maybe the solution is moving all of our quantum computers to outer space, which probably won't bring costs down. But so a current challenge, because obviously we're going to be keeping our quantum computers on planet Earth for now, is that we need to run our quantum computers at room temperature. In addition to being insanely cold, it also has to be insanely silent. Researchers are currently creating environments with the lowest noise levels on record just for quantum computers. And so the challenge in controlling these environments makes quantum computers more likely to produce incorrect outputs. So creating quantum computers with error correction or fault tolerance is incredibly important. So in other words, quantum computers are so sensitive that we won't be carrying around quantum smartphones or quantum laptops in the near future. But although these challenges are going to take years and some of the industry's brightest minds to solve, I think it is still possible. And here's why. So classical computers, as we know of them today, have been around for about 70 years and have seen trillions of dollars of investment. In comparison, quantum computers have only been around for about a little more than 20 years. And have seen about $1 billion of investment. And so they've already come an incredibly long way in like the last 20 years. So as investment continues, so will innovation, and they'll soon continue to improve. And so we know about the current shortcomings with quantum computing. It is important to know why quantum computing is still so important and why it matters. And so here are a couple use cases that have the potential to change the world. And so first up is machine learning. So machine learning is based on both sampling and optimization methods, which means quantum computers can help a lot in this space. So quantum computers can provide more distributed and reliable data than classical computers, and can use optimization to show how the machine learning algorithm should be improving over time. Next up is climate change. Quantum computing can discover solutions that would efficiently combat global warming. And this includes creating synthetic fertilizers that reduce consumption of natural gas, as well as make our energy sources, such as disposable batteries, more efficient. And finally, there could be major breakthroughs in healthcare. Classical computers can take years to process the complexity and accuracy needed to create medical treatments. But a breakthrough in quantum computing would mean treatments could be optimized and developed exponentially faster. So as we have covered, quantum supremacy could be possible, like quite literally within the next 10 years. So, and the great thing is, and like to get prepared for that, the best thing we can be doing right now is learning it and experimenting with it so that we're prepared for when it starts transforming these industries. And the great thing is Microsoft is aware of how important quantum will be and is baking it into the Azure ecosystem right now. Today, you can run a quantum solution using a simulation on a classical computer, and even with the real deal with Azure Quantum. And finally, even cooler, Microsoft has created the open source quantum development kit known as a QDK, which includes free libraries as well as the programming language Q#. And so I highly recommend to learn more to check out Microsoft Learn's Quantum Computing Foundations module to learn more of how to create your first Q# program. And so if you try out quantum computing, I would absolutely love to see it. Tag me on Twitter with what you create, and thank you so much for coming to my talk. I hope you learned something new about the awesome world of Azure today. Thank you.
Yes, that was a great explanation, actually. That was really awesome. And I looked at the chat and people were asking questions and then you were answering them already.
That's awesome. Wow. I don't know if there's any questions I didn't answer. We have time to cover.
Let me just see. Something came on. Someone that says, as a developer, I'm worried about quantum computing since it can decrypt RSA keys very fast. with the formula. So what do you think? Would it also be something that could be used for evil quantum computing?
Oh my gosh, that's actually something that I've done like a little bit of research in. And there's kind of this discussion that it's like, if we created quantum computers, we would be able to pretty much like break any password that currently exists in like a matter of seconds, which a classical computer would take like, yeah, just like millions, if not billions of years to crack. But I've heard that kind of like the alter side to that is if we're creating like these quantum computers that can kind of crack these passwords, we'll be creating quantum solutions that can also like make our environments more secure. So in the one hand, it does have the potential for evil, but on the other hand, we're investing in the technology right now so that when people start to use this tech for bad, they'll be like, yeah, superheroes there to like save the day. So I think as of right now, I'm confident, but it would be interesting to see what the next decade brings. I'd be super interested to hear about that.
Yeah. Well, it's really interesting stuff. I have one last question, a personal question I want to ask. I looked at your blog and I saw you were working on the Seasons of Serverless challenge. How do you find the second challenge? Have you done it already?
That is what I'm doing right after this talk, actually. But I actually was writing an article about custom vision like 2 weeks ago. So I'm like literally super prepared to go in and start working on it. I'm actually so excited about working on it. My goal is to have it done by this Friday, and I'll probably make an announcement like this weekend once I finish it.
Oh, really cool. Well, we're going to read that. So great talk. Awesome. And I really learned something. So thank you so much.
Awesome. Thank you. Have a great rest of your day.
Thank you. Same to you. Then we come to our next session, and it's about Kubernetes and how we can use it through OpenShift. And for that, we have an amazing speaker, and we were very glad he could be here because we had some technical setbacks, I think, a couple of hours ago, but he's here. I think he's here. It's Nigel Brown, developer advocate at the IBM Cloud. Nigel, are you here?
Hey, I'm here. Can you hear me?
We can hear you, certainly. So awesome. Good you could be here.
Yeah, I'm glad to be here. Very happy to be here.
Because normally you're probably in Texas. You're in Austin, Texas?
Yeah, that's correct. I'm in Austin, Texas.
But currently you're not in Austin, Texas?
No, I am. I'm here.
Oh, you are? Okay. Well, excellent. Then, yeah, I only know AKS in Azure for a Kubernetes solution. And I'm really looking forward to how we can do this through OpenShift. And I think you're going to tell us how we can do that.
Of course, of course. Are you able to see my slides?
Oh, could you please share the video? I think we could see your slides. I'm now looking to check. Yes, you can certainly see your slides. And could you share video as well?
The video is on my end. I can turn it off and back on again.
Oh,
yeah, that always works.
There we go. Okay.
We can see you as well.
Okay.
Thank you so much. Well, the floor is yours.
All right, thank you so much. Hey, y'all. I'm very excited to be here with y'all. My name is Nigel. I'm a developer advocate at IBM, and I want to talk to you all about OpenShift. You might wonder why a person from a competing cloud might be here to talk to you about a cloud solution, and I'm excited to tell you about how OpenShift is a way that we can all work together to get Kubernetes going. So they call OpenShift the Kubernetes platform for big ideas. And one of the big problems that we run into when we're dealing with cloud native development is how to develop quickly. Because we all know that as we're developing solutions for our clients, if we're not able to do it quickly, then the value diminishes. And when we're working with tools like Kubernetes, like OpenShift, you're able to work with any kinds of applications that you can dream up. Part of the benefit of OpenShift as well is that you can deploy it in different spaces. So you can run it on the edge. You can run it in your own data centers and hybrid and multi-cloud environments. Now, if you're worried about switching to a new platform, don't worry, you are not alone. There are a lot of people who are using OpenShift now to deliver value to their clients, and pretty successfully, as you can see from some of the companies that are listed here. And part of the things that one of the things that folks run into when they're using Kubernetes is that Kubernetes often is incredibly overwhelming. There's a pretty steep learning curve. And out of the box, Kubernetes needs configuration, different tools that go with it to make it usable for your enterprise environments. And what you have with OpenShift is a set of open source modular components that are built on top of Kubernetes to make it more into a platform as a service, as opposed to what Kubernetes is often referred to as an orchestrator or as containers as a service solution. When you're working with Kubernetes in enterprise environments, you're going to need things like logging and monitoring that aren't really available out of the box with Kubernetes, or things like service discovery. And all of these problems are solved with you when you're working with a tool like OpenShift. Every time there's a Kubernetes release, there's an OpenShift release that goes with it. There's what goes into that release. The biggest contributors to the Kubernetes project are Google, who created the project, and then Red Hat. And they're working on a lot of things inside of the Kubernetes stack to make the tool itself run better, and then present to you a more opinionated view of OpenShift with defect and performance fixes, adding more integrations, and the support. When your Kubernetes cluster falls over, like, who do you call? And when OpenShift, if something ever goes wrong, you have with you the engineering support and the solutions architects, like with Red Hat, to help you solve whatever problems that you ran into. So it's a consistent container application platform that integrates a lot of things that you might look for in Kubernetes that may be difficult to do, or in any of your deployment strategies with cloud native computing. What you have at the bottom is Red Hat Enterprise Linux Core OS, and then Kubernetes on top of that. The way that it's been put that I like is that Kubernetes is the engine that drives OpenShift. So if you're running OpenShift, you are running Kubernetes, and all of your if you're familiar with Kubernetes, all of your command line commands, your kubectl commands, all of those things are valid in OpenShift. But what you have on top of OpenShift, or what you have on top of Kubernetes, are a suite of modular components that make it a lot easier to use. And I'm going to be able to demonstrate some of that for you today. So yeah, feel empowered to be able to control your application security, defend your infrastructure, and extend your security ecosystem with OpenShift. One of the amazing things that came out of the newer versions of OpenShift is a one-click install, fully automated. So if you are running OpenShift yourself, you're not using it on a cloud provider like Azure or IBM Cloud, you can rest assured that the process for getting it going is straightforward. And updates are pushed to you over the air, so you don't have to bring your cluster down in order to be able to get the most updated security fixes. And why is Red Hat the best choice? Because they're contributing to the code base. They have a lot of customers that are using it successfully. You can use it on whichever cloud you prefer, and it's a comprehensive suite of tools. With that, I want to get into a hands-on lab to show you a little bit of what I'm talking about, so it's not just me saying that, oh, hey, this is a great tool. Let's switch tabs over here. I'm going to be using a lab that we've got created for you all. And I said that, OpenShift can run on any cloud, and what you're going to see is a lot of things that are referring to IBM Cloud, but it's okay. Everything that I'm doing for IBM, everything that I'm doing for OpenShift is the same across the different cloud versions. So we have a tool on IBM Cloud called Open Labs, which allows you to get a free OpenShift cluster to be able to build and demo applications. And we have a few tutorials that are set up for you. This one here, when you provision the cluster, you have about 4 hours. This one's only going to take us it's not going to take us the full time. I realize that we're running a little bit behind. but I'm going to show you how to deploy an application on OpenShift, and then show you some of the other features of how it works. So what we have in this exercise one is first talking about some of the things that are specific to IBM Cloud about what you see when you provision a cluster, which isn't necessarily relevant for those of you who are going to be running it on Azure. So I want to just show you what you get when you look at the OpenShift web console. So when you log in, you get a lot of information that you don't really see in Kubernetes. It's a much more helpful dashboard that gives you access to a lot of information that you'd have to search if you were using Kubernetes. And one of the important things that I like to point out is that you have two personas. You have this admin view and you have this developer view. So depending on who has access and like what people need to do, you're able to direct their access through this through the access control that you've got with your admin and developer views, as well as the multi-tenancy of your cluster. Let's just jump ahead to like what it's like to deploy an application. So I mentioned before that, you know, when you get OpenShift, you have a lot of things that are available to you, like the monitoring, being able to do the multi-tenancy, the security. But for those of you who aren't already using Kubernetes and don't use containers in production, you may be looking for a way that OpenShift might make it easier for you to deploy your applications, which brings me to a tool that is developed by Red Hat called Source to Image. And what that is basically a set of builder containers that are made in a lot of popular languages, and you can add your own languages if you would like. The documentation is pretty good about that, where you can just point OpenShift at a repository of code, and then it will take your code, containerize it, and deploy it to OpenShift and provide you with a link all in one go. And if you're familiar with Kubernetes, you realize that does take a lot more steps than that. And Kubernetes by itself doesn't have a way to build your container images. And that's something that OpenShift provides. So let's go ahead and get that going. So the first thing we want to do is switch over to our developer perspective. And when you're in the developer perspective, you don't see as much of the information that we saw before. Our topology right here, it shows as empty because there's no workloads found, but we're going to change that. We're going to want to select creating a project. If you're familiar with Kubernetes, there's a concept of namespaces, and projects are namespaces with a few extra features that make them better for the use for use with Kubernetes or with OpenShift. So I'm going to create a project. What do we call it here? Example health. So I'm just going to copy and paste this here. Create that project. We're going to give it that same name, example health. And now we see that we're in the context of example health. OpenShift uses OpenShift to deploy OpenShift. It's all Kubernetes all the way down. So you'll see all of the namespaces that are created that make OpenShift run. And then the ones that we define, you'll see that the default one is there for you, and then whatever ones you create on top of that. The next step that we want to create is we're going to use the builder images, the source image, like I said. So we're going to point our cluster at a Git repo. So from Git, I'm going to grab the URL that we're going to use, and you can check out this GitHub repository of the application and see what it is that we're deploying. It's a simple Node.js application that would be a sort of front end for a health app. It's all generated data. There's no one's actual like medical information in here. Don't worry. And then we're going to navigate to the repository path. We're going to look at the advanced options. And the actual application that we're deploying here is this node source to image OpenShift master. So we're going to drop that in the context directory so it knows exactly where to look in our repository to build our application. And then we're using a Node.js builder image. Node.js builder image, and we want to change the application name to patient UI. This is going to make it easier for us later to know like where this is the front end of the application, and in later labs there's the back end as well that you can deploy, and it shows you how to manipulate those separately. So I'd encourage you to check that out if you do want to look at how this application is built and how to do these examples in your demo OpenShift cluster. And then we're going to hit create at the bottom of the application page. And you see this box checked, create a route to the application, which is what will automatically give you the URL to hit whenever you deploy. So we hit create and we get taken to our topology window. This is what it looks like. And we see that this build is pending, and we can get some more information about it by clicking on it. What we see is that at first it just tried to pull the image, checked if it was in our container registry, which it's not. So it has to build it. So we see that build 1 is running. Let me jump back, make sure there's nothing else that I'm supposed to point out here. Yeah, so what you see at the top are the pods. Is trying to create the pods for each of your containers. So the way that, so containers at their core are processes that are running in isolation. And with Kubernetes and with OpenShift, we don't talk in terms of containers necessarily, we talk in terms of pods. So you can think of pods as a group of one or more containers that are running in isolation. And if they're running together in the same pod, then they're going to be some tightly coupled resources. The next thing you see is the build. So we have the build 1 that's already complete. We have services. If you're familiar with services, it's essentially a way for us to route traffic to our pods. And then we have routes, which is the public URL that we want to hit. And while I was giving that explanation, you could see that our circle here turned blue and the application itself is running. And we can either hit this button here or hit the route itself to see our application running in production. So that was it. It was like we had our Node.js application that was built. I entered some information about it and pointed the URL to it. And while I was explaining the outlay of it, we see that the layout of the topology view, we see that our application has already built and deployed. This is just a sample login. So whatever you enter here will work. So I just put test and sign in. Don't save that. And you can see the information here. This is our application. And it's just like especially if you've never used something like Kubernetes before, or even having not used containers before, like this is just a pretty quick way of being able to take an application that you've already built, get it deployed in a secure cloud native way. So the next thing that I'd like to point out for you is that there is a CLI that's available as well. So it's not all just using the beautiful UI that you have there, that you can totally customize the dashboard. All the tools are there for you to be able to do that, so you can see what information you'd like. But if you're working more with from a shelled into the resource, the CLI is there for you. If you're familiar with Kubernetes, you might have seen the kubectl, kubectl, kubecontrol, however you want to say it, command used. And OC is the OpenShift CLI, and it extends the ability of kubectl to be able to address OpenShift specific things. But you can say, like, if you know the kubectl command, you can use OC and it'll still work. Okay, so in the lab, we simplified the process. So you can log into your cluster by clicking here. These are all of the things that are pertinent to my cluster because it knows like from what it's set up in the background. And you'll see a success message. Git nodes will tell you about the actual hardware that your cluster is running on. So we have 2 nodes here. And we can see the IP addresses of the nodes, see what status they're in, how long they've been spinning, what version they're running, everything that we need to know there. And then if you want to see all of the services, all the deployments, and all the pods that are currently running on your cluster, you can hit this button here to OC get services, deployments, pods, all namespaces. And we talked about namespaces and projects. Again, these are like projects are just namespaces with a few extra features added in. And since our terminals got a little cluttered, we can just clear it out there and OC get projects. And I mentioned before that, you know, OpenShift uses OpenShift to deploy itself. So all of the same resilience that you get from OpenShift's deployments are there for your applications as well in case something crashes or fails. the same way that the entire cluster doesn't fall over when a small component does, you can design your applications to do the same thing here with OpenShift. And we can see this example health one that we created just a moment ago. If we want to target that project, we just say OC project example health. And it tells us that we're now using that project, so we're in that context. And we can also get the routes that are associated with that project. So this is that URL that I was saying before that I hit to show the actual application that was running. So in the next exercise, we want to look at like logs and events. And so we need to create some work for our cluster to be doing. So we're going to add another terminal here, and we're going to send it an infinite loop that's just going to be querying information so that we can actually see work being done on the cluster. So we're going to simulate a load this way. And while the output is ticking, we know our cluster is getting hit. So the next thing we want to do is have a look at the logs. So out of the box, this is what's available in OpenShift, and you can add in different operators, different software suites to extend that even more if you would like. So in our topology, we're going to look at our pods and then look at our logs, and it's going to show us the load over time. So jump back to our topology, look at our pods, and we're going to see that, look at our logs, and we'll see each time our infinite while loop hits our infinite loop hits the endpoint, we get a little ticker here in our log that tells us, oh, hey, we got hit for information. The other thing that we want to look at are the events tab, which tells us chronologically what's happened over the course of our application deploying. So you always have like some source of truth of like how this whole thing has been going on. And, we can see that, the pod was successfully assigned, and then it pulled the image, started the container, and then started the container again. We must have changed something or something changed, and so it spun up another container. Oh no, that's the route. Sorry. So we got the application running, and then we got the service and the route running. So the events view is useful for identifying the timeline of events and finding potential error messages when the state of a new rollout, when tracking the state of a new rollout, managing existing assets, or even something simple like exposing a route. The events view is critical in identifying the timeline of activity. So let's look at what metrics and dashboards are available as well. And for this, we have to switch back to our admin view, our admin context. And then we're going to look at our monitoring and our dashboards. And if you're familiar with working with Grafana, we're looking at the wrong, let's look at our compute resources pods and look at the example health one. So this is over time, what happened. Like we initially created the pod here about 5 minutes ago, and then we started hitting the infinite loop about 4 minutes ago, and we see the CPU usage spike because it's answering all of these requests. And our memory usage jumped up, and then pretty much everything is cached, so we don't have to worry about that. But you get as much information as you would like, and all of this is being fed to Grafana by Prometheus. If you're more comfortable looking at a view like that, you can look at the Grafana UI here, log in with your OpenShift credentials, and then you'll see the more traditional Grafana outputs, and you can make your own dashboards if that's something that you like to do, or maybe you have your own that you want to bring in for monitoring Kubernetes. But yeah, we can look at the same thing here, and then look at our example health namespace, and we get the same information. And all of that is out of the box with OpenShift, that you would have to do some configuration and monitoring and management to be able to do with Kubernetes. So everything is just kind of there for you. Also shipping with it is Alert Manager. So you can use Prometheus to set up alerts, set up queries, custom alerts for anything that you'd like to do. But the really interesting thing that I like with OpenShift is how intuitive it is for us to scale our applications depending on load. So we can imagine that we're looking for elasticity with Kubernetes. If we have a lot of traffic come in, we want to be able to scale our application up. And when that traffic dies down, we want to be able to scale it down. So we're looking at that ability to do that. And our horizontal scaler that we have in OpenShift makes that really straightforward. Now we're going to dig into a little bit of YAML, but it's okay. We have everything here for you that you can copy and paste. So there's less of a concern of messing things up. So from the admin perspective, we want to go look at our deployments, which manages our application, like manages the pods that are out in the world. And we're going to look at our patient UI deployment, and then we're going to edit that deployment. So let's go do that. So if we go, oh, no, it was under workloads there. I closed it. Workloads, deployments. We're going to look at our deployment here, and we're going to take the action to edit our deployment. And then we get to this YAML tab. It's color coded. There's a little bit of linting there for you if you make a mistake. So yeah, don't worry. We'll look down as well in the YAML editor at line 46. We'll see the resources, and we want to set some resource limits per pod. So let's just copy this here so that we don't mess up the indentation. So line 46, we're going to replace that with that block of text. We're going to save it. An error. So I made a mistake with my YAML. What did I do? Oh, this line came out and it wasn't supposed to. So that's my bad. That should be at that level. Save it. Okay, good. Reload. So if you make a mistake, it catches it there, tells you something's wrong. Just take a close look at it. Make sure you didn't make the same mistake that I did. And then, you should be all good. So we saved and reloaded that to see the new version. And we can look at our events to verify that our replication controller has been changed. And our replication controller is what's responsible for us spinning up new copies or spinning up just copies of our pods. And if we look at our events, we'll be able to see that that's been updated. So let's go to our events and see, created a container, deployment. So it scaled down our replica set. It deleted the pod that was running, stopped that container, and it's gonna, before it did that though, it spun up all the new ones. So let's go a little bit further back in time. Let's see. Yeah, so we've got a new replica set coming up, deleting the pod, scaling up to 1. So that's creating that new one a minute ago. So we took the new deployment and made a new pod that follows those rules. Once that pod was healthy and up and running, then we started scaling down the other one. So once we successfully pulled the image and started the container, then we scaled down the old one. So that's like that process of like the application never going down as we're updating it. And then what we're going to see is that when we have the resource limits in place, we can set up an autoscaler. So we're going to look at our workloads deployments and look at what the deployment says, how many pods there are. We're going to set up our horizontal pod autoscaler. Let's get to that point and then we'll come back here. So we want to look at our deployments. And then we're going to look at our horizontal pod auto. So like in the deployment, if I click this up button here, it will give me a second pod. But we don't want to just be sitting here watching that. It's like, oh, the application seems like it's overloaded. Let's add a bunch more pods. So for now, I'm just going to leave it at 1, and we're going to have everything set up to do that for us. So when we create a new horizontal pod autoscaler, we're going to need some more YAML, but don't worry, we've already got the YAML created for you. We're going to copy this whole block and just replace everything. Take note of the values we're setting for the minimum replicas, the maximum replicas, and the target average utilization for CPU. The value is artificially low, but it'll allow us to see some scaling go into effect, provided our traffic script is still running. So we're not seeing a lot of traffic, so we want to set that bar a little bit low so we're actually seeing what we're intending to see. So I'm going to jump back over to here, paste in our new YAML, create that horizontal pod autoscaler, and we're going to watch it work. So it'll take a little while automatically. But if we look at our, if we go back to our deployments page, we'll see that there's one pod running now, and we'll just let this tick over for a little bit until more pods are created to handle the workload that we've already got going from that infinite loop. That just make sure that's still running. Yep, that's still running, still hitting that. So yeah, after a little while, we'll see that we'll see that go up. While we're waiting for this to take place, do we have any questions that that folks have about this whole thing, about how it's going? Or any questions about OpenShift or Kubernetes in general that I might be able to answer?
En die zijn er niet.
You don't? Okay.
Oh.
Well, of course, this is a mini Azure community that you're giving this session to.
I'm sorry, I can't hear what you're saying. So what's that?
Is your mic on, right? Now, I think we're having some sound issues here.
Okay.
But there are no specific questions at this time.
Okay.
I'm just checking the sound, yeah.
All right. No worries. Okay, I just flipped back over to the page, and you can see now that 4 pods are running. If you caught it, it said 1 and it was creating 4, or creating 3 more, and it automatically scaled up to 4. And now it's seeing there's even more load that the 4 pods can't handle, so now it's scaling up to 8. And we set a max of 10, so it won't scale up past 10. But if we look back at our dashboard, we can see more pods coming up in our namespace to handle the load, to handle the limits that we set. So more and more pods are spinning up that are replicating the same application to spread out the load, and Kubernetes is handling the load balancing between the pods to be able to give, does it round robin, but to make sure that it, and that's configurable, but making sure that each pod is handling a good amount of traffic for what it can do. And we're all the way up to the max 10 pods. So essentially what we wanted to cover was to give you an introduction of being able to run Kubernetes with OpenShift. So Kubernetes being this big monster that can do so many things, but a lot of times it can be overwhelming. And sometimes we're looking for a more platform solution to be able to handle our application deployments. And that's where OpenShift can come in for you if that's what you're looking for. We took an application, we deployed it using source to image, so we didn't actually have to create our containers. But if you already have container images that you want to bring in,